auto-use limitations would be one of many other things that correct that error. So when maybe or somebody else creates an AI system, ask her one question. What would that question be? What's outside this? Don, thank you so much for talking. Pleasure. All right. Following conversation about the author of the popular text about deep learning titled Learning, coined the term object neural network, otherwise known as GANs, and with his 2014 paper is responsible for launching incredible growth of research innovation. Got his BS&MS Stanford, University of Montreal, Joshua Benjo, Aaron Kerbo. Held several including OpenAI, Brain, and now at Apple, director of machine learning. Learning happened for years. Don't talk about any Google or any other organization. This conversation is part of the Artificial Intelligence Podcast. Subscribe on YouTube, iTunes, connect with me on Twitter at Lex, spelled F-R-I-D. Now, here's my conversation. So, open your popular deep learning book with a Russian doll type diagram that shows deep learning that represents learning with terms of deep learning and finally instead of AI. So this kind of implies that there may be limits to deep learning context of AI. So what do you think is the current limits to deep learning? Are those limits that overcome time?
Yeah, I think one of the biggest limitations of deep learning is that right now it requires really a lot of data, especially with labeled data. There are some unsupervised and semi-supervised learning algorithms that can come out of labeled data, but they still require a lot of unlabeled data. Reinforcement learning algorithms, they don't need labels, but they need really a lot of experience. As human beings, we don't want to play Pong by failing at Pong 2 million times. So just getting the generalization better is one of the most important bottlenecks of technology today. And then I guess I'd also say deep learning is like a component of a bigger system. So far, nobody is really proposing to have only what you'd call deep learning as the entire ingredient of deep learning as sub-modules of other systems. Like AlphaGo has a deep learning model that estimates the value function. Most reinforcement learning algorithms have a deep learning module that estimates which action is X, but you might have other components. You're basically building a function estimator. I think it's possible to kind of about this so far, but do you think neural networks noise bogs more like programs as opposed to functions? Yeah, I think we already see that a little bit. I already kind of think of neural nets as a kind of a program. I think of deep learning as basically learning programs that have more than one step. So if you draw a flowchart or if you draw a TensorFlow graph describing your machine learning model, I think of the depth of that graph as describing the number of steps that run in sequence, and then the width of that graph, the number of steps that run in parallel. Now it's been long enough that we've had deep learning working that it's a little bit learning anymore. But back when I first got involved in AI, when we used machine learning, we were using deep learning work vector. You can have a lot of input features to the model. You can multiply each feature by a different weight. All those multiplications are done in parallel there wasn't a lot done in space. I think the got with deep learning was really the ability to have uh, steps of a program that run in. And I think that we've actually started to see that what's important with deep learning is more the fact that we have a multi-step program rather than the fact that we learn to represent. If you look at things like ResNets, for example, they take one particular kind of representation and they update it several times. Back when deep learning first really took off in the academic world in 2006, when Jeff Hinton showed that you can train deep belief networks, everybody who was interested in the idea thought of it as each layer learns a different level of abstraction. The first layer trained on images learns something like learns corners, and eventually you can kind of grandmother cell units that recognize objects. Today, I think most people think of it more as a computer program where as you add more layers, you can do more updates before you output your number. So I don't think anybody the layer 150 of the ResNet layer 100.
So you're not thinking of the representation. Think of it program sort of like a state representation state of understanding.
Yeah, I think of it as a program that makes several updates, arrives at better and better understandings, but it's not replacing the representation, refining it. And in some sense, that's a little bit like reasoning. It's not reasoning in the form of deduction, it's reasoning in the form of taking a thought and refining it carefully until it's good enough to use.
I hope you don't mind, we'll jump thoughtful every once in a while. Do you think of cognition consciousness simply a result of kind of sequential representation? Do you think that can emerge?
Cognition, yes. So consciousness is really hard to even define what we mean by that, because there's consciousness is often defined as having self-awareness, and that's relatively easy to turn into something actionable for a computer scientist to think about. People also define consciousness in terms of having qualitative states, like qualia, and there's all these philosophical problems that you imagine a zombie who does all the same information processing, but doesn't really have the qualitative experiences you have. That sort of thing, I have no idea how to formalize or turn it into a scientific. I don't know how you can experiment to tell whether a person is healthy or not. Similarly, I don't know how you could run an experiment to tell whether an advanced AI system become conscious quality or not.
But it's more practical sense, like almost like something think in an impressive way from types of architecture.
Yeah, so, yeah. Or if you think of consciousness as self-awareness and just making plans based on the fact that the agent itself exists in the world, reinforcement learning algorithms are already more or less to model the agent's effect on the environment. So that more limited version of consciousness is already something that we get limited versions of with reinforcement learning algorithms and trained wells.
But limited. The big question really is how you come from limited level,
yeah,
right? And whether it's possible. You know, even in common sense, scale things up, get better on supervised learning, to get better at labeling data sets, more compute. I think we'll start to see really impressive things that go from limited, echoes at levels.
I think so. Yeah, I'm optimistic about what can happen for computation and more data. I do think it'll be important to get the right kind of data. Today, most of the machine learning systems we train are mostly trained on one type of data. But the human brain, we get all of our different senses. We have many different experiences, like riding a bike, driving a car, talking, reading. I think when you get that kind of integrated data set working with a machine learning model that can actually close the loop and interact, we may find that algorithms not so different from what we have learn really interesting things. So you pick them up a lot. On a large amount of multimodal data.
Multimodal relation. So within, if you're working, collecting within one mode of data, collecting better cases to learn from.
Oh yeah, like could we get a whole lot of money out of designing a model that's adversarially simple, like that, right? Yeah. My thinking on that has evolved a lot over the last few years. When I first started to really invest in studying adversarial examples, I was thinking mostly as adversarial examples problem with machine learning and like the gap in how machine learning models respond to adversarial examples of humans. After studying the problem more, I think that I think of it now more of as a ability than as a fairly something uniquely wrong machine learning.
Also, tools to improve the performance, not on the security side, but literally.
I do as a kind of tool on that side, but maybe not quite as much as I've started to find a bit of a trade-off between accuracy and adversarial tools. Accuracy. Back in 2014, when I did the first adversarially trained classifier that showed resistance to some kinds of adversarial examples, it also got better at the ethics. And that's something we've replicated several times. And when we train against adversarial examples, and this classifier is getting more accurate, but it hasn't really held up on other data sets, and hasn't held up when you train against stronger adversaries. Like when you confront a really strong adversary, you tend to have to gap.
But like that's how us learn.
Yeah. We try to think of what would we screw up, and then we make sure that. Yeah. It's also in a lot of branches of engineering, you do a worst case analysis and make sure that your system will work in the worst case. And then that guarantees that it'll work in all of the messy average cases. You got into a really randomized world.
You know, driving with autonomous vehicles, there's a desire to look for, think adversarially, try to figure out how to mess up, be robust to all those different cases. The hand wavy spherical way to show.
Yeah. Today, most adversarial example research is really focused on their use case, but there are a lot of different use cases where you'd like to make sure that the adversary can't interfere with the operation of your system. Like in finance, if you have an algorithm making trades for you, people go to a lot of effort to obfuscate their algorithm. That's both to protect their IP because you don't want to research and develop a profitable trading algorithm and have somebody else capture the game. But it's at least partly because you don't want people to make adversarial examples that fool your algorithm into making bad trades. Or I guess one area that's been popular in the academic literature is speech recognition. If you use speech recognition to hear an audio waveform and then turn that into the phone you don't want an audio that gets interpreted as especially if the human in the room doesn't realize that something like that is
Recognition. Being able to example.
Yeah, actually, I guess the first work that I'm aware of is a paper called Voice Command that came out in 2016, and they were able to show that they could make sounds that are not understandable by a human, but are recognized as the target phrase that the attacker wants the phone. And things have gotten a little bit better on the attacker side and on the defender side. It's become possible to make sounds that sound like normal speech, but are actually interpreted as a different sentence from the human. The level of perceptibility of the adversarial perturbation is still kind of high. When you listen to the recording, it sounds like some noise interruption. Like rustling sounds are actually the adverse.
You know, Rick mentioned writing learning chapter of the artificial intelligence on the book. So, how do you summarizing the deep learning in a chapter?
Well, in my case, I waited like a year before I actually wrote it. Because, even having written a full-length textbook before, it's still pretty intimidating to try to start writing just one chapter that covers everything. One thing that helped me make that plan was actually the experience of having written the full book before, and then watching how this changed. You know, I realized there's a lot of topics where maybe bringing it first and just seeing what stood the test of a few years of being published and what seems a little bit less important to it now helped me pare down the topics I covered for the book. It's also really nice now that the field is kind of stabilized to the point where some core ideas from the 1980s when I first started studying machine learning, almost everything from the 1980s had been rejected, and now some of it has come back. So that stuff that's really stood the test of time is what I focused on putting into the book. There was also, I guess, two different philosophies about how you might write a book. One philosophy is you try to write a reference that covers everything. The other philosophy is you try to provide a high-level summary that gives people the language and what the important concepts are. The first deep learning book that I wrote with Joshua and Aaron was somewhere between the two philosophies, trying to be both a reference and an introductory guide. Writing this chapter for Russell and Norvik's book, I was able to focus more on the concise introduction of the key concepts and the language you need to think about them more. In a lot of cases, I actually just wrote paragraphs. But here's a rapidly evolving area that you need to pay attention to. It's pointless to try to tell you what the latest and best version of learn to learn model is. I can point you to a paper that's recent right now, but there isn't a whole lot of a reason to delve into exactly what's going on with the latest learning to learn approach or the latest module produced by a learning to learn algorithm. You should know that learning to learn is a thing and that it may very well be the source of the latest and greatest convolution or recurrent net module that's your latest project. But there isn't a lot of trying to summarize exactly which architecture and which learning approach happens at the whole.
Do you maybe focus more on the methodology, so from propagation forward, neural network, that kind of thing?
Yeah, yeah.
So if I were to ask you, I remember I took algorithms. Remember the professor asked, "What is an algorithm?" And yelled at everybody in a good way. Answer. Everybody knew what graduate algorithm was. Let me ask you, in that same spirit, what is learning?
I would say deep learning is any kind of machine learning learning parameters that more than one consecutive step. So that means shallow learning is things where you learn a lot of operations that happen in parallel. You might have a system that makes stuff. You might have 10 designed feature extractors, but really only one step is learned. Deep learning is anything where you have multiple operations. And that includes things that are really popular today, like convolutional networks and recurrent networks. But it also includes some of the things that died out, like pulsing machines, where we weren't using backpropagation. Today, I hear a lot of people define deep learning as gradient descent applied to these differentiable functions. And I think that's a legitimate usage of the term. It's just different from the way that I use the term.
Example of learning that is not gradient differential function. That here, I mean, not specifically perhaps, but more looking here. What's your thought about that space of approach?
Yeah, so I tend to think of machine learning algorithms as decomposed into really three different pieces. take parameters and what function do you use to make a prediction given the data and the parameters. Another piece of the learning algorithm is the optimization, or not every algorithm can be really described in optimization. What's the algorithm for updating the parameters or updating whatever the state of the and then the last part is how do you actually represent the work that comes into your system. I think of deep learning as calling it something about what does the model look like, and basically to qualify as deep, I say that it just has to have multiple layers. That can be multiple steps in forward differential computation. That can be multiple layers in the graphical model. There's a lot of ways to do satisfying that something has multiple steps that are parameterized separately. I think of gradient descent as being all about that other, how do you actually update it? You can imagine having a deep model, like a convolutional net, and training it with something like evolution or a genetic algorithm. And I would say that's what qualifies as deep learning. And then in terms of models that aren't necessarily differentiable, I guess machines are probably the main example of something where you can't really take a derivative in that process. But you can still argue that the model has many steps of processing that it applies when you run it for the model.
Yes, the totally back propagation, start all over. You think about that in an alternative direction on that one.
I don't know that backpropagation is going to go away entirely. Most of the time when we decide that a machine learning algorithm isn't on the critical path to research for improving AI, the algorithm doesn't die, it just becomes some specialized set of things. A lot of algorithms like logistic regression don't seem that exciting to AI researchers who are working on things like speech recognition or autonomous cars today. But there's still a lot of use for logistic regression, things like analyzing really noisy data in medicine and finance, or making really rapid predictions in implementing contexts. So I think backpropagation gradients are around today, but they may not end up being everything that we need to get to real human level or super AI.
Are you optimistic about us discovering, backpropagation has been around for decades? So, are you optimistic about us really discover something better?
Yeah, I am. I think we likely will find something that works better. You could imagine things like having stacks of models where some of the lower level models predict parameters of the higher level models, and so at the top level you're not learning in terms of literally calculating, predicting how different values perform. You can kind of see that already in some areas like Bayesian optimization. You have a Gaussian process that predicts how well different parameter values will perform. We already use those kinds of algorithms for things like hyperparameter optimization, and in general we know a lot of things other than backprop work really well for specific problems. The main thing we haven't found is a way of taking one of these other non-backprop-based algorithms and having it really advance state-of-the-art on an AI level problem. Right. But I wouldn't be surprised if we find that some of these algorithms that, even the ones that already exist, not even necessarily new ones, we might find some way of customizing one of these algorithms to do something really interesting at the level of cognition or the level of I think one system that we really don't have working quite right yet is like short-term memory. We have things like LSTMs, they're called long short-term memory. They still don't do quite what a human does, short-term memory. Like gradient descent to learn a specific fact has to do multiple steps on that fact. Like if I tell you the meeting today is at 3 p.m., I don't need to say over and over again, it's at 3 p.m., 3 p.m., 3 p.m., 3 p.m.
Right.
For you to do a gradient descent, but you just hear it once and you remember it. There's been some work on things like self-attention and attention-like mechanisms, neural Turing machines that can write to memory cells and update themselves with facts like that right away. But I don't think we've really nailed it. And that's one area where I'd imagine imagine that new optimization algorithms or different ways of applying existing optimization algorithms could give us a way of lightning fast updating of a machine learning system in a specific firewall.
That's is they were able to assemble facts better. It's a lot of expert input required. If you ever look back to that, some people will have to turn to the stuff, build knowledge, representation knowledge.
Like, will they have to use graph search and like first order logic entailment and things like that? In my particular line of work, which has mostly been machine learning security and also generative modeling, I haven't usually found myself moving in that direction. For generative models, I could see a little bit of it could be useful if you had something like a differentiable knowledge base or some other kind of knowledge base where it's possible for some of our fuzzier machine learning algorithms to interact with the knowledge base.
And neural network kind of like that is differential.
Yeah.
But
if we had a really easy way of giving feedback to machine learning models, that would clearly help a lot with generative models. You can imagine one way of getting there get a lot better at natural processing. But another way of getting there would be take some kind of knowledge base and figure out a way for it to actually interact with the network.
being able to chat with
Yeah. So like one thing in generative models, you'll get things like faces that are not symmetrical, like people that have two eyes that are different colors. And I mean, there are people with eyes that are different colors in real life, but not nearly as many of them as you tend to see in the machine learning generated data. So if you had either a knowledge base that could contain the fact people's faces are generally approximately symmetric, and eye color is especially likely to be the same on both sides, being able to just inject that hint into the machine learning model without it having to discover that itself after studying a lot of data would be a really useful feature. I could see a lot of ways of getting there without bringing back some of the 1980s technology, but I also see some ways that you could imagine extending the 1980s technology to play nice neural net.
Awesome. So you talked about the story of you coming up with the idea of GANs at a bar with friends. You were arguing that the GANs would work better at the networks, and the other didn't think so. Went home midnight, put it up, and it worked. So if I was a friend of yours at the bar, I would have a really nice idea. I'm very skeptical that it would work. What was the basis of their skepticism? What was the basis of why?
I don't want to be because I'm promoting alcohol for the purposes of science, but in this case, I do actually think that drinking helps a little bit. When your inhibitions are lowered, you're more willing to try out things that you wouldn't try out otherwise. So I have noticed in general that I'm less prone to shooting down some of my ideas when I have had a little bit of drink. I think if I had had that idea at lunchtime, I probably would have thought. It's hard enough to train one neural net. You can't train a second neural net in the inner loop of the outer neural net. That was basically my friend's objection. Trying to train would be too hard.
So it was more about the training process and less skepticism. Sure, you could train it, but the thing would converge to not be able to generate any kind of
Yeah. So part of what all of us were thinking about when we had this conversation was, which a lot of us in the lab, including me, were a big fan of default solutions. They involved two separate processes running at the same time. One of them is called the positive phase, where you load data into the model and tell the model to make the data more likely. The other one is called the negative phase, where you draw samples from the model and tell the model to make those samples less likely. In a deep pulsing machine, it's not trivial to generate a sample. You have to actually run an iterative process that gets better and better samples coming closer and closer to the distribution the model represents. So during the training process, you're always running these two systems at the same time. One that's updating the parameters of the model, model and another one that's trying to generate samples. And they worked really well on things like that. But a lot of us in the lab, including me, had tried to get people to scale past MNIST to things like generating color photos, and we just couldn't get the process to stay synchronized. When I had the idea for GANs, a lot of people thought that the discriminator would have more or less the same problem as the negative phase in the machine. That trying to train the discriminator in the inner loop, you just couldn't get that with the generator in the outer loop, and that would prevent it from converging to.
I share that interest.
Yeah.
But turns out to not be the case.
A lot of the time with machine learning algorithms, it's really hard to predict ahead of time how well they'll actually perform. You have to just run the experiment and see what happens. And I would say I still today don't have like one factor I can put my finger on and say that I can work for photo. There are a lot of theory papers showing that under some theoretical settings, the GAN algorithm does actually converge, but those settings are restricted enough that they don't necessarily explain the whole picture.
So taking a step back, as we talked about learning, tell me what generative adversarial networks are.
So generative adversarial networks are a particular kind of generative model. A generative model is a machine learning model that can train on some set of data, like say you have a collection of photos of cats, and you want to generate more photos of cats, or you want to estimate a probability to discover cats, how likely it is to image a photo of a cat. GANs are one way of doing this. Some generative models are good at creating new data. Other generative models are good at estimating that density function, telling you how likely particular data are to come from the distribution as a training. GANs are more focused on generating samples rather than estimating the density. There are some kinds of GANs, like slow GANs, that can do both, but most GANs are generating new photos of cats. And they do that from scratch. It's analogous to human imagination. The GAN creates a cat. It's using a neural network to produce a cat that has not existed before. Doing something like positing photos together. Not literally taking the eye off of one cat and the ear off of another. More of this digestive process where the neural net trains on a lot of data and comes up with some representation of the probability distribution. There are a lot of different ways of building a generative model, but specific to GANs, that we have a clear game, the game theoretic sense. And as the players in this game compete, one of them becomes able to generate realistic data. The first player is called the generator. It produces output data, such as images, for example. And at the start of the learning process, it'll produce random images. The other player is called the discriminator. The discriminator takes images as input and guesses whether they're real or fake. You train it both on real data, so photos that come from your training set, actual photos of cats, and you train it to say that those are real. You also train it on images that come from the generator, and you train it to say that those are fake. As the two players compete in the game, the discriminator tries to become better at recognizing whether images are fake, and the generator becomes better at the discriminator that its outputs are real. And you can analyze this through the language of game theory and a Nash equilibrium where the generator has captured the correct probability distribution. When the cat example, it makes perfectly realistic cat photos. And the discriminator is unable to do better than random guessing because all the samples coming from both the data and the generator look equally likely to come from.
You ever sit back and blow your mind that it works? The phone very able to make that function. Generate realistic. Yeah, do you ever sit back? Yeah, how does it and why it's quite incredible where it gets.
Yeah, and not just to flatter my own work, but generative models, all of them have this property that if they really did what we asked them to do, they would do nothing but memorize the models that are based on maximizing the way that you obtain the maximum likelihood for a training set is you assign all of your probability mass to the training set, nowhere else. For GAN, the game is played using a training set. So the way that you become thoroughly memorized. One of my former interns wrote a paper, Vaishnav Nagarajan. He showed that it's actually hard for the generator to memorize. Hard in a statistical learning theory that you can actually for why it would require quite a lot of learning and a lot of observation of different latent variables memorized. That still doesn't really explain why when you produce samples that are new, why do you get images rather than garbage? And I don't think we really have a good answer for that, especially if you think about how many possible images are out there and how few images the generative model sees that you're training. It seems just unreasonable that generative models create new images as well as they do. But especially considering that we're basically training them to memorize rather than I think part of the answer is a paper called Deep Image Prior, show that you can take a convolutional net and you don't even need to learn the parameters of it at all. You just use the model architecture. And it's already useful for things like intainting it. I think that it shows us that the convolutional network architecture captures something really important about the structure of images. And we don't need to actually use learning to capture all the information coming out of the convolutional net. That would imply that it would be much harder to make generative models than other different. So far, we're able to make reasonable speech models. But to be honest, we haven't actually explored a whole lot of different sets all that much. We don't, for example, see a lot of deep learning models of like biology data, where you have lots of microarrays measuring the amount of different enzymes, things like that. We may find some of the progress for images and speech stuff that really rely heavily on the model architecture. And we were able to do what we did for vision by trying to reverse engineer the human visual system. And maybe it'll turn out that we can't just use that same trick for arbitrary. Right, so there's that. So it's maybe a little bit easier to start with what kinds of generative models are there other than GAN. So most generative models are like how much probability it assigns to a particular example, and you just maximize the probability assigned to all the training examples. It turns out that it's hard to design a model that can create really complicated images or really complicated audio waveforms and still have it be possible to estimate the likelihood function from a computational point of view. Most interesting models that you would just write down intuitively, it turns out that it's almost impossible to calculate the amount of probability they assign to a particular. There's a few different schools of generative models in the likelihood family. One approach is to very carefully design the model so that it is computationally tractable to measure the density it assigns to a particular point. So there are things like autoregressive models, like pixel data. Those basically break down the probability distribution into a product over every single picture. So for an image, you estimate the probability of each pixel given all of the pixels that came before it. There's tricks where if you want to measure the density function, you can actually calculate the density for all these pixels more or less in parallel. Generating the image still tends to require you to go one pixel at a time, and that can be very slow. But there are, again, tricks for doing this in a hierarchical
quality of the image rates on the side.
They're reasonable, yeah. I would say a lot of the best results are from GANs these days, but it can be hard to tell how much of that is based on who's studying which type of algorithm, if that makes sense.
The amount of effort.
Yeah, or like the kind of expertise. So a lot of people who've potentially been excited about graphics or art and things like that have gotten interested in GANs. And to some extent it's hard to tell, are GANs doing better because they have a lot of graphics experts behind them, or are GANs doing better because they're more computationally efficient, or are GANs doing better because they prioritize the realism of sample over the accuracy of the function? I think all of those are potentially valid explanations. It's hard to tell.
Can you give a brief history of GANs from 2000 paper 13?
Yeah, so a few highlights. In the first paper, we showed that GANs basically work. If you look back at the samples we have now, they look terrible. On the CFAR 10 data set, you can't even...
Your paper, sorry, or
We used MNIST, which is little handwritten digit. We used the Toronto face database, small grayscale photos of faces. We did have recognizable faces. My colleague Bing Xu put together the first GAN face model for that paper. We also had the CFAR 10 data, which takes like very small 32 by 32 pictures of cars and cats and dogs. For that, we didn't get recognizable objects, but all the deep learning people back then were really used to looking at these failed samples and reading them like tea leaves.
Right.
And people who are used to reading the tea leaves recognize that our tea leaves at least look different, right? Maybe not necessarily better, but there was something unusual about them. And that got a lot of us excited. One of the next really big steps was LabScan by Emily Denton and Chintala at Facebook AI Research, where they actually got really good high-resolution photos working with GANs for the first time. They had a complicated system where they generated the image starting at low res and then scaling up to high res, but they were able to get it to work. And then 2015, I believe, later that same year, Alec Radford and Sumit Chintala and Luke Metz published the DCGAN paper. It stands for Deep Convolutional GAN. It's kind of a non-unique name because these days all GANs and even some before that were deep convolutional, but they just kind of picked a name for a really great recipe where they were able to actually, using only one model instead of a multi-step process, actually generate realistic images of faces like that. That was sort of like the beginning of the Cambrian explosion of GANs. Like, once you had animals that had a backbone, you suddenly got lots of different versions of like fish,
right,
four-legged animals and things like that. So DCGAN became kind of the backbone for many different models. Yeah, yeah. And so from there, I would say interesting things we've seen are there's a lot you can say about how just the quality of standard image generation GANs has increased. But what's also maybe more interesting on an intellectual level is how the things you can use GANs for has also changed. One thing is that you can use them to learn classifiers without having to have class labeled for every example here, your training set. So that's called semi-supervised learning. My colleague at OpenAI, Tim Solomon, at Brain now, wrote a paper called Improved Techniques for Training GANs. I'm a co-author of this paper, but I can't claim any credit for this particular part. One thing he showed in the paper is that you can take the GAN discriminator and use it as a classifier that actually tells you, this image is a cat, this image is a dog, this image is a car, this image is a truck, and so on. Not just to say whether the image is real or fake, but if it is real, to say specifically what kind of object it is. And he found that you can train these classifiers with far fewer labeling than traditional classifiers.
So you supervise also not just your discrimination, but you're really classify, you're going to faster being effective at being.
Yeah. So for example, for the MNIST data set, you want to look at an image of a handwritten digit, whether it's a 0, a 1, or a 2, and so on. To get down to less than 1% accuracy required around 60,000 examples, until maybe about 2014 or so. In 2016, with this semi-supervised GAN project, Tim was able to get below 1% error using only 100 labels. So that was about a 600x decrease in the amount of labels. He's still using more images, but he doesn't need to have each of them labeled as this one's a 1, this one's a 2, this one's a 0, and so on.
And be able to, GANs be able to recognize recognizable object, so object class still needs label data because you need to know what it means a class cat dog. How do you think we can away from that?
Yeah, some researchers at Brain Zurich actually just wrote a really great paper on semi-supervised scans where their goal is to classify its make recognizable objects by not having a lot of label data. They were working off the DeepMind's BigGAN project, and they showed that they can match the performance of BigGAN using only 10%, I believe, of the label. BigGAN was trained on the ImageNet dataset, which is about 1.2 million images, had all of them labeled. This latest project from Brain Zurich showed they're able to get away with only having about 10% of the images labeled. And they do that essentially using a clustering algorithm, where the discriminator learns to assign the object group, and then this understanding that object to similar type to form more realistic ideas of what could be occurring in the image. It knows that every image it creates has one of these archetypal rather than just some arbitrary image. If you train again with no classes, you tend to get things that look sort of like grass or water or brick or dirt, but without necessarily a lot going on. And I think that's partly because if you look at a large ImageNet image, the object doesn't necessarily occupy the whole image. So you learn to create realistic sets of pixels. You don't necessarily learn the object is the star of the show, and you want it to be an appeal.
Yeah, I've heard you talk about the force cyclical GAN mapping and how it turns out and thought-provoking that horses usually have grass and zebras are usually have dry terrain. So that kind of generation, you're going to end up generating greener horses or whatever. Those are connected together. It's not just,
Yeah.
you're not able to segment image generating segmental. So are there other types of games you come across find that neural networks can play with each other to be able to solve problems?
Yeah, the one that I spend most of my time on is in security. You can model most interactions in the game where there's attackers trying to break your system and you're the defender trying to build a resilient system. Also domain adversarial learning, which is an approach to domain adaptation that looks really a lot like GAN. The authors had the idea of a GAN paper. The paper came out a little bit later, and they're very nice and cited again, but I didn't actually have the idea of that. Domain adaptation is when you want to train a machine in one setting called a domain, and then deploy it in another domain later, and you would like it to perform well in a new domain, because the domain is different from how it was trained. So for example, you might want to train on a really clean image data set like ImageNet, but then deploy on user's phone, where the user is taking pictures in the dark, or pictures while moving quickly, and pictures that aren't really composed all that well. When you take a normal machine learning model, it often degrades really badly when you move to the new domain because it looks so different from what the model was trained on. Domain adaptation algorithms try to smooth out that gap, and the domain adversarial approach is based on training a feature extractor where the features have the same regardless of which domain you extract them from. So in the domain adversarial game, you have one player that's a feature extractor and another player that's a domain recognizer. The domain recognizer wants to look at the output of the feature extractor and guess which of the two domains the features came from. It's a lot like the real versus fake discriminator in GAN. And then the feature extractor, you can think of as loosely analogous generator in GAN. But what we're trying to do here is both the domain recognizer and not know which domain the data came from, and also extract features that are good for classification. So at the end of the day, you can, in the cases where it works out, you can actually get features that work about the same in both domains. Sometimes this has a drawback where in order to make things work the same in both domains, it just gets worse with the first one. But there are a lot of cases where it actually works out well in both.
Do you think GANs being useful in the context of motivation?
Yeah, one thing you could hope for with GAN is you could imagine I've got a limited training set and I'd like to make more training data to train something else like a classifier. You could train the GAN on the training set and then create more data, and then maybe the classifier would perform better on the test set after training on the bigger GAN. So that's the simplest version of something you might hope would work. I've never heard of that particular approach working, but I think there's some closely related things that I think could work in the future and some that actually already have worked. So if we think a little bit about what we'd be hoping for if we use the GAN to make more training data, we're hoping that the GAN will generalize to new examples better than the classifier would have generalized if it was trained on the set. And I don't know of any reason to believe that the GAN would generalize better than the classifier would. But what we might hope for is that the GAN could generalize differently from a specific classifier. So one thing I think is worth trying that I haven't personally tried but you could try is, what if you trained a whole lot of different generative models on the same training set? Create samples from all of them, and then train a classifier. Because each of the generative models might generalize in a slightly different way, it might capture many different axes of variation that the model would. And then the classifier can capture all of them by training all of them. It would be a little bit like making an ensemble of classifiers.
Ensemble of GANs.
Yeah,
in a way.
I think that could generalize better. The other thing that GANs are really good for is not necessarily generating new data that's exactly like what you already have, but by generating new data that's different from the data you already have. One thing that you can do is you can create differentially private data. Suppose that you have something like medical records, and you don't want to train a classifier on the medical records and publish the classifier, because someone might be able to reverse engineer some medical records trained on. There's a paper from Casey Green's lab that shows how you can train a GAN using differential privacy, and then the samples of the GAN still have the same differential privacy guarantee parameters of the GAN. You can make patient data for other researchers to use, and they can do almost anything they want with that data because it doesn't come from real people. And the differential privacy mechanism gives you clear guarantees on how much the original people's data has been.
Really, I haven't heard you talk about in terms of fairness. I've seen AAAI. How can adversarial machine learning models be fair? That's its variable.
Yeah, there's a paper from Amos Tversky's lab about how to learn machine learning models that are incapable of using specific variables. So say, for example, you wanted to make predictions that are not affected by gender. It isn't enough to just leave gender out of the input to the model. You can often infer gender from a lot of other characteristics, like say that you have the person's name, but you're not told their gender. Well, if their name is Ian, they're kind of obvious. So what you'd like to do is make a machine learning model that can still take in a lot of different attributes and make a really accurate, informed prediction, but be confident that it isn't reverse engineering gender or another sensitive variable internally. You can do that using something very similar to the domain adversarial approach, where you have one player that's a feature extractor and another player that's a feature analyzer. You want to make sure that the feature analyzer is not able to guess the value of the sensitive variable that you're trying to describe it.
Right, yes. Yeah, I love this approach with feature not able to infer, right? Variable.
Yeah,
brilliant. That's quite brilliant. Simple, actually.
Another way I think GANs in particular could be used for fairness would be to make something like a cycle GAN, where you can take data from one domain and convert it into another. We've seen cycle GAN turning horses into zebras. We've seen other unsupervised GANs made by Ming Yu Liu doing things like turning day photos into night photos. I think for fairness, you can imagine taking records for people in one group and transforming them into analogous people in another group and testing to see if they're treated equitably across those two groups. There's a lot of things that'd be hard to get right to make sure that the conversion process is fair, and I don't think it's anywhere near something that we could actually use yet. But if you could design that conversion process carefully, it might give you a way of doing audit where you say, what if we took people from this group, converted them into a group of people in another group? Does the system actually treat them how it ought?
That's you know, in popular press in general, in our imagination, well, cancer generate start to think about deep state, malicious generate data that the identity of others. Something something you look 10 years later, that's something that pops up work in the world.
I'm a lot less concerned about 20 years from now than the next years. I think there'll be a kind of bumpy cultural transition as people encounter this idea that there can be very realistic videos and audio that aren't real. I think 20 years from now, people will mostly understand that you should believe something is real just because you saw a video of it. People will expect it that it's been cryptographically signed, or have some other mechanism to make them believe that the content is real. There's already people working on this. Like there's a startup called TruePic that provides a lot of mechanisms for authenticating that an image is real. They're maybe not quite up to having a state actor try to invade their verification techniques, but it's something that people are already working on, and I think we'll get right eventually.
Think authentication eventually without being able to authenticate it to
Yeah.
as opposed to again just better and better, or generative models being able to do better and better to learn the nature of
I don't think we'll ever be able to look at the photo and tell you for sure that it's real or not real, and I think it would actually be somewhat dangerous to rely on that approach too much. If you make a really good fake detector and then someone's able to fool your fake detector and your fake detector says it's not fake, then it's even more credible than if you never made a fake detector in the first place. What I do think we get to is systems that we can kind of use behind the scenes to make estimates of what's going on and maybe not like in court for a definitive analysis. I also think we will likely get better authentication systems where, imagine that every phone graphically signs everything that comes out of it. You wouldn't be able to conclusively tell that an image was real. You would be able to tell um, somebody who knew the appropriate private key for this phone was actually able to sign this image and upload it to the server at this time. Uh, you could imagine maybe you make phones that have the private keys hardware embedded in them. If like a state security agency really wants to infiltrate the company, they can probably plant a private key of their choice or break open the chip and learn the private key or something like that. But it would make it a lot harder for an adversary with fewer resources to make things.
so you mentioned beer and the bar and new ideas. You were able to come up with this new idea pretty quickly and implement it pretty quickly. I think there's still groundbreaking learning results.
Yeah, I do think that there are a lot of ideas that Jans were probably a little bit of an outlier on the whole like 1 hour time scale, but just sort of like low resource ideas where you do something really different on the algorithm scale and get a big payback. I think it's not as likely that you'll see that in terms of things like core machine learning technologies, like a better classifier or a better reinforcement learning algorithm or a better generative model. Um, if I had the GAN idea today, it would be a lot harder to prove that it was useful than it was back in 2014 because I would need to get it running on something like ImageNet or CellObA at high resolution. Those take a while to train. You couldn't train it in an hour and know that it was something really new and exciting. Back in 2014, training an MNIST was nuts. But there are other areas of machine learning where I think a new idea could actually be developed really quickly with low resources.
What's your intuition about what areas are right?
Yeah, so I think fairness and interpretability are areas where we just really don't have any idea how anything should be done yet. Like for interpretability, I don't think we use the right definition. And even just finding a concept, you don't even need to run any experiments. It could have a huge impact in the field. We've seen that, for example, in differential privacy, that work and her collaborators made this technical definition of privacy, where before a lot of things were really mushy, and then with that definition, you could actually design randomized algorithms for accessing databases and guarantee that they preserve individual people's privacy in like a mathematical quantitative sense. Right now, we all talk a lot about how interpretable algorithms are, but it's really just people, and everybody probably has a different idea of what interpretability means. If you could define some concept related to interpretability, that would be a huge leap forward, even without a new algorithm that increases that quantity. And also, once we had the definition of differential privacy, it was fast to get the algorithm to turn. So you could imagine once we have definitions of concepts of interpretability, we might be able to provide the algorithms that have the interpretability too.
What do you think takes some level of intelligence to be trained?
Yeah, I think that it definitely takes a better environment than we currently have for training agents. So we want them to have a really wide diversity of experience. I also think it's going to take really a lot of computation. It's hard to imagine exactly how much.
You're optimistic about simulating a variety of environments path forward?
I think it's a necessary ingredient. Yeah, I don't think that we're going to get to artificial general intelligence by training on fixed data sets or by thinking really hard about them. I think that the agent really needs to interact and have a variety of experiences within the same lifespan. And today we have many different models that can teach one thing, and we tend to train them on one data set or one RL environment. Sometimes there are actually papers about getting one set of parameters that perform well in many different RL environments, but we don't really have anything like an agent that goes seamlessly from one type of experience to another and really integrate all the different things it does. We do see multi-agent environments. They tend to be, there's many multi-environment agents tend to be similar environments. Like all of them are playing like an action-based game. We don't really have an agent that goes from playing a video game to like reading the Wall Street Journal to predicting how effective a molecule will be in drivers.
What do you think is a good test for intelligence? Benchmarks started with the Turing natural computation benchmark intelligence. What would being good back and really damn impressed?
Something that doesn't take a lot of human engineering. So imagine that instead of having to go to the CFAR website and download CFAR 10 and then write a Python script to parse it and all that, you could just point an agent at the CFAR 10 problem and it downloads and extracts the data and trains a model and starts doing prediction. I feel like something that doesn't need to have every step of the pipeline assembled for it definitely understands what it's doing.
AutoML moves that direction.
AutoML has mostly been moving toward once we've built all the machine learning system, design the architecture really well. And so I'm more saying like if something knows how to pre-process the data so that it successfully accomplishes the task, then it would be very hard to argue that it doesn't truly understand the in some fundamental sense. And I don't necessarily know that that's like the philosophical definition of intelligence, but it's something that would be really cool to build, that would be really useful, and would impress me, and would convince me that we've made a step forward in real AI.
So you give it like URL for Wikipedia, and then next day expect it to be able to solve or that.
Or like you type in a paragraph explaining what you want it to do, and it figures out what web searches it should run and downloads all the necessary ingredients.
So you have a very clear, calm way of seeing how this is headed. I've seen comments for both you and I have been identified as both potentially robots. And if you have to prove to the world that you aren't,
But I can understand thinking that I'm a robot.
it's the flip side of the
Yeah.
Turing test.
Yeah, the prove you're human.
Intellectually, so you have to. Is there something that's truly in your mind? Does it go back to natural?
So proving that I'm not a robot with today's technology, yeah, that's pretty straightforward. Like my conversation today hasn't veered off, you know, talking about the stock market or something because of my training data. But I guess more generally, trying to prove that something is real content alone is incredibly hard. That's one of the main things I found out of my GAN research. That you can simulate almost anything. You have to really step back and separate to prove that something is real. So like, I guess I should have had myself stamped on a blockchain when I was born or something, but I didn't. So, according to my own research methodology, there's no way to know this.
So what last question problem stands out for you that you're really excited about challenging here?
I think resisting adversarial examples, figuring out how to make machine learning secure against an adversary who wants to interfere it and control it, is one of the most important things.
All domains, language, driving,
I guess I'm most concerned about domains we haven't really encountered yet. Like imagine 20 years from now when we're using advanced AIs to do things we haven't even thought of yet. Like if you ask people, what are the important problems in the community of phones in like 2000, I don't think we would have anticipated that we're using them for nearly as many things as we're using for today. I think it's going to be like that with AI, that you can kind of try to speculate about where it's going, but really the business opportunities that end up taking off would be hard to predict ahead of time. What you can predict ahead of time is that almost anything you can do with machine learning, you would like to make sure that people can't do what they want rather than what you want, just by showing it a funny QR code or a funny input pattern.
I think that as a methodology that
I think so, yeah. Yes. Like one methodology that I is not a specific methodology, but like a category of solutions that I'm excited about today is making dynamic models that change every time they make a prediction. So right now we tend to train models, and then after they're trained, we freeze them. We can use the same rule to classify everything that comes in from then on. That's really a sitting duck from a situation. It always output the same answer to the same input. Then people can just run inputs through until they find a mistake that benefits them, and then they use the same mistake over and over again. I think having a model that updates prediction so that it's harder to predict what you're going to get will make it harder for an adversary to really take control.
models maintain a bit of a about them always changing.
Yeah.
Thanks so much.
That was awesome. Thank you for coming in.
Following conversation with Ariel and Alan, senior scientist find that brain research cited 39,000 times. One of the most brilliant, impactful minds of the learning. And some of the biggest papers in AI, sequence learning, generation, caption, machine translation, and, of course, the learning. Researcher, Alpha Star Project, grading how professional, StarCraft. Conversation or the Arctic Intelligence Podcast. Enjoy it. Subscribe on YouTube, iTunes, connect with Twitter. to my conversation. Ariel, yeah, spearheaded the DeepMind team, the Alpha Star that recently top professional player at StarCraft. So you have an incredible wealth of work and deep learning and a bunch of. Let's talk about StarCraft first. Let's go back to the very beginning, before Alpha Star, before time, before deep learning. First, what came first for you? A love for programming or a love for video?
I think for me, it definitely came first the drive to play video games. I really like computers. I didn't really code much, but what I would do is I would ask it to break it and fix it. That was the level of skills I guess that I gained my very early days when I was 10 or 11. And then I really got into the game, especially StarCraft actually, was where I spent most of my time playing into a profession. As professionally as you play back in 98, Europe was not a very mainstream like nowadays.
Right, of course. 90. So, how did you get into StarCraft? What was your favorite race? How do you develop? How did you develop it? What was your strategy? All that kind of thing.
So as a player, I tended to try to play not many games, not kind of close the strategies that I kind of developed. And I like to play random, actually, not in competition, but I think in StarCraft there was three main races, and I found it very useful to play with all of them. And so I would random many times, even sometimes in tournaments, games on free races, because it's not how you play against someone, but also if you understand the race you play, you also understand what's annoying, what then when you're on the other side, what to annoy that person, to try to gain advantage here and there. So I actually played random, although I must say, in terms of favorite race, I really like Dirk. I was probably best at Dirk, and that's probably what I tend to use for the end of my career. Starting.
So let's step back a little bit. Could you try to describe StarCraft that may never have played, especially the massive line variety of
Right.
StarCraft?
So StarCraft is a real time strategy. And the way you think about StarCraft, perhaps to understand it best, is that there are boards called map or yeah, the map where people play against each other. There's obviously many ways you can play, but the most easy one is the one versus one setup, where you play against someone else, or even the big AI, right? There that can play the game well. Don't know. Okay. And then in big board, have again like in chess, but these pieces are not there like they are in chess. You actually need to decide gather resources, decide which pieces. So in a way, you're starting almost with no resources. Start gathering resources. Start gather, and then you must decide how much you want to focus on gathering more resources or starting to build more. And then once you have enough pieces or like attack um, a good attack composition, then you go and attack the other side of the map. Now, the other main difference is that you don't see the other side. You're not seeing the moves of it. It's what we call partial observable. So as a result, you must not only decide trading off economy versus your own unit, but you also must decide whether you want to scout, gather information, but also by scouting it might be that might be hiding from the enemy. So there's a lot of complexity to make all in real time. There's also like chess, the turn-based um, game, play basically all the time, and that comes in terms of speed and accuracy of clicking is also very important. And that trained for me really play this game at an amazing level. I many times can witness live. It's really impressive. So in a way, it's kind of a chess where you don't see the other side of the board, building your own, and you also need to gather resources, basically get some money to build other building pieces, technology.
From the perspective of the difference layer, difference between that and chess, or maybe that and game like turn-based strategy like Heroes of Might and Magic. is that there's anxiety, aware of very stressful balance. Everything you described is actually quite stressful balance for an amateur player. I don't know if it gets to the professional level. They're fully aware of what they have to do. If an amateur build up resources, oh, I have to probably spam and all these the time real time strategy aspects is really stressful. After 20 years ago, and BattleNet, Diablo 96, and it might be a narrow perspective, but not society forever. But I may narrow, but your perspective talk about the history of games over the past years, how transformational, how important it is mind.
Right. So I think I kind of was a gamer while was developing the internet, online gaming. So for me, the way it came was I played other games, strategy related, Command and Conquer. Then I played Warcraft from Blizzard, but at the time I didn't know, I didn't understand what Blizzard was or anything. Warcraft was this game which was actually very similar to StarCraft in many ways. It's also where there's swords and weapons, so there's all races. It was awesome, and it was open, right? So I remember a friend of mine came to school saying, "Oh, there's this game called StarCraft," and I just said, "Oh, this sounds like a copy of Warcraft." Until I kind of saw it, and at the time I am from Spain, so we didn't have internet, like very good, right? So there was for us the StarCraft game kind of an offline experience where kind of start to play these missions, right? You play against some sort of scripted thing to develop the story of the characters in the game. And then later on, I started playing against the building AI, and I thought it was impossible. Then eventually you won, and you can actually play against 7 AIs at the same time. It felt impossible, but actually that hard to beat 7 building AIs at once. So once we did that, also we discovered that we could play as I said, the internet was great, but we could play the LAN, right? On, like basically against each other if we were in the place because you connect machines like cable, right? Um, so we started playing in LAN mode, and again, as a group of friends, and it was really, really much more entertaining than playing with AI. And later on, as internet was starting to develop and being a bit faster and more reliable, that is when I started experiencing battle. It's an amazing universe, not only because fact that you can play the game against anyone in the world, but you can also get so many people get exposed to now like this vast variety of each kind of a when the chats get faster. It was a chat system to play against people, but you could also chat people not only about soccer but about anything. That became a way of life for years, and obviously then it became like it exploded to me. I started seriously going to tournaments.
Give a sense on a societal, theological level, what's part of society that us are not aware of, part of society with gamers. And, every time I come across that for streaming, like, there's a huge number of play games, but just you have a sense of those folks now that you've returned to that realm of the AI side?
Yeah, so in fact, I even after StarCraft, I actually played World of Warcraft. Now, the main sort of online world or present get to interact with lots of. So I played that for a little bit, but it was a bit less stressful than StarCraft because winning was kind of like even that you can always complete them. But I think especially StarCraft first and then games like World of Warcraft really very interesting ways because what you get to experience people you wouldn't interact with, right? So even nowadays, I still have many Facebook friends from there where I played online, and their ways of thinking different. So they just we don't live in, but we don't interact in the real world, but we were connected by basically cyber, and that way I actually get to understand a bit better that we live in a diverse see, and more people are more aware coming like me. But back in the day, towards the 2000, 2005 even, it was very, very, um, especially in Europe. I think there were exceptions like Korea was amazing, like that everything happened so early. Cyber campaign. If you go to that, um, back in the day, StarCraft was you could be a celebrity by StarCraft, but this was like 99. Was like um, yeah, it's quite easy back and yeah, I think it's changing. Right, it's the same way, of course, like technology and social networks are also quick tangent. As you're one of the most productive people in your particular those passion path in life, and yet you're also if it's possible to enjoy moderation. Someone told me that about the this when I was playing having a girlfriend, playing video games or studying, and I think for the most part it was relatively. These things do take time. Games like you take the game pretty want to study, then you obviously will get more time to it. And I definitely took gaming and obviously studying very seriously. I love learning science and etc. So especially when I started university undergrad, I kind of stepped off StarCraft. I actually stopped playing, and then World of Warcraft was a passion when I was fun. But as I said, that wasn't as much time invest as it was StarCraft. Okay, so let's get into Alpha Star. What are the you're behind the team? So keep in mind working. But Alpha Star really first time you became a world class player. So what are the parameters of the challenge? The way that Alpha Star took it on, and how did you, David, and the rest of my team get into it? Where they still started back in 2015. Um, actually, I'm lying. It was 2014 when DeepMind was acquired by Google, and I at the time was at Google Brain. It was in California. We had this summit where we got together, the Brain got together, and became a series of talks. And given that they were doing deep reinforcement learning games, I decided to bring up part of my past. I had developed at Berkeley, like called Berkeley Overmind, which is really just a StarCraft one, right? So I talked about that, and I remember them is came to me and said, well, maybe not now, it's perhaps a bit too early, but you could come to DeepMind and again, deep reinforcement learning, right? And at the time, it sounded very science for several reasons. But then in 2015, when I actually moved to London and joined DeepMind, from Brain, it became apparent that because of the AlphaGo movement and kind of Blizzard reaching out to us, say, wait, like, do you want the next challenge and also be DeepMind, sort of kind of all these things together. And then I went to Irvine in California to the headquarters, just chat them and try to explain how would it all work before you do anything. And the approach has always been about the learning perspective, right? So a lot of rule-based, conditioning and if the units then go attack, and if the other has more units than me, I retreat, and so on and so forth. And of course, the point of deep reinforcement learning, machine learning in general, is that all these we learn. So that kind of was the DNA of the project since its inception in 2015, where we even have an environment. That's how it all started. So to go back to that conversation, Dennis, or even your own head, how far away? As we're talking about Atari game, talking about Go, which is kind of, if you're honest about it, really far away from not that you've beaten it, maybe you could say close, but it seems like StarCraft is way harder than Go.
philosophy, mathematics. So how far away did you were in 2019?
Yeah, when I kind of thought about, okay, I'm gonna dedicate a lot of my time and focus on it, and obviously I do different research in deep learning, so spending time on it, I really think there's gonna be something happening out of this. Really, I thought, well, this and it probably is possible to do the full thing, like all the full game, where you play one versus one, and on a neural network and so on. It really felt like I just didn't even think it was possible. But on the other hand, I see some stepping towards that goal. Clearly, you could find some problems in StarCraft and dissect it and say, okay, here's a part of the game, here's another part, and also obviously the fact that it was really critical, the fact that access right? So Twitter was very kind, and in fact they opened open where you can just go and not every single StarCraft game ever played, but it's a lot of them. You can just go and download. Every day they will. You can just query a data set. Well, give me all the games that were played. And even my kind of experience with language and supervised learning, and stuff, well, that's definitely going to be very helpful and something quite unique because never before we had such a large data set of plays people playing the game at this scale of such a complexity, right? So that to me was a very precious resource. And as soon as I knew that Blizzard was able to kind of this opportunity, it started to feel positive about something non-trivial happening. But I also thought the full thing, like really no rules, no single line of code tries to say, well, I mean, for all these, not having any of these special things seemed really, really.
I do also like that where he was trolling you, sort of almost, yeah, pulling you in. Yeah, they have any awareness. What's the interest from the perspective of exception curiosity?
Yeah, I think Blizzard has really understood that really bring forward this competitive of esports games that StarCraft really smart out of like something that almost was never seen, especially as I was saying back in Korea. So they just probably thought, well, this is such a pure one versus one setup that it's great. If something that can play Atari or Go and then later on chess, can tackle the complex real-time strategy game, right? So for them, they wanted first, obviously, whether it was possible. The game they created was way solvable, like them. And I think on the other hand, they also are a pretty modern company that innovates a lot. So just starting to understand AI for them, how to bring AI into games, not AI for games, but games for AI. Like the ways I think work as we obviously are using for AI, right, to drive AI progress, but these are my actually be able to and many other companies start to understand and so I think that also together. They definitely have brings a lot about.
But one of the interesting things to me about StarCraft, Diablo, and games that Blizzard created is the task of balance, making the game fair, a starting point, and then let skill determine. There, in your first comment, three races, and Aaron, I don't know if I've ever said that out loud. Is that how you pronounce it, Aaron? Yeah. Yeah, I don't think I've ever in person interacted with anybody about StarCraft. Uh, so basically, pretty balanced. I wonder if the AI you're doing, the Alpha Star would help balance it further. Well, something interesting about.
Right. So balancing what an infinite or a new spell type is possible, even that you can always train or retrain at scales that might start using that in unintended ways. But I think actually you understand how StarCraft has kind of co-evolved with players. The way I think it's actually very cool. The ways that many of the things and strategies that people came up with seen it over and over in StarCraft that Blizzard comes up with maybe a new unit, then players get creative and do something kind of unintentional or something that Blizzard designers really didn't test or think. And then after that becomes the mainstream community, Blizzard patches. Then they kind of weaken that strategy or make it actually more interesting but a bit more balanced. So this kind of signal talk between players and Blizzard is kind of what has behind them actually. In actually most cases, I mean, StarCraft, but also in World of Warcraft, they use that there's several classes to be not good that everyone plays like, absolutely the same plays or and so on, right? So um, I think they do care about balancing, of course, and they put a fair amount of, but it's also beautiful to also see how players get creative anyways, and whether AI can be more creative. When I don't think so, right? I mean, sometimes something so amazing happens. Like remember back in the days, like you had these drop ships that could drop rivers, and that was actually not thought about. Drop these units that has this what's called splash damage that basically eliminate all the enemy's workers at once. No one thought that you could actually them and really early game that kind of damage, and then things changing. But I don't know. I think there's quite an amazing exploration process from both sides, players and people alike.
It's almost like a reinforcement, but hey, the scale of play, that play was your game. It's almost on the scale of a large scale defined RL experiment. Look at the numbers. You're talking about, I don't know how many games, but hundreds of thousands, probably in one. Yeah. So it's almost the same as RL. What aspect of the problem of StarCraft is that the perfect information, fact that planning, real time aspects, really quickly, the fact that it's a large action space, so many possible things. Uh, in theoretic sense, there is no national. You don't know what the optimal strategy is. Okay. Right. Is there something that stands out as hardest annoying thing?
So when we sort of looked at the problem and tried to define like parameters of it, like what are the observations, what are the actions, it became very apparent that the very first barrier that one would hit StarCraft would be because of the action space so large and us not being able to search like guys or go even though the search space is fast. Um, the main problem that we identified was that of exploring. Without any human knowledge or human prior, you think about StarCraft and know how deep reinforcement learning algorithms work. Essentially, by issuing random action, hoping that they will come with sometime. So, if you think of the action space in StarCraft, almost anything you can do in the early game is bad. Because any action involves taking workers, are mining minerals for free. That's something that the game does automatically mine, and you take them out of mining, send them around. So just thinking how it's gonna be possible to get to understand this, but even more like expanded, right? There's these place, other locations, gather more resources, but the location of the building is important. And you have to select the worker, spend it walking to that location, build the building, wait for the building, and then put extra workers there so they start mining. That feels impossible if you just randomly to produce that state, desirable state that then you hope to learn from, because eventually that may lead to an extra win, right? So for me, the exploration problem and due to the action space, and the fact that it's not really turns, so many turns, the game peaks at 20 times per second. How they discretize those of time, obviously always discretize those at real time. But it's really a lot of things that could go. And that definitely felt a priori like the hardest. You mentioned many good ones, partial the fact that there is no perfect set because of the partial. Those are very interesting problems. We start seeing more and more now in terms of solve the previous one, but the core problem was exploration and solving it has been basically kind of the focus and how we saw the first
exploration, in a multi-hierarchical way. So, like, point second, exploration has a very different meaning than it does in terms of gather resources early, push it out with, so on. Right. So, how do you solve the long term? Talk about the internals of alpha. So, first of all, how do you represent the state? And, right. How do you then do the long term sequence modeling? How do you build a policy? What's the architecture like?
So, AlphaStar has several components, but everything passes through what we call the policy. And that's kind of the beauty of it. There is now give you a neural network in some ways, and if you fed the right observations, then you actually have basic age. Absolutely nothing else other than those ways that work. Now, the first step is observing the game, and we've experimented with two alternatives. The one that we currently use, fixable spatial images that you would process from the game. That is the two-cell version of the map, and also a zoom version of the camera or the screen as we call it. But also we give to the agent these that it has more of as a set of objects that it can operate. That is not really required, and we have versions of the game that play well without vision. That is not like how to the game, but it certainly helps a lot because it's a very natural way to encode the game. Is by just at all the units that there's properties like health, vision, type of unit, whether it's my unit or the enemy, and that's the summary of the piece of that
It's not the exactness. It is not.
yeah, exactness of it is perhaps not the problem. Maybe the problem is that from how actually play the game is that they play mouse on a keyboard and screen, and they don't see sort of a structured object what they
So remember that there's a certain interrupt that camera based do exactly that, right?
Right.
You go around, that seems to converge to similar performance.
Yeah, I think that's what we kind of experiment with what's or not, but using that so actually if you look at research in computer vision where it makes a lot of sense to use images as two-dimensional arrays. There's actually a very nice paper from Facebook. I forgot who the authors are, but I think part of there's and what they take an image dimensional and they actually take pixel by pixel and scramble the image as if it was at least encode the position of the pixels with the XY coordinate. And this is just kind of a new architecture which incidentally also called the transformer. Set of pixels, as long as you encode XY, is okay. Then you could argue that the list of units that would be is precisely that because we have each unit as a pixel will, and then their XY coordinate architecture that was shown to work very well on Pascal and especially your expertise work. I think there echoes a lot of way we work with language. Right. What's that help with long-term model there? Exactly. So now that we understand what an observation is for a given time, we need to move on. Well, there's going to be a sequence of such observations. And an agent, given all that is not only the current, but all that is why partial security must remember what we're going to do. Because then there might be an expansion upright of the map. So given that, what you must then think about is there is the problem of even observation and not only given all the observations, but given all the observations, given all the actions taken. And that sounds exactly like exactly how kind of I saw the problem, especially when you are given supervised data or replays, because the problem is exactly that you're translating essentially observations and actions onto what's going to happen. It's exactly how you would train a model or to generate language. Have a certain you must remember everything that comes in the past, otherwise I start having text. And the same architectures with LSTMs and transformers operate across time and integrate all that's happening. Those architectures that work so well in translation language models are exactly the same than what the agent issue action. And the way we train it, moreover, for imitation, steps one of alpha star is make all the human experience, try to imitate it, much like you translators that translate many pairs of sentences from say. That sort of principle applies exactly the same. But it's almost the same code, except that instead of words, you have a slightly more complicated the observations and the actions are also that kind of
There are self-play components, so once you run out of imitation.
right. So indeed, you can craft from human replays, but then agents you get are actually not as the humans you imitate, right? So how do we take humans from 3,000 mmR and higher? 3,000 mmR is metric of human skill, and 3,000 mmR might be like, right? So we have average.
What's the, so maybe quick pause, MMR's ranking scale, the matchmaking for players, those 3,000, remember there's a master, grandmaster, 3,000.
3,000 is, I think it's kind of level.
Sounds really good, Roth. Yes.
Oh yeah, yeah. So the ratings, the testing are at 7,000. So 3,000, a bit like, so 3,500 allows us to not filter a lot of the data. So we like to have a lot of data learning, as you probably know. So we take 3,500 and above, and do a very interesting thing. We tell the neural network what level they are in. This replay you're going to try to imitate the next action you can see. The 4,000 mmR. This one is 6,000. And what's cool about this is then we take this policy from human, and then we can ask it to play like a 3,000 mmR player by setting a bit, saying, well, okay, play like a 3,000 mmR player or play like a. And you actually see how the policy behaves differently, gets worse economy. You play like a gold level player, it has less actions per minute. The number of clicks or number of actions that you do in a whole minute. And it's very interesting that it kind of imitates level quite well. But if we ask you to play like a 6,000 mmR player, we tested, of course, these policies, how well they do. They actually beat all the built-in AIs that these are put in the game, but they're nowhere near 6,000 mmR. Right? They might be maybe around gold level, platinum perhaps. It's a lot of work to be done for the policy to really understand what it is. So far, we only understand, okay, here is the screen. That's what happened on the game until this point. What would the next action be? But we ask the pro, now say, oh, this is going to click here or there. And the point is, experiencing wins and losses is very important, and start to refine. Otherwise, the policy can get off policy.
That's so interesting. At least hope eventually to be able to control policy, approximately some MMR level. That's so interesting, especially given that you have ground truth out of these cases.
Right.
Can I ask you a personal question? What's your MMR?
Well, I haven't played StarCraft. I am unranked.
Oh,
Which is the kind of lowest.
okay.
So I used to play StarCraft, the first one, and
But even serious play?
no, not StarCraft. The best place we have at mine is about 5,000. I would high master, grandmaster level. Grandmaster level, the top 200 players in certain regions, Europe or America or Asia. Um, but for me, it's hard to say. I am very bad at the game. I actually play, and I was, oh, it's like it's not so good yet. And then I remember I kind of got busy and I played and really very badly. But how did that amazing? Obviously, I tried my best and I tried to also impress my because I actually played the first game, so I'm pretty good at micromanagement. The problem is I just don't understand StarCraft. And when I played StarCraft, I probably was like for a couple of years stopped. I was, but at the time we have MMRs was well established, so it was hard to know what it was. But then,
What was the difference in the Alpha Star and StarCraft and a human player in StarCraft? Is there any significant differences in the way they both see the game?
I would say the way they there's a few things that are just very hard. Um, the main one, perhaps, obviously, hindsight is what's called slope units, which are in. So in StarCraft, you can make some units that you need to have a particular kind of unit to detect. So these units are, if you cannot detect them, you cannot target them. Destroy your units or orders. But despite the fact you cannot target it, there's a shimmer that is a human unit. In train on your pay attention, but you could see this kind of space-time like distortion, and you would know, okay, there are,
There's like a wave thing.
yeah, it's called shimmer and distortion.
I like it.
That's really like, and so this shimmer, professional players actually can see clearly, they understand it very well, but it's something that requires certain amount of attention and kind of a bit annoying. Whereas for Alpha Star, in terms of vision, it's very hard for us to play sort of, are you looking at these people? So, the only thing we can do, there is a unit that is visible over there, so Alpha Star would know that immediately. Obviously, still obeys the rule, you cannot attack the unit, you must have a detector. It's kind of one of the main things that doesn't feel there's the very proper way. I mean, you could imagine, oh, you don't have hypers, maybe you don't know exactly where it is, or exactly, but it's just really really complicated getting so that everyone would, oh, that's the best way. It is a perception problem. So the only problem is people, or you ask, oh, what's the difference between how people perceive the game? I would say how immediately as it appears on the screen, whereas Alpha Star in principle is very sharp. Okay, the speed turn from 0 to 1, there's now a unit there, although you don't know it, or you know that you cannot attack it. That's from a vision, probably kind of most obvious one. Then there are things when perfectly even professional. They might need tell or might not see the unit. And obviously computer, there's a corner of the screen that's green because a unit enters. That can go into the memory of the agent, the LSTM, and persist there for a while, for whatever, for however long it's relevant, right? In terms of action,
It's like the rate of actions for Alpha Star is comparative lower than professional players, but is there more precise?
right? So that's a very like that's really probably the one that's causing us more for a couple of reasons, right? The first one is StarCraft has been an AI environment for quite a few years. In fact, I was participating in the very first competition back in 2010, and there's really not kind of a very clear set of rules how the action permit the rate of action is that, and as a result, these agents, the bots that people in a kind of almost very cool way, they do like 20,000, 40,000 actions per minute. Now to put it in perspective, a very good professional human might do 300, 800 actions per minute. It might not be as precise. That's why the range is tricky. By exactly 300 actions per minute precise is probably realistic. 800 is probably not. 50 humans a lot of actions because they warm up and of selecting the ones that what they need to have. Yeah. So we came in by not having kind of a standard. Well, how do we measure whether an agent is at level? On the other hand, at a huge advantage because we do imitation learning, agents turn out act like humans in terms of rate of action, even precision and imprecision in the supervised policy. So how agents like to spam click here if you play especially Diablo, you know what I mean. Stuff like spam, oh I move here, like 5 actions seconds, but these actions are not very one would find. So on the one hand we start from imitation is at the ballpark of the actions of humans. Actually this is trying to imitate very nicely curves that we took in block action per minute, and the distribution looks very huge. Then, of course, as self-play kicks in, that's the part we haven't talked about yet, but of course, the agent must play against itself. Then there's almost no guarantees that these actions will not become more precise or even the rate of action increase. What we did, probably one of the first attempts that was the distribution of action for certain windows of time. And just to give a perspective, I mentioned that some of these agents that are programmatic, that's 40,000 actions. Professionals, as I said, 300 to 800. What we look is we look at the distribution for professional gamers, and we took reasonably high minutes, but we kind of identify certain cutoffs after which, even if the agent wants to act, these actions. But the problem is this cutoff probably has a bit, and what ends up happening, even though the game, and when we ask the professionals and the gamers, by and large, they feel like it's playing like, there are some agents that develop maybe slightly too high APMs and actions combined with the persistence make people start discussing a very interesting, if we have limited these, if we let it do that, see what things it can come up with, right? So in itself, it's an interesting question, but the same way that modeling the people, modeling absolutely all the details about muscles and precision and tiredness of people is quite difficult. So we're really here in innovating in the sense of, okay, what is maybe the next iteration of more rules that makes the agent more human-like in the strengths that order strengths. That's really interesting. That's really innovative. So one of the concerns, but so for at least focus ends on the proton organization. Can you tell me about the different races, how they, the Protoss, Terran, and the Zerg, how they compare, how do they interact, what is Protoss, right? Yeah. The dynamics of the game. So Protoss, StarCraft, there are three. In the demonstration, saw in the Protoss race. So maybe let's start with that one. Protoss is kind of the most technologically advanced race. It has units that are expensive but powerful, right? So in general, you wanna serve your unit as you go attack. So you wanna, and then you wanna utilize these tactical advantages of very fancy spells and so on. Or and at the same time, they're kind of, people say like they're a bit easier to play perhaps, right? But that I actually didn't. I mean, I just talked a lot of players that we work with in Mana. They said, oh yeah, Protoss is actually perhaps the easier. That doesn't mean the using professional players excel at it. And it's never like a race that dominates for a very long time anyway. So you look at the top, I don't know, there one race. It's pretty hard to know because it depends on the region. I think pretty equal. And Blizzard wants, right? They don't want, they wouldn't want one race that to not be represented, not plays. Um, so definitely like they try to that, right? So then maybe the opposite race of Protoss is Zerg. Zerg is a race where kind of expand and take over as many resources as you can. And they have a very high capacity to regenerate their units. So if you have an army, it's not that valuable in terms of losing the whole army is not a big deal because you can then rebuild it. And given that you generally accumulate a bunch of resources, um, Turks typically play by applying a lot of pressure, maybe losing their whole army, but then rebuilding. So, although of course every race there's never they're pretty different. I mean, there are some units that are technologically advanced and they very interesting spells, and there's some units protoss that are less valuable and of them. It wouldn't be. Maybe I'm missing out, maybe not. But as summary of strategy, first there's collection of a lot of resources. Right, so that's one option. One is expanding, building other things. Then the other is obviously I don't know what. Maybe there's timing of attacks, like attack early, attack late. What are the different strategies first that you learned about? I've read that a bunch of people are super happy that you guys have apparently the Alpha Star apparently discovered this really what saturate the terminal line. Yeah, yeah, yeah. And that's for 3D amateur players like myself. Always been a good strategy. Build up a lot of money. That's good. Accumulate. So thank you for covering that. Validating all of us. But is there other strategies covered? Yeah. Yeah. So if you look at the kind of not being a StarCraft 2 player, but of course StarCraft and StarCraft 2 are real-time strategy very similar. I would classify perhaps um, the opening of the game is very important, and generally I would say two kinds of opening. One that's the standard opening, that's generally how players find sort of a balance between risk and economy and some units early on so that they can defend, but they're not too exposed, basically, but also expanding quite quickly. So this is kind of a standard opening, and within a standard opening, then what you generally what technology are you able? There's a bit of rock paper scissors of you could go for spaceship, you could go for invisible units, you could go for massive units that attack against certain, but they're weak against them. So standard openings themselves have some choices like rock paper scissors style. Of course, if you scout and you're good at guessing what the opponent is doing, then you can play it as an advantage because you know you're gonna play rock and you're gonna play paper, obviously. So you can imagine that normal standard game diagram is like a continuous rock paper scissors game where you guess what the distribution of rock, paper, and scissors is from the enemy and reacting accordingly to try to beat it or paper out before he kind of changes his mind from rock to scissors, and then you will be sorry to pause on that. Yeah. I didn't realize this element. I know it's poker. I know I looked at the broadest. You're also estimating, trying to better estimate what the opponent is likely to be doing. Yeah, I mean, as a player, you definitely have a belief state over what's up on the other side of the map. And when your belief state becomes inaccurate, when you're having limited doubts whether that you must know, that's what you want to then kind of information, right? Improving accuracy or improving the belief state part of loss and optimize. Is it just it's implicit, but you could increase it probably, and it would be quite good at probably predicting on the other side of the map. So far, it's all in. There's no additional reward for prediction. This is standard opening, and then there's what people call very interesting. And Alpha Star sometimes feel like what they are is kind of an all-in strategy. You're gonna do something. You're gonna hide your own building close to the enemy base, or
you're gonna go for hiding your technological building so that you can people units and the enemy cannot react exactly as and there's quite a few of these variants of them, and there is where actually the base state becomes even more because if I scout your base and I see no buildings at all, any human player knows something. They might know, well, you're hiding something. Base, should I build suddenly a lot of and should I actually block my ramp with workers so that you cannot come and destroy my base? All this is happening, defending against important. And in the Alpha Star League, any agent actually develop some strategy. And in the games we saw against Kilo and Mana, 2 out of 10 agents were actually doing these kind of strategies that are easy strategies. And then there's a variant of this strategy called all in. So an all in strategy is not perhaps as drastic as, oh, I'm gonna cannons on your base and then bring all my workers and try to grab your base and game over. Yes, um, there's these kind of very cool things that you can align precisely at certain time. For instance, you can generate exactly 10 unit composition that is perfect, 5 of this type, 5 of this other type, and align the upgrade so that at 2 minutes you have these 10 units and the upgrade. At that point, that army is there. And unless the enemy knows what's going on, if you push, you might then have an advantage. Maybe the enemy did something standard, it expanded too much, it developed too much economy, and it picked up badly against having defensive, and the enemy will lose. But it's called all in because if you don't win, then you're gonna lose. So you see players that kind of strategy, they don't succeed. The game is not over. I mean, you have plays gathering minerals, but they will PG out of the game because they game is gamble. So if we start entering the game theoretic aspect, it's really rich. That's why it also makes it quite entertaining to watch, even if I don't think it's like watching. But they are trying to mostly increase it. But one element that we improved in that play is creating the Alpha Star. And the Alpha Star League is not pure stuff. It's trying to create a different personality that some of them will become easy agents. Some of them might become very economic, very greedy, like getting all the resources, but then they maybe early on they're going to be weak, but later on they're going to be very strong. And by creating this personality, sometimes it happens naturally that you can see an evolution of agents that even the previous generation train against all of them, and then they generate kind of the perfect counter to that. But these agents, you must have them in the population because if you don't have them, you're not covered. You know, you wanna create all sorts of the opponents that you find in the wild. You can be exposed to these early aggression, later aggression, more expansion, dropping units from the side, all these things, and you're gonna play getting a big stack and finding some subset of, but not all. So the Alpha Star League is a way to kind of do an ensemble of agents that they're all playing much like people play on battle, right? They play against someone who has a strategy and you immediately, oh my god, I want to try it, I want to play again, and it was another critical part of the problem, which was, can we create a bottleneck for agents? And that's kind of what the Alpha Star League is fascinating, and where they stick to the strategy. Yeah, wow, that's really, so that said, enough, but so how hard is it? That's not the goal. I guess I don't know what the goal is. The goal would be to majority, not 5-0. But how hard is it to win all matchups on 1v1? That's a very interesting question because when you see Alpha Star and superficially you think, well, okay, one, let's see some of the games 10-1, right? It lost the play with the camera interface. You might think, well, that's done, right? We're human at it. And that's not really the claim we can make. The claim is we beat a
professional game first time. StarCraft has really been a thing that is going on for a few years, but moment a moment like this has not occurred before yet. But are these agents impossible? Absolutely, right? So that's a bit what's kind of different. If agents play at grandmaster level, they definitely stand the game in all play extremely well. But are they unbeatable? They play perfect. No, and actually, StarCraft, because of the strategy, always possible that you might take a huge risk sometimes, you might get right out of. So I think as a domain, it has a lot of opportunity. Not only because of course we want to learn less experience. You like to, I mean, if I learn to play Protoss, I can play Terran and learn it much quicker than Alpha Star can, right? So there are obvious interesting research challenges as well. But even as the raw performance goes, um, really the claim here can be character level or that high grandmaster level. But obviously the players also don't know what to expect, right? Their prior distribution was a bit off because they played this kind of new, like alien brain, as they like to describe, and that's what makes it exciting for them. But also, I think if you look at the games closely, you see there were weaknesses at some points. Maybe Alpha Star did not scout, or if it had invisible units going against at certain points, didn't have known it would have been bad. So there's quite a lot of work to do, but it's really a very, very exciting moment. Wow, a single neural net on a GPU is actually playing against these guys who are amazing. They're really, really amazing players.
Yeah, I'm sure there must be a guy in Poland somewhere right now training, but make sure that never happens again with Alpha Star. So that's really exciting. Alpha Star having some holes deployed, which is great, and build on top of each other. And it feels like StarCraft, unlike Go, even if you win, not it's still not. There's so many different dimensions for it. So it's interesting. Here's a feeling to Alpha Star that it hasn't been, it's the big. Wait, what? Actually, just one second. How did it feel to come to the top professional that night? Olympic athletes have their gold medal, yeah, right? This is your gold medal. Sure, you're cited a lot, you publish a lot of prestigious papers, whatever, but this is like a win. How did it feel?
I mean, it was for me. It was unbelievable because first the win itself was so exciting. So looking back to those last days of 2018, that's when the games were played. I'm sure I look back at that moment and think, oh my god, I want to be in a project like that. It's like I already feel the nostalgia of like, yeah, that was huge in terms of energy and the team effort that's it. And so that sense, as soon as it happened, I already was I was a little bit, so it's like sad that it happened. But on the other hand, it also very few people all these meta reinforcement learning, meta learning, and so on, right? So there's so many points dead. So I'm kind of a pessimist in general. So I kind of sent an email to the team. I said, okay, let's against PLO first, right? Like what's gonna be the result? And I really thought lose like five, right? I had some comparison made against 5,000 MMR players. PLO was much stronger than that player, even if he played for those top race. Um, but yeah, I was not imagining. For me, that was the best run. And then really kind of he was really surprised. And unbelievably went to this bar to celebrate. And Dave said, well, why don't we invite someone who is 1,000 MMR in Brothers, like actual Brothers, like that it turned up being man, right? And that's so great. I said, why not? But then I thought, well, that's really gonna be impossible to beat. I mean, even if, because it is so much ahead. 1,000 MMR is really like 99% probability that mana will be DLO as Protoss versus Protoss, right? So we did that, and to me second game was much more important, though a lot of uncertainty kind of disappears after we kind of beat PLO. I mean, the professional player, so that was kind of but that's really a very nice achievement. But Mana really was at the top, and you could see he played much better. But our agent was much better. So it's and then after the first game, I said, if we take a single game, I think we can take game. I mean, even years for me that was a huge relief. And I mean, I remember hugging them. It was really like this moment for me resonates forever as a researcher and as a person. And yeah, it's really like great accomplishment. And it was great also to be there with the team in the room. I don't know. It was really like, from my perspective, the other interesting thing, like watching Kasparov, watching Mana was also interesting because it is kind of a awesome. Whenever you look at done a lot of sports, sometimes say you look for right, and really, yeah. The offer from us was awkward here. It was, there's an AI system, and beautiful moment. Yeah, was probably the highlight of my career. Because of reason. Yeah, obviously that you can look at paper citations on the these really is like a test the whole machine learning approach. Um, and advanced technology. I mean, really was everything came together at that moment. That popularization, travel, so on. I mean, where a very large community of guys, which is very important. Massive, so writing papers helps our peers, researchers, that AI is something mature enough that we must try to explain what it is, and perhaps the games in an obvious way because games often really everyone experience an AI playing a video game, even if it's always a scripted element, and people might think of that AI already. Uh, so, what are other applications of the underlying Alpha Star? There's a lot of echoes, language. You already started thinking where the breakthroughs in Alpha Star get expanded to other applications. Right. So I thought about a few things for like kind of next month, next year. Um, the main thing I'm thinking about actually was as a kind of grand challenge because for me like if Harry and then there's like the three-dimensional worlds that we've seen also like pretty good performance from these the flag agents that people at mine and elsewhere are working on. It also seems some amazing results of like Dota 2, very complicated game. So for me, like the main thing I'm thinking about is what's the challenge. As a researcher, I see tension between research and then applications or areas or domains. So on the one hand, we've done, thanks to the application of StarCraft, it's very hard to develop some techniques that now we could look at elsewhere. Are there other applications where we and the obvious one, absolutely, you can think of thinking back to sort of community we took from, which was mostly modeling or natural language. So we've developed an extended thing from the transformer and pointer networks combine LSTM and transformers in interesting ways. That's perhaps the kind of lowest hanging of feeding back now the different fields of machine learning that's not playing video. We go to the Mr. Alan Turing. Yeah, the Turing test. There's a natural language test of conversation. What's your thought of it as a test for intelligence? You think it is a grand challenge, or maybe it is formulated or basically differently? Right. So I really love the Turing test because I also like language. And in fact, some of the early work with machine translation. We tried to apply to have a neural chatbot. Um, Obviously, never passed the Turing test because it was very limited. But it is a very fascinating idea that you could really have an AI that means from humans in terms of asking or conversing. So I think the test itself is very nice and it's kind of well defined actually. Like the passings are not. I think there's quite a few rules that feel like pretty simple and really have. I mean, I think they have this partner price, but I'm not seen. I don't know if you the kind of bots that emerge from that competition. They're not quite as what you would. It's a weakness way to inform it. It needs to be definition of genuine, rich, fulfilling human conversation. The but the Alexa prize, I'm not as well familiar. Try to define that more. I think by saying you have to be in a conversation for 30 minutes, like that. So basically, it's not just cool, but to have an engaging conversation. That I mean, is this? Have you thought about this problem particularly? Like, and if you have in general, how far away are we from? Worked a lot on language understanding, language generation, but full dialogue, conversation. You know, just sitting at the bar, having a couple of beers for an hour, that kind of conversation. Yeah, so I think you touched here on critical, right? So there's a great sort of essay by Hamming which describes sort of grand challenge, and he argues that well, okay, for instance, teleportation or time travel are great grand challenges, but there's no attack. We really don't know or cannot kind of make any progress. So that's why most and so on they don't work on the PhD and part of their career. So I see Turing test as a Turing test as a bit still too early. Like I think we're especially the current trend of deep learning language models. We've seen some amazing examples. I think a recent one. It's very impressive, but to understand the of passing or putting human to think that there's a human on the other side, I think it's quite far. So as a result, I don't see myself, and I probably would not recommend people doing a PhD in solving the because it just feels kind of too early or too hard of a problem.
Yeah, that said, you said the exact same thing about StarCraft.
Indeed.
Yeah, you'll probably also get the person fast during test years.
I mean, I think that yeah. So
we have this on record. It's nice.
It's true. It's true. I mean that progress sometimes is a bit unpredictable. I really wouldn't have not. I even 6 months ago I would not have predicted the level that we see that these agents can deliver at grandmaster level. But I have worked on language enough, and basically my concern is not that something could happen a breakthrough that bring us solving for passing the test. Is that I just think the statistical approach to it, like is not going to happen. So we need a breakthrough, right, for the company. But given that, I think it's quite a different. Whereas for StarCraft, I knew what the steps would be, kind of get us there. I think it was clear that using the imitation learning part and using bottom network agents were going to be key, and turned out that this was the case, and a little more was needed, but not much more. For Turing test, I just don't know what the plan or execution plan would be. So that's why I myself working on it as a grand challenge is hard, but there are quite a few sub challenges that are related that well, I mean, what if you create a system like Google already has like a tool assistant? Can we make it better and can we make it neural and so on? That I start to maybe we're reaching a point where we should attempt challenges.
I like this conversation much. It echoes very much the StarCraft conversation. Exactly how you approach StarCraft, break it down and solve those, end up solving the game. Great. But that said, you're behind some of the biggest of work in learning in the last several years. So you mentioned limits. What do you think are the current limits of learning? How do we overcome those?
So if I had to actually single word define the main challenge in learning, it's a challenge that probably has been the challenge for many years, and it's that of generalization. So what that means is that all that we're doing is feeding functions to data, and when the data we see is not from the same distribution, or even there sometimes that it's very close to the distribution, but because of the way we train it with limited samples, we then get to the stage where we don't see generalization as much as we can generalize. And I think adversarial examples are a clear example of this, but you study machine learning and program, the reasons why SVMs very were where because they were dealing, they had some guarantees about generalization is data out of distribution, or even with distribution where you take it mind, these models fail. I think really I don't see a lot of progress on generalization, the strong generalization sense of the word. I I think our neural networks, you can always find design examples that will make their output arbitrary. It's not good because we humans never be fooled by kind of images or manipulation of the images. And if you look at the mathematics, you kind of understand these kinds of matrices multiplied together. Um, there's probably numerics, you can just find corner cases. So I think that's really the underlying topic many times when even at the grand stage of like Turing test generalization. I mean, if you start passing the Turing test, you in English or should it be in any language, right? As a human, if you could add something in a different language, you actually will go and do some research and try to translate it and go on do the Turing test, but include that, right? And it's a difficult problem and very fascinating, very mysterious.
Yeah, absolutely. But do you think it's we're to try to solve it? Can you not grow as a data intelligent situation? Your training sets you up idea. But
I think
that one path, the other path is
right. So the path that has worked well, is Stacker and in translation and in language, scaling up data and the model, and that's kind of maybe the only single formula that delivers like this. Scale, data scale, and model scale really more and more of the things that we thought, oh, there's no way it can generalize. There's no way. But I don't think it's fundamentally to be solved with. And for instance, I'm really liking um, some style or approach that not only have neural networks, but it have programs or some discrete making, because there is where I feel there's a bit more like I mean the example of or the best example I think for understanding I also worked a bit on like learn an algorithm with neural networks, right? So any example that is gonna sort input numbers, something. But really strong generalization. Give me some numbers or you ask me to create an algorithm that sorts numbers and instead of creating a neural net which is fragile because it's gonna go out of range and at some point you're gonna give it numbers that are too large on web nodes. You just create a piece of code that sorts the numbers, then you can prove that that will generalize absolutely all the possible. So I think that the problem comes with some exciting prospects and scale is a bit boring, but it really works. Then maybe programs and grid abstraction are a bit less developed, but clearly I think they're quite exciting for the field.
do you draw any insight, wisdom from those symbolic? You ever go back to reasoning that kind of logic? That like, come back, those stuff, those
Yeah, I actually love actually having more inductive biases. To me, the problem really is what are you trying to solve? If what you're trying to solve is so important that try to solve it no matter what, then absolutely rules, domain knowledge, and then use a bit of the magic of machine learning to empower the best system that detect cancer or detect weather patterns, right? For in terms of StarCraft, it also was a very big challenge. So I was definitely happy that if we had to cut a corner here and there, it do. And in fact, StarCraft, we start thinking of expertise because it's very, I mean, people actually look StarCraft was by thinking about those principles like machines and room based, and then you could think of combining a room based system, but that has also networks incorporated to make it generalized. So absolutely, I mean, we should definitely go back to these ideas and anything that makes the problem simpler, as long as your problem is that's okay. That's research driving a very important problem. And on the other hand, if you want to really focus on the limits of reinforcement learning, then of course you must try not to look at
Welcome.
imitation data or
How are you? Hang on, Amir. Amir didn't want to talk to you anyway.
and I would never not do one or the other, as long as you can afford them and needs to solve, right?
So that that I really enjoy. But one is translating caption. Another beautiful,
Yeah.
beautiful idea I think that resonates throughout your work. Underlying nature, reality.
Yeah, somehow.
So what the connection is rather the world and the world.
Right. So I think a piece of research that I would say even extends larger difference to learning. What we really meant by that is that you can now really input anything to a neural network as X, and then the neural network will learn about F, take X as an input, and any output Y. And these X and Y don't need to be like static or like a feature, like a thing, like a big step or anything. They could really now beyond like data structure, right? So that paradigm was tested in a very interesting way when we moved from translating French to English, translating an image caption. But the beauty of it is that really, and that's actually how it happened. I changed a line of code, this thing that was doing machine translation. I came the next day and I saw how it's like it was producing captions that seemed like, oh my god, this is really, really working. And the principle is right. So I think I don't see text, vision, speech, waveforms as something different. Um, as long as you basically learn a function that will vectorize these into, and then after we vectorize it, we can then use formers, LSTMs, whatever the flavor of the month of. And then as long as we have by data, really, this formula will work, will keep working, I believe, to some extent. Modulo this generalization.
So but the test there is right, so the former representation.
Yeah.
Your intuition now having all this once you are able to form that representation basically there go back to StarCraft the limits of length. We didn't really touch on the long term aspect. How did you overcome the whole really long term aspect of
So the mainstream StarCraft can absolutely every frame. I think quite a long time. So we would have like 20 times 60 seconds per minute times maybe at least per game. So there are quite a few frames. But the trick really was only observe might be seen as a limitation, but it is also completely transparent. Only observe when you act. And then what the neural network decides, what is the gap going to be until the next act. And if you look at most StarCraft games having the data set provided, it turns out that most games are actually only the long sequence, that is maybe like 1,600 actions, which if you start looking at LSTMs, large LSTMs, transformers, it's not like not that especially if you have supervised them. You have to do it reinforcement learning, a great assignment problem. What is it that in the game that makes it? That would be really, but thankfully, because of imitation learning, we didn't kind of have to do it directly. Although if we had to, tried it, what happened is just take all your workers and attack them. And that sort of kind of obviously prospect because you start trying random actions. One of the actions would be a worker that goes to the enemy base, and because it's self-played, it's not going to know how to defend because it basically doesn't know almost anything. Eventually, what you develop is let's go workers and attack. Because the great assignment in a rally is, I do believe, better, and that's going to be research challenge. But yeah, even in StarCraft, the sequences are maybe 1,000, which I believe it's within the realm of what transforms.
Yeah, I guess StarCraft Go is Go chess stuff that's happening right away.
Right.
Yeah, it's pretty easy to self-play. But to self-play is possible to develop regional strategies with StarCraft.
I mean, Go, there's only 400 actions, but one action, what people call the God action, is if you had spanned the whole first tree, that's the best action. Whatever I would do if you had the capacity. But in StarCraft, 400 is like if 400, you don't even like even click on the pixel around, right? So I think the problem there is in terms of action, space, size, way harder. So and that search is there's quite a few challenges that make it sort of step up machine learning. For humans, maybe playing StarCraft is because it's real. I mean, like it's graphics and everything. Whereas I don't know how to go is a game that I really study. It feels quite complicated. But for machines, kind of maybe the reverse, yeah.
Because this gap actually learning however the heck work. Developed a lot of really ideas. Ask what's your process of developing new ideas? You like brainstorming with others, like was it King Goodfellas that came up with games after a few beers. Right, keeping beers are essential for coming up with new ideas.
We had beers. I think another game of StarCraft after a week. And it's similar to that story. Actually, I explained it. I think mine really as again story. And we're in a bar. Let's play again next week. That's what happened.
I feel like we're carrying the wrong message to young undergrads.
Yeah, no,
but like brainstorming like along with stuff out.
So I think throughout the years also changed, right? So initially I was very fortunate to be great minds like Jeff Hinton, Jeff D. I was really fortunate to join at a very good time. So at that point, the ideas I was kind of brainstorming my colleagues and learned a lot. And deep learning is actually something ever, right? So learning implies reading papers and also discussing ideas. Very hard point not being reading a paper from someone or actually. So definitely that communication aspect, whether it's written or oral. Nowadays, I'm also trying to be a bit more strategic about what so I was describing a little bit this potential research for the sake of research, and then you have, on the other hand, applications that can drive the research, right? And honestly, the formula that has worked best for me is find a hard problem and then try to translation drove different sequence, then maybe like learning algorithms that had combinatorial algorithms led to pointer networks. Um, Diagraph led to really scaling up learning and the alpha standing. So that's a formula that I personally like. But the other one is body that I use a lot of the time where this is what I model based around as kind of a research topic. Once then start to think, well, how are the tests? How are you going to test these ideas? People, environment, right? With a lot of paper and so on. And that's also very fun. On quite a few times. That's very much in my hand, obviously. So I think besides the ideas and discussion, I think it's important also because that sort of guiding not only your own goals but other people's goals have the next breakthrough. So you must really kind of understand the feasibility also as whether the domain is ready to tackle or not. And you don't want to be too early. You obviously don't want to be too late. So it's really interesting. And this is a strategic component of research. I think as a grad student, I just had no idea. I just read papers and test ideas. I think it has been a major thing. And I recommend people kind of reach forward to success like and check back. Other than looking out, this looks random walk, which sometimes some of but generally it's also kind of like your approach a really hard problem, stepping right in and being super skeptical about being able problems. I mean there is a challenge often critical skepticism challenge. Why is it that it's balance? You don't do that on your own, you have mentors that obviously and whether it's the right time, I mean Tammy's Tammy doesn't meet startups and he knew that I'm just doing these videos, right? Really, right? So these things are obviously quite important that you wanna be surrounded by people are diverse, they have their knowledge, they're important. I mean I've learned a lot from people who actually have an idea that I'm not think it if I try it, I've been proven wrong many times. That's really um now let's talk about another possible problem by AI. Right. What do you think it takes to build this public health? Talk a little bit about the current quality. But if you think about something that you look back and say, wow, double intelligence. So I find that AI oftentimes is maybe not very well defined. What I'm trying to and come up for myself, what the results look like as you start to see that you would have agents that no longer sort of forward but actually kind of learn the skill of learning. And that actually is a skill that I emphasize learning to learn or meta learning, which is about no longer learning about the system. So think about the learning algorithm itself in general, right? So the same formula we applied for Alpha Star or StarCraft, we can now apply to almost any game, or you could apply to many other programs and domains. But the algorithm is what generalized. But the neural network, the weights, those weights are used even to play another range, right? I train a network to play very well at Protoss versus Protoss. I need to strip away those weights. If I want to play Terran versus Terran, I would need to retrain a network with the same algorithm. That's beautiful. But the network itself will. So I think if I see an approach that can absorb or start solving new problems without the need to kind of restart the the process. I think that, to me, would be a nice way to define some form of AGI. Again, I don't know the grandiose like AGI. I mean, you could as we talked before AGI. I mean, I don't know. I think concretely, I would like to see clearly that meta learning happens. Meaning there is architecture or network that as it is new problem or new data, it solves it and make it a benchmark, solve it at the speed that solve it from. I find you a new object and you have to recognize it when you start playing a game, you played all the Atari games, but now you play the Atari game. Well, you're gonna be pretty quickly. So that's perhaps what's the domain and what's the exact benchmark is difficult. I think as a community we might need work to define it. But I think this first step I could happen relatively soon. But then the whole what AGI means and so on, I am a bit more confused about what I think people mean.
Yeah, there's emotional, psychological level that, like even the Turing test, passing the Turing test, pass judgment, and being, as a dog, is an AGI. Yeah, level. What does it mean? Right. Yeah. What does it mean? But I like the generalization. I think there's a community to converge towards domains far away. Really generalize. Perhaps not as close as protest to third, but like can be that they'll get better than but then like StarCraft and back.
Yeah,
back and back.
that feels quite hard, but I think as long as you put the benchmark out that we covered then tremendous progress we have. But I think maybe there's a lack of benchmark, but I'm sure we'll find one. Yeah, the community will work towards that. And then beyond what AGI might mean or imply, I really am hoping basically machine learning or AI just scaling up and helping people that might not have the resources to hire an assistant, that they might not even know what the weather is like. But so I think there's, in terms of the impact, positive impact of AI, that's maybe what we should also not do. Right? The research community using AGI, I mean, that's a real nice goal, but and I think the way that it might then use it to solve everything, right? So I think it's paralyzed.
Yeah, we forget of all the positive things actually coming out of AI already and are coming out. But on that note, let me ask about the concept of perception. Do you have any worry about the existential threat of artificial intelligence here or far future? That's
I think in the near future I'm skeptical, so I'm not wrong, but I'm not concerned, but I appreciate efforts, ongoing efforts, even like full research on AI safety emerging conference and so on. I think that's great. In the long term, I really hope we can simply have the benefit outweigh the potential dangers. I am hopeful for that, but also we must remain vigilant, monitor and assess whether the trade-offs are there and have enough also in time to prevent or redirect our efforts. Right? So, but I'm quite optimistic about the technology and definitely more fearful of other threats in terms of planetary level at that point. But that's the one I kind of have more power on. So I do start thinking more and more about it. Kind of thrown in me actually. Start reading more about AI safety. These are fields that so far I have not really contributed, but maybe there's something out there as well.
Well, I think it's really important. I talk about this folks, but ask you and throw it in your head because you're at the edge of actually what people are excited about in AI. I mean, the work with efforts are arguably very cutting edge
for it, right? For things that go wrong, is use of the technologies as technology, right? So I think then we the past. So I'm hoping that by having the teachers and the whole community understanding intelligence, right? How are we doing? And, obviously from a scientific standpoint, that is the drive, my personal drive, or all the time that is doing what I'm doing. Really.
Where do you see the deep learning field heading? Where do you think the next break might be?
So I think deep learning, I discussed this before. Deep learning has to be combined with some form of discretization, program synthesis. I think that's kind of as a research stuff is topic fund and start doing some research. And then as kind of what will deep learning enable to do? I don't think that's going to be what's going to happen this year, but also the idea of starting not to throw away all the weights that of learning to learn and really having agents not having to restart their weights, and you can have agents that is solving or classifying images on the internet, but also generating speech. You ask it to generate some speech, and it really be kind of almost a network, but might not be neural network. It might be a neural network because communication algorithm attached to it. But I think this idea of generalization is something that we first massively find first, and I think that's going to be exciting. I'm not sure how close we are, but I think there's if you have a very limited domain, and start doing some progress, and much like how we did a lot of progress. I really like a talk that Leon gave at a few years ago. Train test paradigm should be broken. We should start talking about training tests, target training tests, test set, and there are closed that are untouchable. I think we should go beyond these and meta learning, meta training, really thinking about if I know about why would that network work on MNI, but right now it really doesn't. It's wrong, right? So I think that's kind of on the application or the benchmark side, we probably quite a few interest and progress and hope and exciting times.
Do you have any hope or interest in knowledge graphs within the context of this kind of those of constructing graphs? So going back to graphs, well, neural networks are graphs, but I mean it's a different kind of knowledge graph. Those like semantic graphs or the concept.
Yeah. So I think the idea of graphs. So I've been quite interested in sequences first, and then more interested in different data structures like graphs. And I've studied graph neural networks in the last 2 years or so. I found these models very from like deep learning side standpoint. But then why do why would what's the application? What kind of the particular application of graphs, right? And perhaps we could extract a knowledge graph from the automatic, right? That would be interesting because then graphs have been very a bit more compatible with the idea of programs and deep learning kind of working together, dumping neighborhoods and so on. You could imagine finding some primitive go around the graphs, right? So I think I really like the idea of a knowledge graph. And in fact, when we started, or as part of the research we did for StarCraft, I thought it would be cool to give the graph of all the prerequisites, like there's all these buildings that depend on each other, and units that have prerequisites of being like that. And this is information that the network can learn and extract, but it have been great to see or to think of really StarCraft as a giant graph that even also as a kind of start rate. We did a bit of research on this, nothing relevant, but I really like it.
And it have elements that are, you also work with in terms of visual network, elements of human interpretable, generally knowledge representations that are interpretable, or at least understand. A lot of interesting aspects there. And first, I'm just kind of and it's a shame that our neural networks aren't taking advantage of all the structured knowledge that's on the web. What's next for you? What's next for your mind? What are you excited about for AlphaStar?
Yeah, so I think the obvious next step to apply AlphaStar to other races that sort of shows that the algorithm works, because you wouldn't want to have created by mistake something in the architecture that happens to work for Protoss but not for other races, right? So as verification, I think that's a step that are working on. And then I would like to see agents and players specialize on different skill sets that allow them to be very good. I think we've seen AlphaStar understanding very well when to take battles and when to do that. Also very good at micromanagement and moving the things around and so on. And also very good at producing non-stop and economy using units. But I have not perhaps seen as much as I would like the idea of the poker idea that you, right? I'm not sure StarCraft or AlphaStar rather has developed a very deep understanding of what the opponent is doing and reacting to that and sort of trying to read the player to something else, or that, so this kind of reasoning I would like more. So I think usually from a research standpoint, there's perhaps also quite a few things to be done there in the domain of StarCraft.
Yeah, in the domain of games, working with auction, manipulating other players, forming a belief state, investing.
Yeah, well, theory of mind. Yeah. The theory of mind of StarCraft is kind of, they're really made. So that would be very exciting to see those techniques applied to StarCraft, or perhaps StarCraft driving it. That's always potential.
Oriel, thank you so much. Okay.
Awesome. It was great to be here. Thanks.
Following his conversation with Chris Ladson, currently director working on several projects in accelerated TensorFlow, Swift for TensorFlow, and all kinds of learning compiler magic going on. One of the top experts in the world on compiler technology. He understands the interface of how hardware and software code. Is that LLVM compiler infrastructure project playing compiler led efforts ratio also built time at Tesla, vice president in the transition from autopilot hardware one hardware Tesla started from scratch how software while compiling across the level of abstraction, one of the most fundamental fascinating aspects of one of the world's excellent process science art conversation art art I might need to what was first program first
I think I started my so when I started hacking out, seeing how the market and looking at them in wrong and trying to figure out why they were right.
basic what was the first language that you remember yourself falling like really
I don't know. I mean, I feel like I've learned a lot of, and each of them have a different special thing about them. I started in basic, and then like basic back in the DOS days. Basic, especially, they're all slightly fancy versions of made the jump to Pascal, started doing language programming, assembly in Pascal. Eventually got into C++, then lots of other weird things. So I feel like you picked a dark path. You could have gone less, yeah, you could have been a higher level, sort of functional, philosophical B route. Instead, you went into the dark art of the straight into the machine, straight to the, so started with basic, net assembly, a lot of assembly. Eventually, that was not the starting.
What is the journey that college
doesn't, and then that was it's really about trying to be able to do powerful things and learn a different role. He was really good with pointers and while Pascal's more seriously, he's more over
pointers, memory management, sources,
and hasn't well, but in Pascal, carrots are about pointer and about how things get laid out in memory. And so in Pascal, you have allocating and the programs are set. You don't have to, for example, think about a string instead of an array of characters which are memory.
Get into talk about LLVM thing in college. Tell me first what LLVM is playing are and how is by yourself the creator developer one of the most powerful out there.
Sure. So I guess so. Let's start with what is a compiler. That a good place to start?
What are the phases of the compiler? What are the parts?
Okay. What is even a compiler? The way I look at it, you have a two-sided problem of you have humans who need to write code. You have machines to run the program that wrote. Lots of reasons you want to be writing in binary. You want to think about everything. But at the same time, you have lots of humans. You also have lots of hardware. And so compilers are the art of allowing humans to think at the level of abstraction they want to think about. And then get that program, get the thing that they wrote to run on a specific computer. And part of all this, there's now lots of different kinds of hardware, like ARM and things like that. But also high performance accelerators for learning and things like that are used new kinds of hardware. At the same time, on the programming side of it, you have basic JavaScript, Python, you have Swift, you have lots of other languages. They're all trying to talk to the way to make them more expressive and powerful. So compilers are the thing that goes from one to the other.
End to end. Very beginning.
End to end. So you go from what the human wrote. Programming languages end up being about expressing, and not just the compiler and the hardware, but the programming language's job is really to capture expression of what the programmer wants that be maintained and adapted by other humans, as well as by the interpreted by the compiler. So if you look at this problem, you have on the one hand humans, very complicated, you have hardware. So compilers work in space. So the software engineering challenge we have here is to try to get maximum read out of this amount of code to write. Compilers are very complex. So the way it works out is have something called a front end or parser language specific. So you'll have a C parser that's applying it, JavaScript, Python, or whatever, the front end. You'll have a middle part, often the optimizer, and you'll have a late part, which is hardware specific. So compilers end up, there's many different infrastructure, which gets better performance, and code generation infrastructure for server support. So LLVM is that layer that is common. All these different standards, like a specification. So it's, I think there's different ways of looking at it, right? Because it depends on which angle you're looking at it from. LLVM ends up being a bunch of code. It's a bunch of code that people read. They've built compilers, called a compiler infrastructure because kind of the underlying platform is a concrete compiler. But it's also community. The LLVM community is hundreds of people that all collaborate, and one of the most fascinating things about LLVM over the course of time, managed somehow to successfully get harsh competitors in the commercial space to collaborate on shared infrastructure. So you have Google and Apple, you have AMD and Intel, you have NVIDIA and AMD on the graphics side, you have Cray and everybody else, and like all these companies are collaborating together to make that shared infrastructure great. They do this not at their heart, but interest in having really great infrastructure on top of it. Facing the reality that funds that no one company, the big company, really want. That's cool. That's a great point because it's also about the skill set. These skill sets are hard to find. How big the LLVM? It always seems like with open source projects, because of kind, and LLVM, of course, yes, it's of course about now. Really cool. It's like magic often happens in a very small circle. It's like so the LLVM came from university project, so I was at the University of Illinois. There it was myself, advisor, and then the two or three research group that built many of the core pieces initially, and then graduated and went to Apple. And Apple brought it to the product versus geographic stack, but eventually compiler realm, and eventually built Clang, built these things. Along the way, building a team of people that are really amazing compiler engineers to help build a lot of them. So as it became momentum and as Apple was using it public and encouraging contribution, many others from Google came in and started contributing and helping Google effectively playing it because it cares so much about C++, the solution of that that's a lot in the C++ world and playing like that. So likewise, NVIDIA cares a lot about CUDA. So CUDA is playing for graphics. So when you first started last week's project, I think it's gonna go as far when you about it. Really, no, I was. So I mean, my goal when I went to university out was master's, get back. So I was not planning to stay for 5 years, and all the I got nerds night. A lot of it was because I was fun stuff, learning really interesting things, and basic software engineering. That turn, but really different thing people are trying to collaborate in version control, and it was different. Like I said, about the docs, percent of the world population has so okay, very like I can't. It's something that attracts you to the idea of optimizing code. One of the biggest things. So I'm a person. So when I was in my undergraduate, I had an advisor or I went to this little private school. There were 7 or 9 like students in my think it's evolved a lot in the many years. But Vector was a compiler guy. Passion. He passionate about on making one of the things I like about compilers, large software. So one of the culminating classes many science departments time did was they take algorithms, data structures, classes. Compilers class was the last class you take. You put them together, and one so you keep building on your own. It's really it's very challenging because many classes don't get the project done, forget about it, and move on to the next one and get your whatever. Here you have to live with hey, reinvest. I really like that. And so exercise project following semester and great a great mentor in a lot of so from him for graduate school. Super excited about going to grad school. I wanted the master's degree, but I want to be an academic. And like I said, I kind of get tricked into saying on. Definitely do not regret.
Well, that's so there's also the other part of analyzing, analyzing language, picking up, parsing, so on. That interesting field stuff. For me, it was more. I'm not really a math person. I do math. I understand some, but get into it. But math is kind of like the a lot of the parser part of the compiler has a lot of good theories. Don, for example, quite well. Waiting for his book on that. Um, but I just like building a thing and what it can do and exploring and setting new tools and the case of LLVM that my research advisor that I was working for, compiler guy. So it's just we found each other because we're both compilers taking a class. A lot of LLVM initially was it's fun implementing all the standard algorithms. Things talking about and well known curricula for advanced studies and compilers. So the thing I built that was learning a lot by reading about it, just building. Language, try to describe, how you turn a program. Yes. So, like, what are the hard parts? Why is it hard? So, I'll give you examples of the hard parts. So, C++ is a very complicated, like 1,400 pages. C++ by itself is crazy. Let me just try and in terms of like so it's what they call syntax, so the actual how it range, yes, how it behaves. Also in the case of history, play that forward, and then a bunch of suboptimal decisions were made, and they compound, and then more and more things added to us, and it will probably never stop. But the language is very complicated from that perspective. So the interactions between subsystems is very complicated. Just a lot there. Talk about the front major challenges playing as a project, the CC plus compiler that I built. I admit challenges we took on was GCC. Time was a really standardized compiler that had really consolidated a lot of the other compilers in the world and was standard. Great for research. Design was very difficult, and it was full of variables and other things that made it very difficult to reuse in ways that it wasn't originally designed for. So with playing, one of the things we wanted to do is push forward on better user interface, make error messages better than that's actually hard because you have to do a lot of bookkeeping that are make compile time better. Compile time is about making it efficient, so it's really hard when you're keeping track of information. We wanted to make tools, refactoring tools, and other analysis tools that front end piece complicated. Types trees, then you start doing the lowering, going from C++ in the way that they're often there are, I think LLVM has something like 150 different what are called passes and compiler code passes through, and get organized in very complicated ways, affect the generate code performance, compile time, and many other things. What are they passing through? So what the design parser? What's the graph? What is it? Yeah, yeah. So in the parser, a tree called an abstract tree. The idea is you have a node for the when wrote in their code. The function call you call with the function they call and the arguments like that. That gets lowered into what's called an intermediate representation. The representations are like LLVM has one. There is a called a control flow graph. So represent operation program as very simple. Add two numbers, apply two things, but then what are called blocks. So you get blocks of these straight line operations. Instead of being nested like a tree, straight line operation. And then you have block or outside. That's what's the block. Straight line operations block. You have branches. Right, for example, text tree, you would have a for node or for statement. In language, you have a for node, and you have a pointer to the expression for the initializer, a pointer to the expression for the increment, a pointer to the expression for comparison, a pointer to the body. From nested. Also, graph, you get a block for the code that runs before the initializer. You have a block for the body of the body of the code goes in there, but also the increment of that. Then you have a branch that's back and a comparison and a branch. So more of an assembly level. The nice thing about this level of representation is much more language independent. Lots of different kinds of languages, different kinds of a lot of different ideas of what is called, for example. All that contains the product so that middle part can be shared. It's a representation of neural networks. Specifically, everything described as a kind of arrows of neural network graph. But yeah, are they neighbors or they're quite different in they're very similar in idea. But one of the things that neural networks do is they learn representations for data at levels of abstraction, right? And then they transform those through layers. Either does very simple things, but one of the things that Either does is it has two different representations. A neural network often, for example, you get many different representations or set of ops that's transforming between. Either often you get representation and they do many transformations are often, but programmers they're familiar types try to find expressions compatible with executor, find redundant computation, or find constant folding or other simplification, turning times x shift left by 1, things like this. All examples of this happen. Others end up getting and other kinds of algorithms that try to find higher level properties of the program that can be used by the option. What's like the biggest bang for the buck? The nation. Today? Yeah. Well, no, not even today. Very beginning, the 80s, I don't know. Yeah, so for a lot of like register allocation, the idea of a modern microprocessor, what you end up having is you'll have memory, which is relatively slow, and they get registers relatively fast. But registers, you don't have very many. Yeah. So when you're writing a bunch of code, you're just saying like, compute this, put in temporary variable, compute this, put in temporary variable, I have a loop, I have some other stuff. Now you're running on an x86 PC. So it only has some cases loads registers. Right? Now is actually a really big deal. Think about an inner loop times. If you're doing loads inside that loop, then it's going to be really slow. But if you somehow fit all the values inside that loop in registers, now it's really fast. So getting that right requires a lot of work. There's many different ways to do that, and often what the compiler ends up doing is it ends up thinking about things in different representations than what you do. Right? You wrote intent. The compiler thinks about that as 4 different values which have different lifetimes across and each of those can be put in register or memory or different memory or in some parts of the instead of ordinary load. There are many different kinds of techniques you can use. So it's adding almost like a time to trying to optimize across time. When you're programming, so the risk area, maybe risk, all right, the risk the risk chips made things more complicated for the compiler because um, what they ended up doing is they ended up adding pipelines to the process where the process would do more than one thing at a time. That means that the order of operations matters. One of the classical compiler techniques, scheduling, the instructions around so that the process like pipelines full instead of stalling and getting like that are bread and butter compiler techniques. We've studied a lot over the course of decades now, but the engineering side of making it real is also quite hard. Talk about machine learning. This is a huge opportunity for machine learning because many of the algorithms are full of these like hand rolled heuristics that work well on specific benchmarks, but generalized, full of magic numbers. I hear the techniques that are good to handle. But what would be the your machine learning? What's the thing you're trying to optimize? Ultimately, running time. Yeah. You can pick your metric, and there's running time. There's memory use. There's lots of different things. Code size, another one that people care about. Like, sure, somebody actually crazy enough to try machine learning based parameter tuning for so this is something that is, I would say, research right now. There are a lot of research systems that have been applying search in various forms. Reinforcement learning is one form, but also search has been tried for quite a while. And usually these are small problem spaces. So find the optimal way to generate and apply for a GPU. Right? Something like that, where you say, there's a lot of design space. You unroll loops a lot, you execute multiple things in parallel, and there's many different founding factors here because graphics cards have different numbers of threads and registers, cores and memory bandwidth, and many different things interact in nonlinear ways. Search is very powerful for that, and it gets used in certain ways, but it's not very structured. Something that needs to be industry. So, has there been like big jumps in application? Yeah. Right. Yeah, I guess. I don't know what's. Yeah. So it's largely driven by hardware. So, hardware and software. So, in the 90s, Java totally changed, and I'm still amazed by how much. In a good way, or in a good way. So, like reflecting back, Java introduced things like it's all at once, like a compilation. I mean, none of these were novel, but it pulled them together and made it made people invest in it. A compilation, garbage collection, portable code, things like memory safe code, a very dynamic dispatch execution model with many done in research, been done in small ways and really came to the forefront, really changed how things, therefore changed the way people thought about the problem. JavaScript was another major rule change based on the way it works. But also on the hardware side of things, in vector instructions really changed the problem space and are very, they don't remove any of the problems that others past, but they add new kinds of problems of how do you find enough work to keep a 4-wide vector, or if you're doing a matrix multiplication, how do you do all
one core has. Take it to hundreds of over. Yeah. So what the Java virtual machine does is it lets, just like I was talking about before, where you have a front end that parses the code, and then you have an in-memory representation that gets transferred. What Java did was it parse the code and then compile to Java bytecode. That bytecode is now a representation, pretty standard and locked down and change. And then the back part of the compiler, documentation and code generation, now be built by different vendors. Java bytecode can be shipped around across the wire and is relatively trusted.
And because of that, it runs the browser.
And that's why it runs in the browser. And so that way, you write a Java applet and you, as a web developer, you build this app that's running on a web page. Well, the user of that is running a web browser on their computer. You download that Java bytecode, trusted, then you do all the compiler stuff on your machine.
Now, is that a good idea or a bad idea?
It's great. Man, it's a great idea. I very much technology is itself neither good nor bad. It's how you apply it. This would be a very, very bad thing for very low levels of stack, but in terms of solving for building transparency or portability, and Java ultimately didn't win out on the desktop. There are good reasons for that, but it's been very successful on servers, and many it's been a very successful thing for decades.
So what been LLVM and displaying improvements in optimization? Broadest history. What are some setback accomplished?
Yeah, I think that the interesting thing about LLVM is not the innovation of the research. It has very good implications. It's very important output, no doubt. And a lot of really smart people working on it. But I think that the thing that's most profound about LLVM is that standardization makes things possible that otherwise wouldn't have happened. And so, the things that happen with LLVM, Sony has picked up LLVM and used it to do all the graphics compilation in their movie production pipeline. So now they're able to have better special effects with LLVM. That's not what it was, right? But that's kind of good infrastructure when ever designed for, because it's good layering and engineering and cool and things like that. Where, yes, it's great in various ways, but it's not as good as the infrastructure decompiler or supporting compiler. It's not infrastructure.
Now you can tell I don't know what I'm talking about. Person closed, by the way, something. I don't think, have I ever used Clang?
Entirely possible. Also, you've used code generated, probably. So, Clang and LLVM are used to compile all the apps on the iPhone, effectively, and the OSs. It compiles the rules production server applications used to build games, PlayStation 4, and things like that.
Totally used that I have, but everything I've done that I experienced in Linux,
I think Linux.
Is there a reason for that?
Combination of technical and many Linux developers use Clang. Distribution, for lots of reasons,
totally online. LLVM has either level or whatever.
the way I would say it was just so close it doesn't matter. Like there's slightly better in some versus otherwise, but it doesn't actually really matter anymore. That level.
Of optimization, very just solid incremental work.
Yeah. It describes a lot of compilers. The hard thing about compilers, my experience is the engineering, software engineering, you can have hundreds of people collaborating on really detailed, low-level work, and scaling that. That's really hard. That's one of parts about LLVM is designed to be modular. And when I started, I would write, for example, the register allocator, and then something much smarter than me would come in and pull it out and replace something else. And because it's modular, they were able to. That's one of the challenges with, for example, substitute. It can be done. That's one of the reasons the LLVMs are very successful in research.
But in the community sense, like over in Rust, right, Python, from benevolent dictates of life, right? So managing community with other folks, there for a time or well,
oh yeah, so I mean I still have, I can remember my patches in LLVM than anybody else. And many of those I wrote myself. But
right, so close the I don't know, metal, you still write code.
yeah, I still write code. Not as much as I was in grad school, but the way that LLVMs work at the time is that when I was a grad student, I could do all the work and hear everything and review every patch and make sure everything's done exactly the way, in my opinion, sense felt like done. That was fine, but I think scale you can't do that, right? So what ends up happening is LLVM has a hierarchical system of code owners. These code owners are given the responsibility not to do all the work, not necessarily to review all the patches, but to make sure the right thing is happening in architecture area. So you'll see, for example, hardware manufacturers and the hardware specific parts of their hardware. That's very common. Leaders in the community that have done really good work naturally become the de facto owner of something, and then usually somebody else is like, how about we make them the official code owner, and we'll have somebody to make sure that all the patches get reviewed in a timely manner, and then everybody's like, yes, that's obvious. It happens. So I'm nominally at the top of that stack still, but I don't spend a lot of time reviewing patches. What I do is I help negotiate a lot of the technical agreements that end up happening, making sure that it makes progress in the right direction, and doing that. So just started a nonprofit. Just a year ago, I've gone away. The nonprofit, the LLVM Foundation nonprofit, all the business side of the thing, make sure that the events that LLVM has are funded and set up and run correctly, and stuff like that. But the foundation is very much stays out of the side of where the project is.
Right, that sounds like a lot of it is the organic.
Yeah, well, and this is LLVM is on part of it. Somebody pointed out to me recently that LLVM is now older than it was when LLVM started. So kind of as a way of getting away from you. But the good thing about that is it has a really robust, really amazing community of people that are in the professional lives spread across lots of different companies, but the community of that are interested in similar as working together effectively for years, have a lot of trust and respect for each other, and don't always agree that we're able to pass forward.
Then in a slightly different flavor, you started Apple in 2005 with the past mentioned department LLVM, Xcode. But so quick view of time there. What were the challenges while leading developers? What was the big motivator, dream, mission behind creating Swift? Early birth of it, projected, so on and Xcode.
Yeah, so these are different questions.
Yeah, I know.
Okay, so I'll say
I want to talk about the other stuff.
I'll say on the technical side that we can talk about the pieces. That's okay. So it's to really oversimplify many years of hard work. LLVM started, joined Apple, became a thing, invested. Then there's a question about how do we actually parse source code? So LVM is that back part, the optimizer and the code generator. And LVM is really good for Apple at through a couple of hardware transitions. Joined right at the time of the Intel transition, for example, and 64-bit transitions, and then transition to ARM iPhone, and so LVM is very useful for things. But at the same time, there's a lot of questions around developer experience. So if you're a programmer pounding out in time Objective-C code, the error message you get, the compile time, the turnaround cycle, the thing in the IDE are not great, or not as good as they could be. So, um, I occasionally do. I'm like, okay, how hard is it for I just? So I'm not going to commit to anybody. I'm not going to tell anybody. But nights and weekends, let's start working on it. And then I built up in C. There's this thing called the preprocessor, which people don't like, but it's actually hard and a bunch of weird things like trigraphs and stuff like that that are really nasty. And it's the crux of Tyler. They're working on the parser and kind of got you know what? It's actually everybody's saying that it's possible, but it's actually just hard. Um, Eventually told the manager about it. Oh wow, great, we need to solve this problem. Oh, this is like it working. And C++, for example, huge language, always it's very nearly impossible, but it's just really, really hard. And the way to get there is to build it, there, that was only possible because we're lucky to have some really exceptional engineers that do various parts of it very well. Great. But kind of a simple thing. So we came from, we were just finishing off the first version of C++ support in Slang. And plus, very formidable and very important language, but it's also ugly in ways. And you can't implement C++ without thinking there has to be better things. I started working with Swift again. So for ambition doesn't go anywhere, just let's see what's done. We're done with this thing. Just me for time, not telling anybody about it, kind of thing. And it made some progress. Actually, talking with the software at the time, Bertrand's delay. Bertrand was very encouraging. Well, let's have fun talk about this, and language guy, and help guide some of these to really work. Encouraged me, like, got things off the ground, and eventually my manager and told people, and it started making progress. The complicated thing was that the idea of doing a language is not obvious to anybody, including myself. The tone at the time was that the iPhone was successful because of Objective-C. Right? Not just by the board, just because. And down to the time, Apple was hiring software people who loved Objective-C. Right? And it wasn't that they liked Objective-C. They loved Objective-C, and that's why they got hired. But you had a software team that leadership in many cases went all the way back to NAC, where Objective-C really became real, and they quote unquote grew up writing Objective-C. Many of the individual engineers all were hired because of this notion of okay, well, language was kind of theoretical, right? Meanwhile, my sense was that the outside community wasn't really in love with Objective-C. Some people were, some of them outspoken, but other people being challenged as very sharp corners of so the challenge of making stuff happen technical is the part of what we do. Like if we do a new language, which is Apple, many things happen, right? So if we ship it, what is the metric? Why wouldn't we make Objective-C better? If Objective-C has problems, let's file off those rough corners. One of the major things that became the reason to do this was safety, memory safety. And the way Objective-C works, that a lot of the object systems and everything else built on pointers and use an extension on top. So pointers are unsafe, and the
get rid of the pointers, it's not objective anymore. So fundamentally, that was an issue that could not fix safety and memory safety without fundamentally changing language. So once we got through that part of the mental process and the thought process, it became design process. And okay, well, what is good? How do we think of this? And what are we looking for? And that was very different. Well, what are some design choices early on? Like we're talking about basic, are you thinking of type language or not? Yeah. All those kinds of things. Yeah. So some of those were obvious. So a type language, for example, type language. Going with non-type language, um, really seriously. One the performance and one the refactoring. That's a good example. Quick dumb question. Yeah. Obvious. Obvious language. Compiled language. Yes, that's not a dumb question. Earlier, I think in the 90s, Apple is seriously considered moving its development experience to Java. But what started in 2010 was several years after the iPhone. The iPhone was definitely on an upward trajectory, and the iPhone was still memory constrained, right? And so being able to compile the code and then ship it, and having standalone code that is not compiled is a very big deal. It's very much part of the Apple values. JavaScript's also a thing. I mean, it's not exclusive, and technologies are good how they're applied, right? But the design of Swift saying like how to make it better, right? Objectives exactly compiled, and that was a natural thing to do. Skip ahead a little bit. I go right back to the question about the 2009. Work with Google, TensorFlow, and so on. Again, static. The right thing. The right thing. Yeah. So the funny thing, after working on compilers for a really long time, this is one of the things that is helpful. That I don't look at compilation as being static or dynamic or interpreted or not vector. One of the cool things about Swift is it's actually dynamically compiled. Interpreted, then nobody's actually done that. And so what ends up happening is you use Swift in workbook, for example, in Colab or in Jupyter, actually dynamically compiling the statements that you execute. Let's get back to the software engineering problems, right? Where if you layer the stack properly, you can actually change how and when things get compiled to the right abstraction. So the way that the Colab workbook works Swift is that start heading into it, it creates a process, a Unix process. That line of code you type in, it compiles it through the Swift compiler, the front end part, and then the optimizer compiles code, and then it injects it into that process. So as you're typing new stuff, it's putting in new code, overwriting, replacing, updating code in place. The fact that it's not an accident design for this, but it's an important part of how it's set up, and how it's layered, and non-obvious. One of the things that, for me, a very strong design point is learn it very quickly. So from a language design perspective, the thing that I always go back to is the UI principle of progressive. So in Swift, you can start by saying print world, right? And no /n, just like Python, line of code, no main, no header files, no public class void, blah 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 string like Java has, right? One line of code, right? Keep that and it's great. Then you can say, well, let's introduce variables. Declare a variable, var, so var x equals 4. What is a variable? You can x equals 1. This is what it means. Okay, we'll have to control flow. This is when it or for this is what it allows. You can say let's introduce functions, right? And many languages like Python had this kind of notion of let's introduce small things, complexity.
classes, and then you can add generics, splits, and then you can modules and build out in terms of the things you're expressing. But this is not very typical for. So this was a very strong design point, and one of the reasons Swift in general is designed factoring of complexity in mind. The language can express powerful things, if you want to, but it has a very high level of the perfect blend. Have very advanced library writers, you have to use the security details, but then other people just want to use libraries to work in a higher abstraction.
Kind of cool that I saw that interoperability. I can't pronounce that word stuff, but you can just drag in Python. And you can like so this demo, for example, like how do you make that happen?
Yeah, well,
That's a couple.
yeah,
That is easy to look or
yes, it's easy. That's not a page magic hack or anything like that.
no, I don't mean from perspective. I mean
So it's easy once all the pieces are in place. The way it works. So if you think about a dynamic language, think about it as it has a what most, or you can say it has one type. It has one type, and it's like the Python object. Python object around, and because it's one type. So what happens with Python talking to each other? Swift has lots of arrays, has strings, all like classes, that kind of stuff. It now has a Python object. There is one Python object type. Import NumPy. Yeah, Python object is the NumPy module. You say NP.array. It says, okay, hey Python object, I have no idea what you are. Give me your array member. Okay, cool. It's dynamic stuff, talks to the Python interpreter and says, hey Python, what's the .array member in that Python object? Gives you back another Python object. Now you say parentheses call and the arguments you can pass, and then it says, hey, Python object that is called of np.array, call with these arguments. Right? Again, calling into the Python interpreter to do that work. So right now, this is all really. If you dive into the code, the Python module in Swift is something like 1,200 lines of code, written in pure Swift, super simple, and it's built on top of the C interoperability, talks to the Python interpreter. But making that possible required us to add two major language features to Swift to express these dynamic calls and dynamic members. And so what we've done over the last year is we propose, implement, standardize, distributed language features to the Swift language or to make it so it is really trivial. Right? The things about Swift is critical to the Swift retensible work, we add new language features. The bar for adding those time, but
Google doing incredible work. Several things because of us. So because of 2.0, whatever leading up to 2.0 has by default 2.0 has easier execution. And in order to make code optimized or something computation or graph. What's that process like? What are the challenges there?
Yeah, so I'm tangentially involved in this, but the way that it works autograph, mark your function with the decorator. When Python calls it, that decorator is invoked, and it says, before I call this function, you transform it. And so the way autograph works, as far as I understand, is it actually Python parser parse that, turn into syntax tree. Now it's like either technique to again transform the so it's saying, hey, I have an if statement, I'm going to create an node in the graph. You have multiply, well, I'll turn that into multiply node in the graph. That's the tree tree.
So where does the Swift extensible come in? The parallels. And for one, Swift is the interface like Python is extensible, but it seems like there's a lot more going on than just the language itself.
called front-end testing. So Swift and Python, Go and Rust share graphs and all the runtime, everything. So for TensorFlow is merely another front end for TensorFlow, just like any of these other. There's a major difference between, I would say, three camps of technology. There's Python, which is a special case, because the vast majority of the community efforts go to Python. Python has just for automation, APIs, and all this stuff. There's Swift, which we'll talk about in a second. Then there's kind of everything else. Everything else are effectively language bindings. They call into the runtime, but they're not, usually don't have automatic don't find anything other than APIs called APIs and kind of wrappers. Swift is really kind of special. It's a very different approach. Very different approach because there we're saying, look at all the problems we solve full stack of TensorFlow compilation process. Think about it that way. Because TensorFlow is not a compiler. It's a model. It makes them go fast on hardware. That's what a compiler does. It has front end, it has an optimizer, and it has many backends. So think about it the right way, or if you look at it in a particular way, it is a and so Swift is merely another front end that is saying the design will say, let's look at all the problems we face as machine learning practitioners. What is the best possible way to do that? The fact that we can change literally anything with the stack. Python, for example, where the vast majority of the engineering effort is done, is constrained by being the best possible thing you can do with the Python library. There are no Python language features that are added because of machine learning. They added a matrix multiplication operator with that, but that's it. So with Swift, it's hard. You can add language features to the language and process that. So we look at these things and say, well, what is the right division of the programmer and the compiler? Swift has a number of things to shift that balance. So because it has a type system, for example, it makes certain things possible for analysis of code, and the compiler can automatically build graphs for you without you thinking about them. That's a big deal for a programmer. You get clustering and fusion and optimization and things like that without you as a programmer having to manually do it because it's for you. Automatic differentiation is another big deal. I think one of the key contributions of the Swift TensorFlow project is that there's this entire body of work on automatic differentiation that dates back to the Fortran. People doing a tremendous amount of numerical in Fortran to write these what they call source translators, where you take a bunch of code, shove it into a mini compiler, and it would push out more Fortran code, but it would generate backwards passes for your function. So in that work in the 70s, tremendous number of optimizations, tremendous number of numerical instability and other kinds of problems developed, but they're very difficult to support in a world where your execution begins op by op. You need to be able to look at your function and give a reason. So when you have a language integrated automatic differentiation, things the project, you can open all these techniques in familiar ways. But the language integration piece has much design room in it.
The other here that's kind of interesting is so we're in the new world with deep learning, constantly changing it. I imagine the disclosing. I imagine you're still innovating in new front too.
Indeed.
So how much sort of software and hardware and trying to figure out how to together move towards the optimal?
It's an incredible amount. We're on our third generation for now 100 petaflops in a very large box, virtual box covered. And I imagine we're not out of ideas yet. The great thing about
is there a perfect example of hardware software? So it's about saying what hardware do we build to solve certain classes of machine learning problems? Well, the algorithm, the hardware takes, is to produce, right? So you have to make bets and decide what happens. And so, and the best way to set transistors to get maximum performance watt or area, like whatever it is you're on. So one of the amazing things about is this numeric format called P-flip. Is a compressed 16-bit floating point format, but it puts it in place in numeric terms as a smaller mantic than a larger exponent. That means less precise, but it can represent larger ranges of values. Machine learning context is important and useful because sometimes you have very small gradients you want to accumulate and very, very small numbers that are important things that you're learning. But sometimes you have very large people not as precise scientists. But it turns out the machine learning algorithms actually want to generalize. So there's actually the network to generalize across data sets. Regardless of whether it's good or bad, it's cheaper to hardware that because the area times of a multiplier is n squared the number of semantic, but it's linear with the size of the exponent. So it's a big deal. Both on the hardware and the software side. Yeah, so that was a breakthrough from research science working on optimizing network transport of weight across the network originally, to find ways to compress that. But then it got burned into and part of what makes performance so great. TPUs have many different aspects of their, but the co-design between low-level compiler bits, or bits, algorithms, is all super important. It's amazing trifecta that only people can do. Yeah. Can you tell me about MLIR project, the creative one? Yeah, so MLIR is a project that we announced at a compiler conference 3 weeks ago, the Compilers for Machine Learning Conference. Basically, again, if people can tell as a compiler set, it has a number of compiler algorithms in it. It also has a number of compilers that get embedded into it. They're made by different vendors. For example, Google has XLA, which is a great compiler system. NVIDIA has TensorRT, Intel has ngraph. A number of these compilers, they're very hardware specific and they try to solve problems, but they're all kind of similar in a sense as they want to integrate with it. So TensorFlow has an and it has these code generation technologies. And the idea of MLIR is to build a common infrastructure to support all these different subsystems. Initially, it's able to make it so that they all plug in together and they can share with a lot more code and be reusable. But over time, we hope that people start collaborating and sharing code, and instead of reinventing the same things over and over again, actually fosters that working together to solve common problems, which been used by other people before. Beyond that, MLIR is a joke kind of LLVM2 learns a lot about what LLVM has done, what LLVM has done wrong. The chance to fix that. There are challenges in the LLVM ecosystem as well, where LLVM is very good at the thing it was designed to do, but 20 years later the world changed and people are trying to solve higher level problems and we need these technology. And what's your content? Very so it is not yet open source, but we hope the value as oh yeah, absolutely. And I think that's for community large. That's there is a example where you were previous and now culture. I would say some of the moment in the history of software. There's a large company, a very large program. What are your thoughts on that? How happy or not with that kind of table? But between I prefer the approach. That's what the Apple approach
Apple came from, but that's been 35 years ago. Apple is definitely adapting. The way I look at it, there's different kinds of concerns, right? It's very rational for business to care about making money. That fundamentally is what a business is about, right? But I think it's also incredibly realistic to say it's not your string library that's the main thing. Why product differentiating features and other things like that to keep up of your string library. So keeping your string library proprietary and secret isn't maybe not the important thing anymore, right? Or before, platforms were different. Even 15 years ago, different. The world is changing. So Google strikes a very good balance. I think the concept of being open source really changed the entire machine learning caused a revolution in its own right. Amazing because I could have imagined, I wasn't at Google at the time, but I could imagine a different context in the world where the company says machine learning is critical to what we're doing, we're not going to keep it. Right. So that just profoundly brilliant insight that I think has really led to the world being better and better for Google as well.
And has all kinds of is really, I mean, you can't understand people deciding how profound software is.
Well, and again, I can understand the concern about if we release our machine learning software, our competitors can be faster. On the other hand, I think that's I'm sure that obviously that's very non-obvious, but I think it felt very well.
So let's try this real quick.
Yeah.
We're at Tesla for 5 months. The VP bought a software he wanted to do during the transition change. One, number two, a couple questions. One, first of all, to me, one of the bravest engineering undertaking, like undertaken really ever in the automotive industry, software wise, starting from scratch. It's really brave. So my one question there is, what was that like? Challenge of that?
You mean the career decision of jumping from a comfortable job and known, or
that combined with at the levels you making that decision, and then when you show up, you know, it's a really hard engineering.
Yes.
Could say slow down, say hardware one, or those kinds of taking a toll on let's scratch. What was that like?
Well, so I mean, I don't think Tesla has a culture of taking things slow and seeing how it goes. I mean, one of the things that attracted me about Tesla is very much a gung ho, let's change the world, let's figure it out. So I have a huge amount of respect for that. Tesla has done very smart things with hardware one in particular. The hardware one design was originally designed very simple automation features in the car for like traffic aware cruise control and things like that. The fact that they were able to effectively feature creep it into lane holding and a very driver assistance feature is pretty astounding given the hardware. Hardware 2 built on that in a lot of ways. The challenge there was that they were transitioning from a third-party provided stack to an in-house. So for the first step, which I was getting onto that new stack, and that was very challenging. And it was kind of critical for various reasons. That was a big, but it was fortunate that a lot of the knowledge and expertise for driver assistance features.
So you collected time with what you found in Tesla. It was ultimately not Elon Musk podcast, of course, Elon Musk is some of the most bold innovative engineering work in the world. At times it cost some of the numbers of Tesla. What did you learn about this working on it?
Yeah, so I guess I was at Tesla. I experienced the highest degree of turnover I'd ever. But one of the things I learned, and I came to respect, Elon's able to attract amazing talent. He has a very clear vision and he can get because they want that to happen. Right. the power of vision is something that I have a tremendous respect for, and I think Elon is fairly popular in the world in terms of being able to get people very, very. There may be people in a big corner and say, we're going to go to Mars, right? But then there are a few people that can get others to buy into it and lead the path and make it happen. So I respect that. I don't respect all of his methods, but I have a huge amount of respect.
You mentioned a few places, including in this context, working hard. What does it mean to work hard back in your life? What were some of the periods of having to everything happen?
Yeah, good question. So working hard, we find a lot of different, a lot of hours. That is true. I think it's the hardest is both being firm focused on delivering an outcome, but also thinking about the long term balance, right? Because you are myopically focused on solving a task and getting it done. Think about that incremental next step. You'll miss the next big, right? So I've been really fortunate that I've been able to kind of oscillate between them. And historically, Apple, for example, that was possible. I was able to work with some amazing people, build teams of leadership structure, and allow them to grow in their careers and take on responsibility, thereby freeing up me to do the crazy came up the next time. So about that. But it's also about if you take actions that other people don't take. So I think that's a big part as well. But bedrock is just a lot of hours. That's a good thing. There's different theories on work-life balance. My theory for myself, which I do not project on the team, but my theory for myself is that I want to love what I'm doing and work really hard, and my purpose, I feel like my goal is to change the world and make it a better place. That's what I'm really motivated.
So last question. LLVM logo dragon. Explain the dragon, the connotation, also modular, the other part. What is your favorite dragon-related character from the
They're all very kind ways of explaining it. You want to know the real reason it's a dragon?
Yeah.
And so there's a seminal book on compiler design called the Dragon Book. So this is a book on compilers, and so the dragon logo for LLVM came about because at Apple we kept talking about LLVM related technologies. So there's no logo put on a slide. We're like, what do we do? And somebody's like, well, what kind of logo should compiler? And I'm like, I don't know. I mean, the dragon is the best thing. Apple somehow magically came up with the logo, and it was a great thing, and the whole community rallied around it, and it got better as other graphic designers got involved. That's originally where it came from. So,
is there a dragon that was that Game of Thrones, Lord of the Rings, that kind of thing?
Lord of the Rings is great. I also like role-playing games. The role-playing game, the dragon. But really, back to but oh no, we need a thing. And hilariously, one of the funny things about LVM is that my wife runs the foundation, goes to Grace Hopper and is trying to get more women involved. She's also a compiler engineer, trying to get other interested in compilers and things like that. So she hands out stickers. People like the LVM. And so sometimes culture has helpful effects. Like generation compiler engineers engaged.
Okay, awesome. Chris,
Great talking.
conversation project. He's an engineer director of Google. TensorFlow, an open source library at the center of much of the work going on in the world of learning, cutting edge research and the large scale applications of learning based approaches. It's becoming much more than a software library. Now, an ecosystem learning and machine learning in the cloud, on the phone, in the browser, on both generic and specialized hardware. Plus, big emphasis on passion community development. Project, their team, large team of engineers are working to find the future of learning, TensorFlow 2.0, which is now in alpha. I think the first TensorFlow moment second open innovation investment. Many companies to open code, publish, and in general engage in open ideas. This conversation is part of the Artificial Intelligence podcast. You can do it. Subscribe on YouTube, iTunes, or simply connect with me on Twitter at FRID. And now, here's my conversation with Project Mamba. You were involved with Google Brain's start 2011 with FD. Started with the proprietary machine learning library and turned to TensorFlow 2015, the open source library. So, what were the early days of like? What were the goals, missions? How did you proceed forward with possible for you? Think back then when I started talking about it, the idea of learning was intriguing in some ways. It hadn't yet taken off, but it held some promise. It shows very promising early results. I think that the idea where Andrew started was, what if what really relates to what Google has in computing power, and also put that kind of data together. What does it? And so far, the results, if you scale the computer, the data, it does kind of not work. And so that was the first year to prove that out. And as you started the first year, we got some early wins, which always. What were the wins like? What was the wins where you were, there's a promise, this is good? I think two early were one was that we collaborated very closely. The other one was on images where the cat first knowledge was covered by love. And the birth of Google Brain was around neural networks. That was deep learning from the very beginning. That was so. But in terms of scale, what was the sort of dream of what the echoes of the open source TensorFlow that might be brought in? Was there a sense of like machine learning is not going to be for the entire company? It's going to grow into that direction. Yeah, I think that was interesting. Like if I think back to first get it, a year or so we had started scaling it to hundreds of thousands. We had runs into that, and all of those great problems. In terms of learning at Google, the good thing was machine learning for a long time. Learning was new, but as it scaled up, it showed that that was possible. Back lots of started to get one first, where image photos came out of the that was exciting. As went into with that a couple of years, suddenly also I started to lots of okay, deep learning is interesting, doing more. So by 2014, we were looking at control and not just externally ahead of everybody is, but among the so the open source. I was just chatting with Chris Gladner about the open source flow. I would say is that personally one of the big seminal moments of software engineering company like Google decides to make a large project that players might argue a lot of IP, decide to go open source it and in the entire world and saying, you know what, it's a pretty powerful thing. And it's okay. That was incredible, incredible. Do you remember discussion happening? Yeah, they're open happening. What was that like? I would say the initial idea from came off of things. One was for putting a lot of these things out there. People really want all these research and they got forward. And part of that was because it helped fast. So the next step was would software help with that? Like where existing two libraries out there, others, but they were all developed and the level. The other one was software perspective on lots of software or in the published papers. Often there was an open source project that someone else picked up that place. Back then it was like, okay, there's Hadoop. So the tech people that better for a number of and turns out and they're now not really providing our tech, but they can give us those. They're going to now provide APIs on top of that. It's as good as like something that is very right. Community loves it, but also helps push the right a good. So how does cloud, the TensorFlow open source right library, and how does the fact that you can use versus enterprise and the cloud fit that strategy? So TensorFlow itself is open and right, and we're sure that continues the case. On Google Cloud, make sure that integration want to make sure that you're leading the TensorFlow effort, the history time on TensorFlow project, if you're behind this like open source, but really, what's about there's incredible that well, there's all these parts, but some ample moment that I became. I don't know if you can history, but in deep learning, everything moves so fast that years of already history. So back, we're building open source in 2015. Started on it summer of 2014, and somewhere like 2014. By then, we decided like okay, there's a highlight first started about that in short period like that. At that point, by that point, we had lots of different that group, things like motor, large yes, or different kind of hardware, GPU type, like CPU type, trying started to push on mobile, so we're running models that were customizing code in order to make sense of that part of overall design. Mobile, like pretty complicated algorithms running well. That's good. When you have a model that like on it, already at that time there was learning machine learning on it. That's good. We already had and in those cases basically customized crafted code or something. So I was actually at Google by parallel. some degree to which you're balancing it, like trying to see what cafe was offering people, trying to see what piano was offering, that you want to make sure you're delivering whatever that is. Perhaps Python part of that influence. Um, so when you build systems, and some of that was parallel with some of the libraries coming from office there, but we're just on our own. By the time we got to this, we prepared a number of libraries who had experience with George, with folks here who were very branching. There's I think we looked at a number of where you have looked at China back then, trying to of course API implementation. The graphs were not, and they were supporting all these together was wanted limitation prior view of the words. So as we ability, we want the hardware as we that's how we were ability express on that. What the graph is with our sense of flow 2.0, there's more by default will be compared to sort of hiding the graph because less developed on what was that like with using graphs? It's kind of the piano way, the obvious choice. So I think where it came from was or like belief had a graph like that well, a much more simple it's more like a graph, it was more like a line thing. What you might think of cafe. But the graph was we always cared about the graph. So it were deploying a bunch of so as it came from that when sort of that might get a lot simpler to do, but not having a graph. How do you define what balance classic and I guess the question I mean production focus on but did you even anticipate the other side of it could be what are the numbers something crazy 1 million downloads I mean was that even like a possibility in your mind that as popular so I think it is this a lot from the research perspective and like earning some 41 million no I don't think that's not there it seems like there's like potential future where lots of this I would say kind of growth probably more after the open sourcing where we're like okay learning actually growing a lot of different reasons on that and leverage that deliver lots of what change was the open source like how this incredible amount of attention from a global population of developers but how do the projects start changing makes people remember it, those times and I know now there's documentation community well there's a YouTube channel now yeah very driven back then I guess 2.1 version that's the version I think called 6.5 change leading to it's interesting you know I think we've gone there when we started out when we people love documentation so huge step up from it all of the production of people I think what changed was the deep learning pushed
some people who just developers suddenly get out and interested, right? Who had the work money before that, and that I think really how started to have pushed out. Over the next few months, we start to stabilize as we look at not just measures. Now we want to stabilize it more supply chain. That's how we start for that perspective and uh, start providing factors where more and more enterprises want to combine that or not or in next either they dream that so it was okay of course there's a lot of talk about this. I imagine anything well 1.0 is pressure to enterprise probably wants to stable and in a sense now the sense of flow it feels like learning in general is extremely dynamic so much have and sense of flow is growing incredibly sense of stability at the helm of it. Yeah, I know you're in the midst of it, but yeah, it's I think in the midst of it, it's often forget what enterprise wants and what that's there's running models that are 3 4 years old. I'm just for a couple of years now or more. And they're fine. Even the last couple of percent or quality does work. And value in providing that making it because that allows more. And then there's the child one. Okay, middle like not deep learning that models one and the learners are transformers now and combine the data and so there's definitely that area that like the boundary that's yard. But I think what it's much more and even stuff that years old, it's very, very partly. I imagine maybe you can correct me if I'm wrong. One of the biggest cases essentially taking like residency and kind of transfer learning on a very particular property. Basically probably what the majority does. And you want to make that as I would say for the whole perspective, common case, right? Back to apps, ones or new ones common. I would say there are a couple of reasons for that. One is that written slides, that's true. Yeah, what enterprises want, that is part of it, but that's not what enterprises are like restrictions on stuff. Was dashing models or creating trees. Sometimes still benefit from deep learning. You want that's the depending on the audience. And they just have the best of enterprise probably just has a very large that for deep learning probably time. And the other people that they want it's again they want the developers somebody we put together and their piece type trust they want I don't train a model that every I wonder if you think the role in I don't know, so I teach a course learning and people like lawyers and say one is learning good at your go around and all kinds of disciplines
what I see what it boils down to, these companies are often a little bit old school in the way they organize it. Data is not ready. You also find yourself being in the role an evangelist for like, uh, let's organize your data, get the benefits, get those, have those conversations.
I get all kinds of questions there from, okay, what do I need? Learning when they're already, I don't have enough time, or, what do you learning? So, like, to all the way to experts who are very specific.
Is there a good answer? It boils down to oftentimes digitizing whatever you want automated, so whatever data you want to make predictions on, make sure that it's in an organized form. Like within a sensitive place, now providing more and more data sets, pre-trained models, finding yourself also an organizer. That's
Yes, data that's come up with one these here, one important thing. The other related thing I would say that I often tell people, don't think of the fancy thing that something very basic work can lots of things can do.
yeah, start with the basic truth. One of the big things that makes it more acceptable whenever that happened of the care standard outside of I think it was Keras on top of piano at first only, and then Keras became on top of that. You know, when Keras chose to also add TensorFlow to the back end, was it that drove that initially? You know, the discussion, conversation.
Yeah, so Alonso started his project before he was, and he was I remember after. Then at some point when it started becoming popular, there were enough similarities. I put at my where he joined Google, so I when you're talking about that, he thought that anyway. In fact, I find out about him once after he like project.
I wish he wasn't like part of TensorFlow joined.
Joined matter. And at some point, people realized, oh, he's doing this stuff, like the API, and he's right here. So after him, and okay, I don't like come over to your team and work with you for a quarter. Let's make project manager. Sure, quarter's fine. And that quarter,
So Keras got integrated TensorFlow like deep way. Now with 2.0, 2.0, Keras is kind of the recommended way for beginners to interact with it. Makes that initial sort of transfer learning or basic use case even for enterprise percent. So what was that decision like? That seems like kind of a bold decision. Oh well.
What'd you say?
a lot of time that
What'd you say?
I
love you too, big dog.
Like, yeah, awesome share all the stuff. They were also like APIs that over time. One of the messages modeling this one and modeling this one. Like, that's sort of like, okay, had to address that later on with 2.0. The idea was one. Some maybe where we were like, okay, let's see what are the like. There's a very one that lots of about. There were lots of great things about it. Uh, Organically, that's kind of the best way to do it. Great. It was surprising there were less and outside. I mean, there was a feeling like Karis might be almost like a competitor, kind of a defensive blow, and this became an empowering element. Well, that's right. Yeah, it's interesting how you can put two things together with can't align by it. I think Francois, the when I did a bunch of gathered in, I think we all want to see the same kind of thing. We all care about making for the huge set of developers out there.
So Python has Guido and Rothschild, who until recently held the position of Netherlands life. Right? So there's a huge successful open source project like TensorFlow needs one person to make the final decision. You've been a pretty successful TensorFlow dev summit now the last couple of days. Clearly a lot of different features incorporated and so on. How are those designs made? Is there a VDFL and TensorFlow and or is it more distributed?
I think it's somewhat say I've always been in the design directions, but there's lots of things that are just there. The number of people on really driven a lot of open source stuff, a lot of APIs, and the number of other which different parts of it. Have design reviews the last year, a lot of time up to the community, getting more process in place, so just grow that community and that get kind of scale because then I don't think scale that has the point of it.
So yeah, the growth of that ecosystem. Talk about it a little bit. First of all, when I started with Andre Karpathy when he found that JS, the fact that you can train and build network in the browser in JavaScript is incredible. But on TensorFlow JS is really serious, like a thing to operate with it back end and front end. And there's the TensorFlow extended mentioned. There's TensorFlow Lite mobile. All of it, as far as I can tell, is converging towards being able to, save models and kind of move around, train on the desktop and mobile and so on. I coached in this, so
How you living, Pim?
whatever I need.
Hello. How'd you find out about me? Excellent. We're watching a podcast. Feel free to enjoy. Okay.
Lots of so that's one direction. The other is trust. Right. Um, at high level, one way I think about it is there devices often and one of the books or the center like running
developers. And so the way I've about how to help learning happen. So the tag aspect of tag and go over like cover more first time. So around that to help you find was or you want to train uh pipelines or about all that production. The edge kinds of things. And it's not just us though. Um, lots of times from talk some like project or focusing kinds like I actually focus across other there are different parts of the cloud and the our goal is that right but not in one but full other work broader community that about that and help encourage that and um that's exciting not just one of the things about I know that is okay we have freedom right how do we help work that together if you're pushing on one more format and then how we share modeling skills modeling content so how um very skeptical of that in terms of I didn't see yes it's a very difficult project standalone is not as difficult but integration is there, I mean there's a lot of aspects of it but technical stuff how many challenges have to do lot and it still has that's the question there are lots of I think we were for the last years there's a lot I often been thinking together well that's exactly the point but there are lots of people behind that I think about still challenges ahead there are we have a lot more devices on board for example hardware perspective how do we make for the users so a lot of compiler stuff that others are working on or APIs as TensorFlow started as a very monolithic there's lots of tools around it but the core part monolithic challenges for us to scale that out is how do we break that apart with in some one but for a system that's now I guess or more and that's rapidly evolving and that's with hard to modify and break apart sort of like a they call it running so there's a challenge here. The downside of so many people excited about TensorFlow and coming to rely on it application is that you're kind of responsible like it's technical that you're responsible for previous some degree trying to innovate I mean probably easier just start from scratch every few months so you feel the pain of that 2.0 does break some back compatibility but not too much
want to look at that code again, it doesn't matter. There are a lot of productions that are very intensive, both have Google and crossover. People worry about this. They're done for a long time. So it is important compatibility. With cost, there's have to a lot of things. I think like value because of that much bigger because it's not just about the person, also about the person tomorrow. You know what? How we when you work with work. Hey, one way I like to think about this, and I always think about it, well, if you want to do was aim really like, and then you'll figure out how to for all the other things. Yes, you do compromise, but unless you're design with the team, not worry about that. So I get to a place. So even if you are responsible when you're in the idea stage, if you put all that behind you, that's right. Okay, that's really good. So I have to ask this. A lot of people ask me how I feel about PyTorch as a product. Recently, as a I wish everything was that as but do you enjoy competition? That's eating in many ways. Make you mention momentum, power, production level, so on. But, a lot of research now enjoy that kind of competition or do you ignore it on as the best. So, like learning, like kind of, and target principle like earlier. One, it's really important for us to have production. One, just and that's what I don't came along and said, you know what, I only care about research. What's the best? I started trading. I don't worry about graphs. It's not as fast, but let me just start. And there are things to learn from that, right? Again, and benefit what had come before, but also different kinds of good things there, depending on what you before that. So, competition definitely there's the area that we talked about, like early on, the time we had visited a couple of times, we had the, at some point, we thought, like, can be well, so let's try it again. And, agree together, finally come well together, but it took us a while to get to the point. Let me, ask another way. I think with Muhammad Ali or Frazier, right? Do you think it would have been added quickly there? It might have taken long. Yeah. It was, we had tried made it before, so but it's like, I'm grateful that TensorFlow is part of just work class. What other things you can talk about are you looking know that it comes and so talk about some ecosystem stuff. You get customer errors, your execution, the other things yeah, so I would say one is where principle is and talked about. I think as on that lots and what it sets us up for the what the users want. What it does also allows us to do a whole bunch of stuff behind the scenes. So, for example, so graphs, knowledge,
always get a lot of good issues right? And on that, plus that point out, guys, where we are, feel a lot of performance, whatever you know, let's keep our most like on the optimize that and a lot of those things out. It really allows us to on other things as well. Right now, about that, the other piece that I was talking about is modular. That's really important for a lot of the other people, other organizations and so on that want to elaborate a little bit with you, but as a flow more modular. So they organize in lots of repositories organization. It can more one where we have tens as the execution engine, CPUs as the work and stuff. And all of these work together in a single library on Binary. There's no irrespective of body. There are some individuals within it. In a perfect world, you would have, okay, I want to run it on my fancy custom networking, then this and that. I mean, kind of support that, but hard to starting to more some of these and again, to the large size of because group involved there, enable and by people mean it developers and an organization. The hope is that everybody sort of major, I don't know, major corporations put a test as well. Yeah, if you get enterprises like that, a lot of them are already, they are not the ones that develop the protein. Some of them do, but a lot of them don't, and they touch research. There are something let's say vendors who are doing the custom or some or special a lot of users who want certain optimized a pharmaceutical company perhaps. So yeah, like I mentioned, Tesla has been downloaded 41 million times, 50,000, almost 10,000, and 800. So I'm not sure if you can explain it, but what does it like that? What in retrospect, what is the critical thing that allows the growth to happen, and how does that go? Yeah. Yeah, that's an interesting question. I had all the answers, I guess, complicated. I think there are a number of things that need to come together, right? One, like, think about part of timing, what's needed, does it what's example, not just growth, also growth of learning itself. Other than that, though, I think community warfare, people think open, like, spend a lot of time for contributions as well. Contributing was putting the process in place, right kind of community, and so on. Like for the last transfer, that's important for the project. We're like, okay, process do that. Lots of community as that you as a small project to do those. And so, being one of the processes the document about what developers and about what kind of tools they want to use. One of these. So one of the big things that the TensorFlow Fire, the people building something on TensorFlow, and so, implement a particular architecture, and then implement that and world. I have a sense that 2.0 and 1.0 that maybe partitioning there's a Python 3 code base in the older versions of TensorFlow that will not be as compatible. Or it's usually a conversion pretty naturally. So it's hard to make that once talked about it for some sure best of that to it. It's 50 version changes, that's all the reason really pushing hard to actions of anyway. I think at some level want to move it only for a move. Most people want to live with that. And over the next few months value definitely shift happen. Either as you said earlier, the reality that also one thing very so lots of what do you think as a full point out? That there are things happening so crazily that end of or it's possible plan for the next 5 years. I think there's something that we can expect in terms of are there some going to stick around, something not going to stick around? I would say the basics of deep learning, the convolutional ones, or the kind of they'll probably stay around it. With RNN GANs, very likely they are how very hard to predict. Directionally, some things that we can see is starting to do right for projects right now. Just finding distribution and fast, they're starting to make it more like match trying to advance ideas if that's the right direction. Ideas active more I don't know if it'll other aspects so we able to train with more bits. I think the TPU side of things on a TPU third and version 3. It seems that the evolution of TPU and TensorFlow are they're co-evolving. Both are learning from each other, from the community, and from the application. Biggest benefit. And trying to keep it with Keras and make TensorFlow as accessible and easy as possible. I think together struggle with that you element that, or is Keras solving it that you're like we talked about? Yeah, for some of them, like you said, right, the inner point is funny. Some train transfer learning on kind of model. Make that easy important. In some ways, that by providing them models or so on, not watching God, but then I will guide there's probably on that. Then for the search, then there are probably custom layers themselves. So there's a whole spectrum there. And then providing the pre-trained models increase the time from trying you could basically about notebook so I basically answering my own question because it would test it. So I was just wondering if there was other was trying to but I'm not sure there. But probably I think high schoolers was amazing terrifying. Yes. That they grow up they some incredible ideas of them. So there's technical aspects of work, but you also have a management aspect role with TensorFlow project, a large number of developers and people. So what do you think? Google's been at the forefront of exploring and TensorFlow is one of the most cutting edge technologies in context. Definitely something that takes about able to deliver something well. One of the things that's important is a cohesion across it. Not in it. Like at this scale, standards here can only much talk together. Stars across but often I see the product of what is larger than whole together. Have together. So I think but part of that is not just that of it, but it's not together. Also people have to care about what they're building. That's or the right kind important factor. And finally how do you put that together? Migration go are we all action or and sometimes it's a very bottom up organization or recently more so always where that become large product line back. So there's place that's actually the way you monitor the health like is the way you know you did a good job. That's good. Like I mean you sort of nice determine how aligned it's not binary, it's not like a on and the other element of superstars, so much in Google, large percentage of work is done by individual superstars. Yeah, and sometimes it has to be against the dynamic of was that has I mean I'm sure it might be a little easier because of the you're at the cutting edge exciting. Yep. And you can struggle with that as a challenge. That said, I think we've been what's good about getting people who care and are have kind of culture that's large extent, but also like you said, even the project has so many exciting things to do. There's been for lots of growth, which does make the problem allows what they're doing zoom around them time. Yes, we care about whether I don't know if it work well with us years are not the productivity broadly about the team. Yeah. That's a lot of so in hiring engineers it's so interesting. right, the hiring process. What do you look for? How do you determine a good developer, a good member of a team for hours together?
Yeah.
Get no magic answers, I'm sure.
Yeah, I mean, Google has a hiring process over 20 years, I guess. Probably heard it a lot of work with this hiring process. For me in particular, I would say, in addition to more technical skills, what does matter is their motivation. Because if it doesn't align well with their, that's not going to lead them on. It becomes more important with more senior professionals, but again, a human junior person is not motivated to do well at what they're doing. However smart they are, it's going to be hard for them.
The whole hiring process, can that passion, like trying to determine, I think, as far as I understand, maybe you can speak to it, that the hiring process helps the initial, like, determine skill set there, is your puzzle solving ability, problem solving ability good, but, like, I'm not sure, but determining whether the person has fire inside them,
Yeah.
that they just matters. Cool stuff, but that I don't know. That's something that ultimately ends up when they have a conversation with you or gets.
So one of the things we have as part of the process, because like part of the process, in addition to that, where whoever the user is supposed to be personal concept of Kubernetes. So that is definitely part of it. Now, there are various kinds of projects and kinds of there might be the kind of culture you want there and so on. That does it. So for example, TensorFlow fast project, when people who are comfortable with that. And now, for example, we are deploying also very product and we want to make sure that work really work like and cut corners. So there are kind of people who are like those. And I think those kind of things vary a bit across projects, product across components. But a lot of it long.
What is the hardest part of your job?
I think,
I guess.
it's fun, I would say. Hard, yes. I mean, lots of things. Sometimes I think that does vary.
So let me clarify that typical things are fun.
Yeah.
When you solve them, right? Fun to that.
I think to successful thing across the board, and this is articles now, but find balance across different aspects of sometimes fast versus how perfect it is. Sometimes you evolve to evolve, good evolve, art right fit, and those are certain kinds. But they're often a hard decision. Then they don't have time. You get time to solve it.
On both choices, pretty good. And those deadlines, time flow driven by deadline, degree that a product might, or is there still a balance where less deadline? You had the Dev Summit, they came together incredibly. Looked like there's a lot of movement on. So that deadline makes people rise to the occasion. 2.0 alpha. Yeah. Sure, that was done last minute. Well, I mean, like, and then up to the best.
And those things you strike a good balance. There's some value that deadlines that does bring us urgent to get the right thing together instead of get the perfect thing out. that's good. It works well, and probably very tired, like everything. That's across the day. We deadlines focus on things that are important. Figure out what are how much of and it's developing everything. Everything look at are we do the regular line doesn't that we want to get past because and iterate and improve on things kinds of things out that aren't very short kind of out there we're trying to feedback. That's why I think that cycle and that's focus on rather than get everything. 2.0 is the pressure to make that stable or like for example press 5.0 just came out and there was no pressure. And there was a lot of build up dates late, but and they said okay, well we're gonna release a lot of updates with agree. That's that same kind of way or is there pressure to know these candidate and then you get final if that's gonna be the so it's going to be like what was that every guy there it's going to work. Doesn't can colors it doesn't act still a lot more to when we continue that's so I don't think we'll be done in like 2 I don't know if you think but is there there's not external deadlines I know but is there internal deadlines artificial or otherwise that you try and just set for yourself or is it whatever it's ready so you want it to be a great and that's something important tons of out there have 41,000 one project but it's not like pretty good yeah exactly but like a lot of the people together out there you don't have to rush that because that's the get it very that's we have said we're looking at ones in the next quarter as far as possible definitely yeah my favorite line was spring is relative concept and I love it it's spoken like a something I'm really interested in your previous line of work is for TensorFlow you let a team go on search I think this is a very interesting topic on every level on a technical because at their best as connect people to the thing they want and then the worst way I had got it the point of hire you whatever you're actually so they have a bad rep I guess and on the other end connecting users that they need and want is a beautiful opportunity for machine learning to shine. Huge amounts of data, you've got a map, they won't get so learn from this tool that have you learned from that experience and what do you think of that? Take you back to that. But yes, I totally agree with what you I think the search as they always look back and was extension of what search goal is what is information access that it's not just for products or people can really important for relying on and the search as minimum quality that actual don't have that quality cannot be sure okay the money
that is important that is really like out there. Advertising part is model models after to the web and part of search word. I do hope like you said there are ads that are not my Google website and happening United not that's going there. Um I hope we can strike a balance showing ad where it's valuable to the user and provides the motivation to the service research like their website, the monitoring for them to provide um, done good showing and stuff that is showing. So do you see it moving forward as continue being a model that that funds Google that significant uh, revenue? That's one of the most exciting things, but also limiting things of the internet is nobody wants to pay for anything. And advertisements again coupled with their best are actually really useful and not annoying. Do you continue to see that and growing and improving, or is there these sort of more Netflix models where you have to start to pay for content? I think it's a mix. It's going to take a long while to get that difficult. Everything on that. But over the last few years, I would say definitely towards more those that people are willing to pay to see value. For example, the app by more people I find are or or the good websites that wasn't years ago. And I just see that change myself as well and definitely like that next model where you can try something out for that there's a more clear model of so speaking of revenue, how is that a person who for free? What's the question is the future of TensorFlow of empowering say a class of 300 students amassed by MIT? What is going to be the future of being able to do more? Like where are they going to train networks, right? Right. What that future look like? GPUs, a number of things related. Open source, you can run it wherever you on your desktop, and your desktop's more powerful. More. Phone is like I don't know how many times powerful. Probably train on your phone though. Yeah. So that's the power you have in your hand. Clouds are actually very interesting from our courses perspective because they get very collab about it or to a website. Nothing there and so that's just about cloud as well. And so I do expect that to grow. Again, Colab is a pre-service. It's great started to play with things with more things. And really get much. So we're talking about yeah, get a lot. Great. So if I'm a beginner interested in machine learning, well, what should I do? Probably start going to our website and playing there. Just go to tesla.org. That's what I think. Check out tutorials and guides and stuff. Go to okay, awesome. I just next. conversation we have with the head of Adobe. Adobe is empowered artists, designers, minds, all professions, working for me for years. Software, Photoshop, Illustrator, Premiere, After Effects, design, software that video, working to find the evolution of products and life of the biggest here, automate the tasks, more and more time, operate yes, cutting edge learning methods, time, more than perhaps the other. Kevin, body with body, create outside of the price and both things are near and dear to my heart. Conversation part of the Artificial Intelligence podcast. US, subscribe on YouTube, iTunes, directly on Twitter, and Lux spelled FRI. Now, it's my conversation. Kevin, you're head of Adobe Research, a lot of innovative efforts. I images, video, audio, language, but you're also yourself an artist, a poet, a writer, even a roboticist. So while I promise everyone listening I will not spend time with together read poetry with love, I have to sprinkle it in a little bit. So some of them are pretty deep profound and some are light. Start with a nuance. Yeah, this is writing. You write and then a poem that beautifully parodies both. I did the house. I got the end and my way by Prince Doctor. So it opens. Now third is near. Time to take the final stride. Diet. So where does that love for poetry dissect your mind? How does it all fit together? Bigger doctor.
Well, interesting you chose that one. That was a poem I wrote when I finished my doctorate in surgery and weight and got on a diet. And well, the rational parts of my brain wants to do that. The irrational parts of my brain were protesting and embrace the opposite.
I regret nothing.
Yes, exactly. Taking it to an extreme, I thought it would be funny, obviously, it's serious topic. But I think for me, I've always been interested in writing. I was in high school as well as doing technology invention. And sometimes there are parallel strands in your life that carry on, and one is more about your private life, and one's more about your technological career. And then sort of happy moments along the way sometimes touch one idea informs the other. About that.
Writing, art, poetry contribute directly or indirectly to your research, work, and building.
Well, sometimes it does if I, say, imagine a future in a science fiction kind of way, and then once it's on paper, I think, well, why shouldn't I just do that? There was an example where when realistic voice synthesis first started in the 90s at Apple, where I worked in research, as done by a friend of mine, I sort of sat down and started writing a poem which line I would enter into the voice synthesizer and see how it sounded, and sort of wrote it to that voice. And at the time, the agents weren't very sophisticated, so they sort of had random information, and I kind of made up the poem to match the tone of the voice. It sounded slightly sad and depressed, so I pretended it was a poem written by an intelligent agent. Sort of having the users go home and leave them alone, but at the same time they were lonely and wanted to have company and learn from what we were saying. And at the time it was way beyond anything that AI could possibly do, but since then it's becoming more than the bounds of possibility. And then at the same time I had a project at home where I did sort of a smart home. This was probably 94, and I had the talking voice to remind me when I opened the door of what things I had to do. I had buttons on my washing machine because I was a bachelor. I had to close it moldy, so as I got up in the morning, the day I the washing and so on, I made photographic photo albums that use light sensors to know which page you were looking at, would send that over wireless radio to the agent and play sounds that you were looking at in the book. So I was kind of in love with this idea of magical realism and whether it was possible to do it. So that was a case where the sort of agent sort of intrigued me from a literary point of view and became a personality. Recently, I've also been plays, and when plays you write dialogue, and obviously you write a fixed set of dialogue that follows a linear narrative. But with modern agents, define a personality or a conversation, sort of thinking of, I kind of have imaginary dialogue in my head, and then I think, what would it take not only to have that be real, but for it to really know what it's talking about? So it's easy to pull into the uncanny valley with AI, where it says something it doesn't really understand, but it sounds good to the person, but you rapidly realize that it's kind of just stimulus response that doesn't really have real world knowledge about it. So when you get to that point, it really needs to have multiple ways of talking about the same concept so it really understands it. Now, what really understanding means, the whole thing, right? But if it only has one way of referring to something, it feels like it's a kind of response. You can reason about it or go at it from multiple angles, similar kind of response to people. It starts to seem more like there's something there that's you
can say the same thing multiple things from perspective. I mean, the automatic image caption that I've seen before.
Yeah.
Elements of that, right? Generate different kinds of.
Right. So one in my team, there's a lot of work on putting a medium from one form to another, whether it's auto tagging or making up full sentences about what's in the image, then changing the sentence, finding another image that matches the new sentence, or vice versa. And in the modern world of GANs, you sort of give it a description and it sizes an asset that matches the description. So I've gone on a journey. My early days in my career were about 3D graphics, sort of pioneering sort of before movies had special effects done with graphics, and sort of was through that revolution. And that was very much like the Renaissance, where people would model light and color and shape and everything. And now we're kind of in another wave where it's impressionistic. The idea of something generated correctly with new frontier and computer image generation, AI algorithms.
So the creative process more like coming from this raw pixel.
Well, it's interesting. It depends. I think that we really want to span the entire range from really, really good, what you might call low-level, by low-level, as close to, say, analog workflows as possible. So what we do there is we make up systems that do really realistic oil paint color simulation. So if you want every bristle to behave as it would in the real world and leave a beautiful analog trail of water and then flow off the brush stroke, you can do that, and that's really important to create something really expressive or really novel that they have control. And then as certain other tasks become automated, it frees the artist up to focus on the inspiration and less of the post-production. So thinking about different ideas, obviously, once you finish the design, there's a lot of work to, say, do it for all the different aspect ratio of phones, websites, and so on. And that used to take up an awful lot of time for artists. It does many, what we call content velocity. And one of the targets of AI is actually to reason about, from the first example of what are the likely other formats, maybe change the language to German and the words are longer. How do you reflow everything so that it looks nicely artistic in that way? And so the first focus on the really creative level, which is what is the look and style and feel and the message, the story and the element. So I think creative. So that's one way in which we're trying to hear and pass more of it. Everyone from a full website. On the other side, as some of these things have automatic versions of them, people will possibly change role from being the hands-on artisan to being either the art director or the conceptual artist, and then computer will be a create polished examples of the idea.
Talk about the different products, right? And the products. Yeah, just to know where I'm coming from, I'm a huge fan of Photoshop, which is Premiere for video, for audio. I'll probably use Photoshop to create the thumbnail for the video, Premiere to edit the video, Audition to do the audio. That said, everything I do really manually, and I set up, I use old school keyboard, and I have auto hotkey that just, it's really about optimizing the flow of making sure there's as few clicks as possible. Right. So before we get into on some awesome deep learning thing, where does AI, a little more AI or just automation in general, coming on, or in general, prior in 2008, getting into life, low level pixel work flow here?
Yeah, that's a great question. So we have a very rich array of algorithms already in Photoshop, classical procedural algorithms, as well as based on data. In some cases, they end up with a large number of sliders and degrees of freedom. So one way in which AI can help is an auto button which comes up with default settings based on the content itself rather than default values for the tool. At that point, it starts. So that's a very kind of made life easier for people. Well, use of from other examples,
like smart defaults.
Smart defaults, absolutely. Another one is something spent a lot of work over the last years. I've been at Adobe 19 thinking about selection, for instance, where with quick select, you would look at color boundary, figure out how to plug fill into regions you thought were real world. But that algorithm had no visual common sense about what a cat looks like or a dog. It was just based on rules of thumb which were applied to graph theory. And it was a big improvement over the previous work where you had to almost click everything by hand, or if it just did similar colors, it was little tiny regions that would connect. But in the future, using neural nets to actually do a great job with, say, a single click, or even in the case of well-known categories like people or animals, no click, where you just say, like the object, and it just knows the dominant object, the person in the middle of the photograph. Those kinds of things are really valuable if they can be robust and or they could be a great start.
So, for example, background removal.
Correct.
Like one thing I'll in a thumbnail, I'll take a picture right now and remove the background behind you. And I want to make that as easy as possible. If you don't have flowing hair, like Rich
at the moment, yeah.
Rich.
I had it in the past, it may come again in the future. Now,
so that makes it a little more challenging to remove the background. How do you think the problem for basically making the quick selection tool smarter and smarter?
Well, we have a lot of research on that already. If you want a sort of quick, cheap and cheerful look, I'm pretending I'm in Hawaii, but it's a joke, then you don't need perfect boundaries. You can do that today with a single click with the algorithms we have. We have other algorithms where with a little bit more guidance on the boundaries, like you might need to touch it up a little bit. We have other algorithms that can put a nice match from a crude selection. So we have combinations of tools that can do all of that, and that we Max conference and Max demonstrated how very quickly, just by drawing a simple polygon around the object of interest, we could not only do it for a single still, but we could pull a match, well, pull a decent selection mask from a moving target, like a dance onto a brick. So it's going from hours to a few seconds for workflows that are really nice. And then you might go in and touch up.
So that's a really interesting question. You mentioned the word robust. There's like a journey for an idea, right? So presented probably Max has elements that inspires the concept to work pretty well in the majority of people. But how do you make something that works well in the majority of people? How do you make something that works or becomes robust?
on the difference between academic research and industrial research. So in academic research, it's really about if the person has a great new idea that shows promise. And we certainly love to do those people too. But we have sort of two forms of publishing. One is academic peer review, which we do a lot of, and have great success there as much as university. But then we also have shipping, which is a different type of, and then we get customer review as well as product. And that might be a case where it's not about being perfect every single time, but perfect enough of the time, plus a mechanism to cover with. So we have the luxury of very talented customers. We don't want them to be overly taxed doing it every time, but if they can go in and just take it from 99 to 100 with the touch of a mouse or something, and the professional end, that's something something well. And for them, it went from having to do that years past all the time to much less often. So I think that gives us now to have to be 100% automatic all the time, then that would delay the time at which we
on that thread, maybe you can think of again, or just maybe that's the most
absolutely.
so I think Photoshop, for example, or Premiere, has a lot of amazing features that I haven't. So what's the AI helping make my life or the life of creative here? How collaboration do how do you learn to collaborate better? How do you learn the algorithm? Um, Something that you have to watch tutorials, you have to watch videos, and so on. Or you ever think about areas of self exploration?
We absolutely do. So I'm glad that you brought this up. We sort of think about two things. One is helping the person in the moment task that they need to do. Another is more holistically about the journey learning of all. It's like good as a university for long enough to become an expert. And not necessarily an expert in everything. It's like living necessarily know every street. So we have projects in research which actually look at the thousands of hours of tutorials online and try to understand them. And then we had one publication at Kai where it was looking at, given the last 3 or 4 actions, what did other people in tutorials do next? So if you want some inspiration for what you might do next, or you just want to watch the tutorial and learn from people who are doing similar workflows to you, you can without having to go and search on keywords. So really trying to use context as intelligent suggestion, either about choices you might make, or in a more assistive way where it could say, if you did this next, we could show you. And that's basically the frontier that we're exploring now, which is if we really deeply understand the domain in which designers and creative people work, can we combine that with AI and pattern matching of behavior to make intelligent suggestions, either through verbal ability or just showing the results that we tried it. And that's really the sort of meeting today, thinking about these things.
Well,
So it's still a grand challenge. We don't love an artist over one shoulder and a painter over the other, right? And we hope to get there. And the right thing to give enough information to people in itself that builds a foundation for the next level of exploitation.
are you aware of the gigantic medium of create just a bunch of creative people, both artists and teachers? And
Absolutely. And the more we can understand those media types, both visually and in terms of transcripts and words, bring the wisdom that they embody into guidance.
that would be brilliant. Remove the area from self, voice, and so on.
Absolutely. And then in the longer term, an interesting discussion is, does it ultimately not just as learning the interface with that, but does it modify the interface or defragment into a variety of tools? level of ability. I like to say that you had a feature to a GUI, you have to get more visual complexity from the GUI, whereas if you have a system built, they have it, to ask for it, then it's sort of additive without being warranted. So definitely think about new users and how to onboard them. Many actually value the idea of being able to master that complex base of keyboard shortcuts like you were talking about earlier, because great familiarity, it becomes an instrument for expressing visual ideas. And other people just want to get something done quickly in the simplest way possible, and that's where a more version of the technology, like maybe on a different class of device, more in context capture, say. Whereas somebody who's in post-production workflow maybe wants to be on a laptop or a screen desktop and have more knobs and dials to really express the idea of what they want.
So many exciting applications of machine learning that on like key stitching, sky replacement, foreground, background, facial search, automatic image caption, like we mentioned, project book, project images, project scribbler, style transfer video, style transfer video, project Tron's best name ever. So, favorite or some of them, or examples that pop to mind. Here are links to other ones we don't talk about. Almost all of them that exciting.
Why they're interesting for different reasons. So I think the sky replace, we talked about selection in a type operation, almost like an assembly language structure. Whereas sky replace is a compound action where you automatically select the sky, look for stock content that matches the geometry, try to have variety in choices, and that's in the sky behind the foreground. Then importantly, the foreground of the other image searched on, the recolor the foreground is curated. So if you go from a midday sky to an evening sky, it will actually add sort of an orange glow to the foreground object as well. I was a big fan in college of Greece, because a number of paintings where it's realism, because they'll like do a composite, but the foreground building will be at night and the sky will be during the day. There's one called the Empire of Light, which was on my wall at college. And we're trying not to do surrealism. It can be a choice, but we'd rather have it be natural by default rather than it looking fake and then you have to do a whole bunch of post-production. So there's a case where we're kind of capturing an entire workflow into a single act and doing it in about a second rather than a minute or two. And when you do that, you can not just do it once, say like 10 different backgrounds, and then you're almost back to the inspiration idea of, I don't know quite what I want, but I'll know it when I see it. And you can just explore the design space as close to final production value as possible. And then when you really pick one, you might go back and slightly tweak the selection mask just to make it perfect. Do that kind of polish that professional.
So then there's this idea of, you mentioned sky replacing different docking. Generally, you have this idea,
or it could be on
this right, but making even more intelligent choices about search docking is really interesting.
Right.
Kind of digital.
Absolutely. Right. So that was something we called normally when you do say an image search, you would it's just based on text, you would give the keyword image and would find the nearest one that had it. But many tasks you really want to be able to say, I want to be a person or in a dog to the right and a umbrella above the left. You want to leave space for the text or whatever. And so Concept Canvas lets you assign spatial regions for this. And then we've already pre-indexed to know where the important concepts are in the picture. So we then go through that matching asset. And even though it's just another form of search, because you're doing spatial design or layout, it starts to feel like design. You sort of feel oddly responsible for the image that comes back as yeah. So it's a good example where giving enough control starts to make people have a sense of ownership of the outcome of that. And then we also have technology with Photoshop, which typically can move the dog in post as well. But the content canvas, it was just a very fast way to flip through and be able to lay things out.
In terms of being able to remove objects from a scene in the background,
right,
dramatically, that's extremely exciting, and that's networks that in there.
Right.
So
yeah, again, so hearing that is definitely one approach.
So is that a really difficult problem? Look again to take it to a robust product level.
Well, there are certain classes of image for which the traditional algorithms like content aware will work really well, like have a natural texture like a gravel path or something. Patch based, it will make up a very plausible looking thing and fill in the hole. We use them algorithms to sort of smooth out the lighting so you can see bright contrast in that region, or you gradually ramp from one dark to light and it straddles the boundary. Where it gets complicated, you have to infer in this structure behind the person in front, and that really requires a common sense knowledge of the world to know what. If I see 3/4 of the house, do I have a rough sense of what the rest of the house looks like? Just fill it in with patches because that's things that make sense locally. You look at the global structure and it looks like it's crumpled or messed up. And so what GANs and neural nets bring to the table is this common sense learned from the training set. And the challenge right now is that the generative methods that make up holes in that kind of technology are only stable at low resolution. And so you either need to go from a low resolution to high resolution using some other algorithm. We need to push the arguments and research to get to that point. Of course, if you show it something, say it's trained on houses, and then you show it an octopus, it's not going to do a very good job of showing common sense about octopuses. So, again, you're asking about how you know that it's ready for prime time. You really need a very diverse training set. Ultimately, that may be a case where you put it out there by guardrails where you might do a detective who looks at it and sort of estimates its own competence, how well a job algorithm. So eventually, maybe this idea of an ensemble of experts where any particular expert is specialized in certain things. And there's either they vote how confident they are about what multiple people doing, or there's some dispatcher which says you're good at housing, you're good at trees. And so I mean, it's all this adds up to a lot of work because each of those models will be a whole bunch of work. But I think over time, gradually build out the set and initially focus on certain workflows and then branch out.
You mentioned workflow. Have you considered looking far into the future? First of all, the fact that huge amount of people that use Photoshop, for example, they have certain workflows. Being able to collect information by which they, basically get information on their workflow about what they need, ways to help them, whether it is houses or more.
Right.
Like basically, kind of data collected. Well,
Right, absolutely. And the whole world of AI is what data together and why. At one level, the way to think about it, not only want to train our customers how to use our products, but we want them to be just important. At the same time, we want to respect their privacy. And obviously, we wouldn't do things without their explicit permission. And I think the modern spirit of the age around this, you have to demonstrate to somebody sharing their data with the tool. Either it's helping short term to understand their intent to make better, or if they're friendly to your cause or your tool, or they want to help you evolve quickly because they depend on you for their livelihood, they may be willing to share workflows or choices with the that then train. There are technologies that learning without necessarily storing them and learn on the fly, but not record of it. So we're definitely exploring all of those.
And I think Adobe, where now, like if I look at data I've created, sharing data with the network that I have with Adobe, because that's just exactly as you said, there's an obvious benefit of sharing the data that I use to create Photoshop. Right? Not
Say that. I mean, I think there are some workflows which might be very particular, such as I was preparing release case. I would want to give that, running home to help train the algorithm or anything. There may be other things that where he has a more permission so they can find only doing hobby projects or things that are confidential and in exchange for some better tangible or otherwise, I'm willing to share very fine-grained data. So another possible scenario is capture relatively crude high-level things from people and then develop knowledge to participate. We do that today with explicit customer studies where, we go and visit somebody and ask them to try the tool and we even observe what they future to be able to do that enough to be able to train an algorithm. We need a more systematic process, but we're very conscious because one of the things people treasure about Adobe is the sense of trust, and we want to into that through overly aggressive collection. So we have a chief privacy officer, and definitely front and center of thinking about AI rather than an afterthought.
well, when you start that program, sign me up.
Okay.
There are other projects you wanted to mention that I did not pop into mind.
Well, you can put the number. I did mention Trump. I think that one might be, and that's a good example where we're actually thinking about how to apply so that we Trump does it either for a video of a person walking, make a painting of somebody else, and then apply the style of the painting to the person. And it's unlike a sort of screen door post filter effect that sometimes online. It really looks as though it's sort of somehow attached to the reflective motion of the face. And so that's the case where you workflow like that, really more about the world. And I think as 3D computer vision algorithms get better, initially they'll focus on particular domains like faces where you have a lot of prior knowledge about structure and maybe have a parameterized template that you fit to the image. But over time, this will be possible for more general content. And it might even be invisible so that doing 3D construction, but under the hood, it might then edit largely or correctly.
It's very application, right? So,
and a very sensitive one. If you do something uncanny, it's very disturbing.
I guess get it right. So, in the space of augmented reality and virtual reality, what do you think the role of AR and VR in the content creator
That's a great question. I think VR and AR so slightly different. So VR can really transport you to an entire immersive world in a matter of worked on VR in the 90s, trying to solve the latency and nausea problem, which we did, but it was very expensive and early. New wave of that now, I think, and increasingly those devices becoming all in one rather than something that's tethered to the box. The market seems to be bifurcating into professional, like for architects and people designing products anyone better than looking at a scale model or a drawing. For that, they sense of scale and spatial. Right? I think AR holds the promise of taking digital assets off the screen and putting them in context of the real world. And that has the corresponding need that the assets need to adapt to context in which to take place. And it's a bit like having a life that comes to your house and happen. My mother had a friend who daily homes in England as the National Trust. They would adapt to the scenes and even they walk the audience through the room to the action based on the country house they found themselves in. And I think AR will have the same issue that, if you have a tiny table in a big living room or something, it'll try to figure out what can you change, what's and there's a little bit of a tension between fidelity where capturing Uriah doing a fantastic ballet, you wanted sort of exactly used the town. Whereas somebody telling you a story might be walking around the room gesture and that captures them in the photography.
Abilities that were not of stories.
I think it depends on the character. A celebrity wants to contribute. They don't want to be animated by someone. Really, a lovable frog telling you a story. Not a princess and a frog, then it's right. A lot of the ideas that have grown up in the game world now come for commercial, once they're needing adaptive characters.
Are you give engineering tools all creators the augmented world in a Photoshop augmented world?
Well, we have shown a few demos of sort of taking a Photoshop layer stack and expanding it. That's actually been shown publicly as one example. Yeah. What I'm excited at the moment is 3D. 3D design is still a very challenging space, and I believe that it's a worthwhile experiment to try to figure out if AR or immersive make 3D design more spontaneous.
Give me an example. Design,
well,
like applications.
Literally, a simple one would be laying out objects, right? So, on a conventional screen, you have a plan view and a side view and a perspective view, and you're dragging it around with the mouse and not get the form and all that. Whereas if you're really laying out objects in a VR headset, you could literally move your head to the viewpoint, it'd be in stereo, so you'd have a sense of depth. You're already wearing the depth glasses, right? So it would be those sort of big gross motor move things around kind of still seem much more spontaneous, just like they are in the real world. The frontier for us, I think, is whether that same medium can be used to fine-grained design tasks, like very accurate, constrained spontaneous CAD model or something. That may be better done on the desktop. It may just be a matter of inventing the right UI. So we're hopeful that because there will be this potential explosion of demand for 3D assets driven by AR and more real-time animation and those tools will also help, or those devices will help with designing the concept.
You mentioned quick ideas. I'm the fucking phase.
I think I'm here.
Yeah, oppose all cause.
Yeah.
They're about creating the version of AI base that develops current products. So that new idea
base would definitely be offended by that. I think there are some things where have convenient control that may be more welcome. You think about not breaking well-known methods. So I think that makes sense. Photoshop has never been a static. It's always been evolving and growing. And to some extent, there's been a lot of brilliant thought along the way of how it works today. So no one's to roll that out. If there's a fundamental breakthrough, like a single click is good enough to select an object rather than having to do lots of strokes, that actually fits quite nicely to that either as an optional mode or as a starting point. I think when we're looking at radical simplicity where you encapsulate an entire workflow with a much simpler UI, then sometimes that's even in the context of either a different device, like a mobile device, where importance is naturally different, or in a tool that's targeted a different workflow where it's about spontaneity and velocity rather than precision. And we have projects like Rush, which can let you use professional quality video editing for a certain class and get output that targeted very differently in terms of and the experience. Ideally, people would go, I'm feeling like doing Premiere, big project, I'm doing a full television series. That's definitely a Premiere thing, but if I want to do something for my recent vacation, maybe I'll just use Rush. I can do it in the half an hour I have free at home rather than the 4 hours I need to do it at work. And for the use cases which we can do well, it really is much faster to get the same output, but the more professional tools obviously have a much richer toolkit and more flexibility in what they can do.
And with the flexibility, I like this idea of using AI to coach like what has done feeling lucky, but
Right.
Or one button it pretty good settings. That's simple setting.
Absolutely. Yeah.
So imagine there's this home. You're not sure about the correlation as far as like the conditions on sometimes the degree what the optimal is.
And then some things are sort of on demand, like help, right? Where I'm stuck, I need to know what to look for, I'm not quite sure what it's called. And something that was proactively making helpful suggestions for, you could imagine a maker suggestion button, where you'd use all of that knowledge of workflow and learn about, or just to try or show the answer. And maybe it's not one intelligent default, but it's like a variety of defaults. I like that one. Yeah.
So practical.
I guess.
We're gonna interpret a few lines of reading yours before I ask the next question. First of all, the smartphone. Yeah, I left my phone at home. I went down to the hand was soft, pushing glass. But I was this is a phone about you leaving your phone behind and quite liberated because of it. So kind of a difficult topic and talk about it. Figure it out, but the help of AI and more create versions of reality that are way more beautiful than actual reality. And some of the creative effort that is part of creating this, well, of course, it's inevitable, but how do you think we should adjust the real world that's partly artificial? Like, that's better than the world that 100 years ago when you didn't have Graham and a big version of ourselves.
Oh, this is sort of showing off better versions of ourselves.
Of modifying the images or even the artificial intelligence idea mistakes, creating adjusted fake versions of ourselves.
I think it's an interesting question about sort of historical bent on this. So I actually wonder if aristocrats famous portraits that were slightly nicer than they actually looked in practice later. So, yeah, human desire to put your best foot forward has always been true. I think it's interesting. You sort of framed it in two ways. One is, if we can imagine alternate realities and visualize them, is that a good way? In the old days, you do it with storytelling and words, poetry, which still quite sometimes on websites. But we've become a very visual culture in particular. In the 19th century, we're very much a text-based culture. Read long tracts, political speeches are very long. Nowadays, everything's very kind of quick and snappy. I think it depends on how harmless you're. It's a lot of it about it. So if you have a somewhat flattering photo that you pick out of the photos that you have in your inbox and say, this is what I look like, it's probably fine. Someone's going to judge you by how you look, then they'll decide soon enough when they meet you whether the reality. I think where it can be harmful is people hold themselves up to a possible standard, which they can decide about themselves getting that stuff up. That can be an issue. And but I think the ability to imagine and visualize an alternate reality, which sometimes which you then go off and build later, can be a wonderful thing too. People can imagine architectural styles, which they then have a startup, make a fortune, and then build a house that looks like a favorite video game. Is that a terrible thing? I think I used to worry about exploration, actually, that part of the joy of going to the moon. I was a tiny child. I remember it raining black and white. I know what it would look like when you got there, and I think now we have such good graphics visualize the experience of what happened, that I slightly worry that it may take the edge off. Actually, go. You know what I mean? We've seen it on TV. We kind of, by the time we finally get to Mars, we go, it's Mars. It's like, but then, the outer exploration. I mean, I think Pluto was a fantastic piece of discovery where nobody had any idea what it looked like. Varied and beautiful. So I think expanding the ability to imagine and balance. I think there are abuse and like seriously and try to encourage them. I think there's a parallel side where the public needs to know what's possible for events like this, right? So that you don't believe everything you read in print anymore, and it may over time become or you need multiple sets of evidence, something rather than a single media. I think it becomes true forever. There's a famous story about Anne and Henry VIII, where Anne didn't get married, right? Or they got married. So whole line went and painted a picture, and then Henry VIII wasn't pleased, and history doesn't record whether Anne was pleased, but I think it's not be married something. So I mean, this has gone on for a long time, but I think it's just part of the magnification of capability.
You've kind of built up an amazing environment here, research culture, lab. And you've written driving jobs as interns. Can you tell a little bit?
So a couple of reasons. As you see, looking at my personal history, there are certain ideas you bond with at a certain stage of your career, and you have to keep revisiting them every time. If you're lucky, you pick one that doesn't just get solved in the next 5 years. So I think a constant influx of new people with new ideas. From the point of view of industrial research, because a big part of what we do is really taking those ideas to the point where they can ship as very robust features. You end up investing a lot in a particular idea, and if you're not careful, people can get what they choose to do next, knowing that the product seems to want it. And interns let you explore the more fanciful or unproven ideas in a relatively lightweight way, ideally leading to publication to the intern and to the researcher. And it gives you then a portfolio. Which idea am I going to then try to take all the way through to us the next year or two to ship? So it sort of becomes part of the funnel. They're a great way for us to identify future research about rates of resonance. It builds a bridge to the university department so we can know and build an enduring relationship with professors as well, which much of the value you can imagine around collaboration. So it's sort of a virtuous cycle. And then the long-term legacy of research, I'm hopeful, will be not only the people who stay, but the ones who go off and carry that same other company. So we believe industrial research is how it can contribute. We hope that this model will continue to propagate and be invested by other companies, which makes it harder for us to recruit. But, that's a sign of success. Rising tide lifts all ships.
And where's NPS born? Brainstorming their discussion, well, like what
Ideas come from.
as I'm asking somebody, I'm hoping
No, it's
give a better answer.
It's all the better
Answer than a better
question I asked at the beginning of every summer. So what will happen is we'll send out the questions. We'll have a number of candidates come in. We'll contact the candidates, talk to them about their interests. They'll usually try to find somebody who has a reasonably good match with what they're looking for, or just has a really interesting domain that they and we substitute them. And then the intern stays in touch for them. And then we come in the third, what are all the general ideas that we're wanting to whether same idea, maybe they that. But then once the intern actually arrives, sometimes the idea goes differently, and sometimes it's a giant left turn to go, that sounded good, but we have this other great idea. So it's pretty flexible at the beginning. One of it goes wrong, who gets the credit, right? And so in Adobe, we push the needle very much towards freedom of choice of projects by the researchers, but then we reward people based on impact. So if the project ultimately ends up impacting the product, so the benefit model here is that you have one lab director who thinks tells everybody what to do, takes all the credit if it goes well, blames everybody else. So we don't want that one. And this helps new ideas circulate. The art of running such a lab is that there are strategic priorities for the company, and there are areas where we do want to invest and pressing problems. So it's a little bit of a trickle down and filter up needs. So you don't tell people you have to do X, but you say X would be particularly appreciated. And then people reinterpret X through the filter of things they want to do. And miraculously, it usually comes together very well. One thing that really helps, Adobe has a really broad portfolio of products. So if we have a good idea, there's usually a product team create or so it means we don't have to much. Once in a while, the product team sponsor an intern. They have a problem that they really care about, in which case it's a little bit more, we really need one of these. And then we sort of say, great, I get an extra intern, and we find an intern who thinks that's the so that's not the model, that's sort of the icing on the cake as far as and all of the above. It's really hard to predict which of these we all have high hopes for all of these projects, but ultimately some of them pay off and some of them sort of are a nice paper but don't tend to they turn out not to be as novel as we thought, but they then others make a little bit of progress and realize how much we know and that problem several years ago and finally have a break and it's on track to
jumping back to overall Adobe, you looking forward to 2019 beyond.
of the technological breakthrough,
especially ones that will make it into product or make an impact.
So I think the creative, the analytics assistants that we talked about, where they're constantly trying to figure out what you're trying to do and how can they be helpful and make a really hot topic. And it's very unpredictable as to when it'll be ready, but I'm really looking forward to seeing how much progress we're making with that. I think some of the core technologies like adversarial networks are immensely interesting, and seeing how quickly those become practical for mainstream use cases at high resolution and with quality also exciting. And it also had this sort of strange way of even the things that are oddly odd in ways. So look like dreaming or something. So that's fascinating. I think internally we have a Sensei platform, which is a way in which we're pulling our neural nets and other intelligent models through a platform which is then leveraged by multiple product teams at once. So we're in the middle of transitioning from once you have a good idea, you sort of hand design it for that. We're more sort of Henry Ford, stand it up in the standard way, with the access in a standard way, which should mean that the time between a good idea and our products is very important. And when one product has a good idea, many of the other products can leverage it. So it's sort of an economy of scale. So that's more about the how than the what. But that combination of Renaissance and AI, there's a comparable one in graphics, real-time ray tracing, other really exciting emerging technologies. When these all come together, you'll sort of basically be dancing with light, right? Where you'll have real-time shadows, reflections, as if it's the real world in front of you, but then with property brought by AI, where it sort of anticipates or modifies itself in ways that make sense based on how it understands the creative task it's trying to do.
That's a setting creative for myself to be a creator. First of all, I work at autonomous vehicles. I'm a roboticist. I love robots. And I think you have a fascinating takes slash artificial robots. I share your fascination. Their movement is beautiful, adaptability is fascinating. There are, looked it up, 2,900 snakes in the world.
Wow.
375 venomous. Some are tiny, some are huge. Saw that the one is 25 feet. So what's the most interesting thing to connect with in terms of snakes, both natural and artificial? What was the connection? Robotics, AI.
Well, it actually came out of my work in the 80s on computer animation, where I started doing things like hot simulation and other kind of soft body simulation. And sort of drop it and it would bounce and it would just sort of stop moving. And well, what if you animate the spring length and simulate muscles? And the first object I could do that for was an earthworm. So I actually did a paper in 1988 on the motion dynamics of snakes and worms, and I read the physiology literature on both how snakes and worms move, and then the early animation examples of that. And
You're interested in robotics.
Came out of simulation and graphics. When I moved from Alias to Apple, we actually did a movie called Majesty about a secret agent snake that parachutes in and captures a film canister from a satellite, which tells you how old-fashioned we were thinking back then. The classic 1960s Bond movie. And at the same time, I'd always made radio-controlled ships when I was a child, and from scratch. And I thought, well, how hard can it be to build a real one? So then started a obsession with trying to build better snake robots. And the first one that I built just sort of slithered sideways and forward, then I added wheels. And building things in real life makes you honest about the friction. The thing that appeals to me is I love creating a vision of life, which drove me to animation. And if you have a robot with enough degrees of coordinated freedom to move in a kind of biological way, then it starts across the uncanny valley and like a creature rather than a thing. And I got that with Pretty Snake. By S3, I had it able to sidewind as well as go directly forward. My wife-to-be suggested that it would be the ring bearer at our actually went down the aisle carrying the ring, and got a local paper for that, which was really fun. And this was all done as a hobby. And then at the time, the incredibly limited.
You can explain that. You said the whole idea is trying to run it at,
autonomously on board now or on board, right? So the very first one, I actually built the controller from Logic because I used LSI, things when I was a teenager. And then second and third one, the 8-bit microprocessors were available with like a whole 200 bytes of RAM, which just about squeeze in. So they were radio controlled rather than autonomous, and really were more about the physicality, coordinated motion. I've occasionally taken a side step into if only I could make it cheaply enough with a great toy, a lesson in how work is its own magical realm that you enter into and learn things about backlash and other things you don't take into account as scientists. Why what seems like a good idea doesn't work. So it's quite humbling. And then more recently, I've been building S9, which is a much better engineered version of S3. Motors around working more, not by replacements. Sad, given that it was such a meaningful one. S5 was about twice as long. Looked much more biologically inspired. I like the typical roboticist I take with my snakes. For a good mechanical reason to do that, but it also makes it a little more biological, although it means every segment rather than a repetition. Why most engineers don't do it. It actually saves leverage. That one is currently on display. None that it's done any buying. It was on YouTube and it got its own conspiracy theory when people thought it wasn't real because I work in it must be fake graphics. And people would write to me, tell me it's real. But the background doesn't move and it's like, on a tripod. So that one, so you can see the real thing, so it really is. And then the latest one, the first one where I could put a Raspberry Pi, but yeah, but this one can have on compute, and then where my hobby work and my work are converging, now add vision accelerated chip, which means evaluating and do object recognition. So both for the snakes and recently for the spider that I've been working on, having desktop level compute now opening up a whole world of true autonomy with onboard compute on batteries and still having that sort of biomimetic quality that people appeal to children in particular. They really trust them, and adults think they're creepy, but children actually think it's charming. I gave a series of lectures at girls who came to encourage people to technology. And at the moment, I'd say they're still more expensive than the value that they add, which is why they're a great hobby to me, but they're not really a great product. It makes me think about doing that very early thing I did earlier with changing the muscle rest length. If I could do that with a real artificial muscle, then the next snake ideally would use that rather than most gearbox. Lighter, much stronger, and more continuous. So I like to say being in research is a license to be curious, and I have the same thing with my hobby here. Biology, curious about things that otherwise would have just been, National Geographic specials. I am thinking, how does that snake move? Can I copy it? Look at the trails that winding snakes leave in sand and see if my snake robots do things.
Out of something inanimate, I like the way you put it, bring life into it.
Absolutely. And then ultimately give it a personality, which is where the intelligent agent research will converge with the vision and having not necessarily human level intelligence. Turing test is such a high bar, it's a little bit, but having one that you can have meaningful conversation with, especially if you so not trying to have it so a stranger could walk up and have one, but so as a pet owner or robot pet owner, you could know what it thinks about and what it can reason about.
they're actually dogs. Might have a conversation one way.
Absolutely.
And nevertheless,
and one of the things that I'm trying to do with some audio is beginning to get towards the point where the reasoning system can explain why it knows something or why it thinks something. And that again creates the sense that it does know what it's talking about, but also debugging. As you get more and more elaborate behaviors, like why did you decide to do that? Why, how do you know that? I think the robots really are my muse for helping about future AI and what to invent next.
Even at Adobe, mostly operating in digital world.
Correct.
See a future where Adobe expands more physical world, perhaps life, not in animation, but life in physical.
I have to say at the moment it's a twinkle in my eye. I think the more likely thing is that we will bring virtual objects into the physical world through augmented reality. And many of the ideas that might take 5 years to build a robot to do weeks with assets. So I think when really intelligent robots finally become commonplace, they won't be that surprising because we've been working with those personalities in the virtual sphere for a long time, and then they'll just say, "Oh, it's Siri was like Alexa on who thing." So I can see that well coming. And for now, it's still an adventure, and we don't know quite what the experience will be like. It's really exciting because all of these strands might converge.
Interesting ways. It is definitely fun adventure. So let me end my favorite last 2 lines of my favorite poem, that ponder mortality. Sense immortality as our idea of others, work of others. Then not we were born. Little atomy permit dance. Out of them is Christ. I'm content to have another chance. More parts on. Join beautiful heaven. And thank you for inspiring and empowering like myself creating. So,
Great competition.
following the conversation with Rosalind Professor at MIT, director of Media Labs, co-founder of Attica. Decades ago, she launched a field of effective book. This book describes towards artificial and natural vital role of emotional communication has relation to people, general, and human interaction. I really need to talk with Rob topic, including emotion, ethics, privacy, verbal computing, and her webs, and the love. This conversation is part of the Artificial Intelligence podcast. Enjoy it. Subscribe on YouTube, iTunes, Twitter. Let's spelled FRID. Now, here's my conversation with Rosalind Card. More than 20 years ago, he coined the term affective and led a lot of research then. I understand the goal of emotional that behavior of the machine. So, how is your understanding of the problem defined by change 20? So, it's scope, the application, challenge.
Actually, originally when I defined the term affective, it was a bit broader than recognizing although those are probably the that we've worked on the hardest. The original concept also encompassed that would have mechanisms. It would be anything that relates to rising deliberately. So the human computer interaction part is the part that's like I'm really ticked off at my computer and I'm yowling at it and I'm cursing at it, actually smiling at it. That kind of thing. And I thought my affect, and if it's going to be intelligent, Microsoft 360 is really hard. It's the most AI in it. Nothing's going to act smart. It needs to respond and reason the different.
By the way, look at the Flippy, maybe for 95, 98, but many people, you find yourself that reference, recognize what you're talking about.
I don't expect newest students to days, but I've mentioned it to a lot of audiences, like how many of you know the Flippy thing, and still the majority of people know it.
Flippy kind of looks at maybe natural English processing for typing and tries to help. I think I don't even remember what Flippy was annoying.
Yeah, it's right. Some people actually liked it.
I miss it.
I would hear those stories. Miss it?
Well, I missed the annoying. It felt like there's a
Someone was there.
Somebody was there, in it together, and we're annoying. It's like a puppy that just get it. It's
right.
ripping up the couch.
And in fact, they could have done it harder like a puppy. They had done like yelled it or cursed it, its little ears back and it's still down and perked off. Probably people would have wanted it. And yelled at it, what did it do? Smile. Yeah, right. Somebody comes to my office and I yell at them, they start smiling and it's never want to see it. So Bill Gates got a standing ovation that it was going away. Because emotionally unintelligent, right? Intelligent about whether you're writing a letter or what kind of help for that context. Unintelligent about, hey, if you're annoying a customer, don't smile. So that kind of mismatch was something, and intelligence at the time was really all about math and tests and games, problems that could be well defined. Social emotional interaction much more complex or Go or games that people are trying to solve. And in order to understand that required skills that most people in computer science actually were lacking.
Well, let's talk about computer science. That's better. Mark's message has launched the field with a lot of research. I still find self passion about human beings. Yet, science still seems to be a lack of, sorry to say, empathy in us computer scientists.
Yeah, well,
whereas
let's just say there's a lot more variety these days. Scientists are a much more diverse group today than they were 25 years ago. And that's good. We need all kinds of people to be scientists so that computer science becomes more what society is. And brilliance among every person not be limited for computers to other people.
How hard do you think it is? How difficult it is to recognize emotion? Emotional intelligent interaction. Has it gotten easier or harder? And how far would tracking scoring tests all the intelligence scoring tests for emotional intelligence?
As difficult as I thought it was going to be, my spot on. I think the time estimates are also hard because they're always a function of society, love, and of a society excited and you get hundreds, thousands of people on first application. That application itself really general in the lack of ability to have awareness of the fact that it's not conscious, the fact that there's no signs of becoming conscious, the fact that it doesn't align. Those kinds of things that we have to detect what other people pick up implicitly. That things yet there aren't great yet that lead us to believe that's going to that we're going to discuss a lot of limitations where we're probably only going to do the right and very limited, narrow, specified content where we can prescribe much what's going to happen there. So I don't. It's hard to predict the date because when people don't work on it, infinite. When everybody works on it, you get a nice piece of it, well solved, finished for about this time. I actually think it's a more important right now than difficulty of it, and that's causing some of us to put the brakes on a little bit. Usually, we're all just like step on the gas, let's go fast. This is causing us to pull back, and that's the way some of this technology is being. That worries so deeply that it's causing me to pull back myself on a lot of the things that we've been doing and try to get a little bit more about it. If we're going to go forward with that, how can we do it in a way that guards that
technology we're referring to when a computer senses space.
Yeah,
right?
yeah.
So there's a lot of exciting things there, like deep connection. What are your worries that could go wrong? Is it in terms of privacy? In terms of other kinds of more subtle
privacy. So here, if I'm watching a video of, let's say, a political leader, and we're quite, as we know, can criticize the president of the United States. Here, that's not a shocking thing. It happens, about every 5 seconds. Right? But in what happens, you criticize the leader of the government, right? And so people are very careful not to do that. However, what happens if you're simply watching a video and make a physical expression that's a little bit of skepticism, right? Well, and here we're completely free to do that. In fact, we're free to fly off the handle and say anything we want. Usually, there's some restrictions there, but when the athlete does this, part of the national broadcast, then get a little unhappy about picking it for him to do it, right? But that's more a question of we have freedoms, and places that don't have those freedoms. What if our technology can your underlying affect? What if our technology can even not content? What if our technology can get without your prior? And here in the U.S., our first company started Epic and worked super hard to turn away money and opportunities that try to reach people's their prior input. Even the software that is licensed, signed, right? Get buy it, right? So do this without people. There are other countries where they're not interested in buying. They're just gonna they're gonna inflict it on you, and if you don't like it, you better not scowl.
So, comment on a small tangent. The idea of adversarial examples of fake and so on.
Yeah.
What you bring up is actually, in one sense, fake provide a comforting protection that no longer really trust that video of your face was legitimate. Therefore, you always have an escape clause if a government is trying. If the table
example, your heart rate, and whether or not it's tampered with. And we also can put like fake heart rate and you're doing now too. We decided we after we developed a way to extract it, we decided we also scan it. And so the fact that we took time to do that other too, right? That was time that I wasn't spending and how we spend our time now being paid a little bit less by goal and a little bit more like by concern about what's happening in society and what kind of future we're doing with it. And as we sit back and say, don't just build AI to build AI to make Elon Musk more money or to make Amazon and Jeff Bezos more money. Good gosh, that's the wrong answer. Why are we doing it? What is the point of building AI? It was driven by researchers in academia because papers published and to make a career for themselves and it's something cool, right? Like done. Now we realize that this enables rich people to get faster richer or are to buy larger. That's the kind of future that we want to think about. They want to rethink AI. They want to rethink problems in society that are causing inequity and think how to build AI that's not about a general intelligence, but that's about extending intelligence ability to have not so that we close the gap.
I hope that kind of stepping up happens organically. I think no majority of on AI is decided to publish papers and make money without thinking about the why. What happens organically is a regulation.
Great question. I prefer they talk about the carrot versus stick. I definitely prefer the carrot. And in our free world, there's only so much stick, right? You're gonna find a way around it. I generally think less regulation is better. That said, even though my position is classically carrot, no stick regulation, I think we in this I do regulations around people with their data that own your data, not Amazon, not Google. I would like to see people own their own data. I would also like to see the regulations that we have right now around lie detection, extended motion in general. That right now you can't use the lie detector on an employee when you're on a when you're interviewing them for a job. Similarly, we need to place protection around reading people's emotions without their consent and characterizing them for the job. I also think that when we're around mental health, that should, even though it's not medical data, that should be the kinds of protections that are mental. Don't know yet. Right now, with your smartphone, if you're wearing, you want to learn about your stress, activity, and how much you're using your phone, and social interaction, all of that non-medical data, when we put together with now called AI, even though the founders of the language called it that, that ability not only tell that you're calm right now or that you're feeling a little stressed, also predict how you're going to help that, especially when we're tracking more.
If it up work, a lot of people on our phones are worried about this. For the most part, on balance, are you optimistic about benefits brought from that camera that must or more work?
I think a little bit more work about at us and us. The device sitting on your countertop in the kitchen, whether Alexa, Google Home, or Apple Siri device, want to listen. They say ostensibly us, and I think there are great people. Some people want to help people. Let me not brand them all bad. I'm a user of products of all companies, all the Alphabet, Apple, Amazon. They are awfully big companies, right? They have incredible, and what if I'm a certified, and suddenly all of that data, not part of America, but all of that data were part of somebody who just take over the world and give it to them. And guess what happens if I just skirt the wrong way and they say something that you don't like? Well, they have re-education camps, right? That's a nice word for them. By the way, they have a surplus of organs for people who need surgery these days. They don't have an organ donation problem. They take your blood and they know you're a match. And the doctors are on record of taking organs from people who look perfectly healthy and not, they're simply not the favored ones of the government. And that's a pretty evil society, and we can use the
was born so you can certainly connect to the worry that you're expressing. At the same time, probably both you and I, you're very much so, there's an exciting possibility that you can have a deep connection with the machine.
Yeah.
Right, so
those of us, I just did a theory that they, when you list, like, who do you most have lunch with dinner with, right? And they'll write, like, I don't like one of them said to me once when I had this party, I want you to know, my only social friend, my one social friend. Like, okay, now this is really a machine person, right? And that kind of brilliance. I love that science welcomes people, love people, and people who are very awful. I love that anybody can join kinds of people. And don't need to, I'm not forced to feel like that suddenly becomes a joke. At the same time, if most of the people building AIs in the future are the kind of people who don't like people, that's a little bit of a problem.
Well, hold on a second. So let me push back on that. So don't you think a large world, and there's loneliness, there's
huge problem that's growing,
and the longing for connection.
If you're lonely, you're part of a big growing.
So we're in it, I guess. If you're lonely, you're not alone. That's a good one. But do you think there's you talk about some worry, but do you think there's an exciting possibility that something like Alexa, like these kinds of tools, can alleviate that in a way that other humans can't?
Yeah, definitely. I mean, a great book can kind of alleviate both, right? Amazing story, and it's great to go spend time with that, right? And they're not a human character. There's a human behind it. But yeah, it's incredibly delightful. And it's been, I don't read the trashy romance books, but somebody does, right? And what are they getting from them? Probably some of that, right? And that social moment, that romantic moment, connecting. I've had a similar science fiction book, connecting forces hard, amazing writing, Ender's Game, and terrible title. Kind of books character, and you feel like you're very social, it's very connected, even though it's not responding. And a computer, of course, can respond. So it can, right, have very connection, much more than her, plays.
With so much more, and heard already.
Well, but it's just right. It's just, but I mean, there's a real attraction to character. Learn. You can imagine not just you and one character, group with characters. You can imagine people and characters, human and AI connecting. There maybe a few can't be friends with everybody, but people and their AI, and there can be an extended human intelligence there. Uh, that way, but very limited. There are, what I mean is there are many more possibilities than what.
There's a here. One, you expressed a really serious concern about privacy, how government. And there's a possibility of, let's look at Alexa.
Yeah, yeah.
So personal, the most part, as far as I'm aware, ignore your emotions. They ignore even context, what it takes to view you get beautiful, complex aspects of who you are, except maybe aspects recognized. Do you think they should lower trying to understand your emotion?
All of these companies are very interested in understanding emotion. They want more people are telling everything they want to keep. Apple wants to know the difference between a person who's really suicidal and a person who's around. Right? The word tone of voice and what surrounds those words is pivotal to understand. They should respond in a very serious way, bring that person or kind of joking back. You want to sell something else, right? Like somebody says that, well, you do want to err on the side of being careful. People want to know if the is happy, stressed. All right, well, so they give you an altruistic reason and a business profit motivated reason, and there are people and companies that operate on both levels. The altruistic people really care about their customers and really care about helping them feel a little better at the end of the day. And it would just make those people happy that they made your life better. Home stress and afterthought with their product felt better. There are other people who maybe have studied the way affect affects decision making and pricing people pay. And they know, I should say, like the work of Jim Lerner at on heartstrings and purse strings. If we manipulate you into a slightly sadder mood, you'll pay, right? You'll pay more to change the situation. Something you don't even need. So I'm a little sad. Maybe I don't want to cheer them up. I want to help them get things. Little shopping therapy, right? That helps them.
Really different company that's primarily funded on advertisement. They're encouraged to
offer you products, or Amazon is primarily funded on buying. So I think we should maybe regulate a little bit of a wall between agents that have access to our emotion and agents that want to sell us. Maybe there needs a little bit more of a firewall.
So maybe digging in a little bit on the interaction with the lifestyle. Of course, care about like recognizing emotion. What about the actual interaction itself? Do you think you mentioned clippy, annoying. What is the objective function we're trying to optimize? Minimize annoying, minimize or maximize happiness, or look at human relations. I think that when dance, the annoying, the flaws, that's what makes it fun. So there are rooms for what's the objective
When
function?
you want to have a little push and pull, kids learning, right? I see my and one of them wants to provoke the other to be upset, and that's fun. And it's actually healthy to learn where your limits are, to learn how to self-regulate. Imagine a game trying to make you mad, and you're trying to self-control. So if we're doing a AI human interaction that's helping build resilience and control, whether it's to learn how to not be a bully, or how to turn the other cheek, or how to deal with, then you might need an AI that pushes your button, right? Um, but in general, if you want an AI that pushes your button, probably depends on your personality. I don't. I want one that is there to serve me and that is there to extend my ability. I'm not looking for a rival, for a helper, and that's the kind of AI I define myself.
Your sense of the majority of the world have a rich experience that's what they're looking for. Now, look at the movie Her, spoiler alert. I believe the program woman movie Her leaves the person for somebody else.
Right.
Says they don't want to be right. Like, your sense of Alexa said, I'm actually had enough of you for a while, so I'm going to cut myself off. You don't see that as.
I'd say you're trash because I'm patient, right? We gotta remember, and this is where blending human AI as if we're equal is really deceptive. AI is something at the end of the day that my students and I are making in the lab, and we're choosing what it's allowed to say, when it's allowed to speak, what it's allowed to listen to, what it's allowed to act on, the inputs that we choose to expose it to, what outputs it's allowed to have. It's all something made by a human, and if we want to make something that makes our lives miserable, fine. I wouldn't invest in it as a business, unless it's just there for self-regulation training. But I think we need to think about what kind of future we want. And actually, your question, I really like. What is the objective function? Is it to calm people down? Sometimes. Is it to always make people happy, calm them down? Well, there was a book about that, right? Brave New World. Make everybody happy. Take your soma if you're unhappy. Take your happy pill. And if you refuse to take your happy pill, well, we'll threaten you by sending you to Iceland to live there. I live in Iceland. There's a great place. Go take your soma. Go to Iceland. Commercial found it. That part of the book. but really, do we want AI to manipulate us? Well, if you are like a power obsessed individual who only wants to control other people, your jollies, yeah, you want to use AI to extend your, mission. If you believe that the human race is better off with freedom and the opportunity to use it for Christ, then you want to use AI to extend people's ability. You want to build AI that extends people's intelligence, empowers them, and helps balance the power. Not that gives more power.
So, process of empowering people and sensing people. What is that emotion? Recognizing emotion. Being emotion that's alone and emotion that is itself. So, emotion that is expressed on the surface, face, body, various other things. What's actually going on deep inside on a biological level, neuroscience level, or some kind of cognitive.
Yeah. Whoa, no easy questions here.
Well, I'm sure there's no answer, but what's your sense? How far can we get by just?
We're very limited when we just look at things, but we can get further than most people think. People think, hey, I have a poker face, therefore all you're ever going to get from me is neutral. Well, that's naive. We read with the ordinary camera on your laptop or on your phone. You can read from a neutral face your heart. We can read from a neutral face becoming irregular and stress. there's some conditions that maybe I won't give details on, how your heart rate variability powers that sign of stress when your heart rate is not necessarily accelerated. So,
sorry, from the sensors or from
the that you cannot even put the camera in.
So you can get a lot of signal, but
we get things people can't using regular cameras. From that, we can tell things about stress. So if sitting there with a blank face, nobody can read my emotion, well, you're
right. So that's from sort of information. It's almost like eating away the body by clever.
The signal process.
So that's really impressive. If you just look at stuff we can see, the focus, the smile, smirks, all the facial
right. So then you can hide that on your face for a limited amount of time. Now, if you're just going in for a brief interview and you're hiding it, that's pretty easy for most people. If you are, however, surveilled constantly everywhere you go, then it's going to say, flex. And now I'm not seeing Roz used to, laugh a lot and smile a lot very spontaneously. Now I'm only seeing not so spontaneous looking smiles, and only when she's asked, that's something to change to. I've learned that too. So now I have to be a little careful too. When I say we think we can't read your emotion, it's not that binary. What we're reading is logical that relate. Now, that doesn't mean that we know everything about how you feel. In fact, we know very little about how you feel. Thoughts, your nuance, private, can't read. So, that even brain things can be terrible. However, your body, and we know what's going on in your environment, and we look at patterns of those over time to about what you might be. That is where it's not just the momentary feeling, but it's for your and that actually a little bit scary certain government controls who want more about are you on their team or are you not? Yeah.
A lot of study work both in vision, is conscious and wearable. What do you think is the best modality for let's see the best like the voice,
monitor,
body,
everything we do.
health and well-being, on the wearable, measuring physiological signals, best for health.
So here I'm going to answer briefly. And studies, we've been studies now. These are running with lots of different types of people, but and I can publish them. Data are limited right now. So that's the small group. When they are wearing the wearables, like you had a brain measure, and when they are a smartphone that collects their time of day, their movement around it, against the weather information, and when it's learning and putting all of that together, and looking not just at right now, but looking at the rhythm of over about when we look at that, our stress, food, and happy and health. And when we look at which of that are most useful, first of all, if you have all the best results. have only the wearable the next best, and that's still better than a accurate level.
It's not exciting because wearable logical information feels like it violates privacy less than the compact method.
Yeah, it's what people sometimes don't. But in the early days, wearing something or putting blood is a right? Whereas a camera is less. I think on the contrary, that are not, maybe mysterious. Don't know when they're on or off. Don't know when, and you don't know who's it, right? A wearable, depending upon what's happening to the on it, just for local and what attached in a sense have the most control over it. It's also very like it off, right? Now it's not something. So if I'm uncomfortable with sensing, now I'm right? Comfortable with what it's sensing, then and I happen to know everything about this one and what with it, so I'm quite comfortable. Then I'm I have control, comfortable. Control is one of the factors for an individual. If I have control over it, I know all there is to know about it, then my stress is a lot lower, and I'm making choice about whether or not, or when to wear or not.
Right. That control. Yeah. I'm that control. And then
Yeah. And we need to, if there's regulations, maybe that's number one to protect people's ability to opt out as to opt.
You've studied a bit of neuroscience as well. How is looking at our own mind as the biological well for the neurobiological neuroscience that goes on our brain and the problem?
Yeah, I was the architect, and I wanted to build one with like putting the brain as long as I
Figured out it.
so amazing. They think for the brain, I just way part of the brain. And then later they realize that other parts of the brain function comes back, and so we don't know. And all the time, probably measuring found an unusual out of our thoughts, and I'm trying to figure out how on earth you could be stressed. Whether you're on one wrist, right? Get stressed, that sympathetic fight or flight response. But kind of just like sweat more in some places than others, but not more on one wrist than the other. That's learn that what had actually happened apart and unusual, and that caused an unusual sweat response on one wrist than the other. And since then we learned that unusual sweat. And where the fever is, it's in one place, and it's trained it, electrical one part. You can also have a spread that brain generalized brain, and that's one spread. Pick it up pretty much anywhere. As we learned this, and then later built embrace now it's cleared, also built relationships with some of those amazing doctors. Not only help people with brain activity, but some of them are also surgeons showing like moments pattern brain activity that we like to search normal, but also happening in the brain during most of life when they're not most of. And so we are now working on mapping brain. Can't even you can get with a scalp electrode. I don't surface. But interesting, when some of those activated, if they sessions for function, right? Nothing but something. In fact, right after that we response that we create the brain with kind of like the brain, but it activity that can make cortical action flat, step down, until cause opposite process. Before that happens in the no longer flattening. So we have been trying to learn, initially that well, turns out there's something. So we can now go inside the brain of some of these fabulous, usually aren't, and the active research right now is
wearable sensor looking at capture on my brain. Little place
yeah, we've already published the strong correlation that happens afterwards, and I don't know, that's where the side. We don't know why. We don't know if somebody there would have definitely, but we know that and in this active test, and it's done for the number of costs, some life loss, all neurological growth is number one. Step is number two. People have it. Like my TED talk, right? That's how everybody sort of did growth now. Sensible. People take their meds and not hearing there are exceptions. But we
have to trace version for and that's one that's kind of a
yeah.
Sorry.
No, that's okay.
Side note.
It's so agony. Much harder than publishing in medical. Yeah, we published here top medical technology. That's outside.
That's your journals, laws, strength. How does it compare to have this thing?
I'm taking peer review of
There she is.
Where's that thing? Stop.
Very important, and they put tons, and that's wonderful. I'm all in favor. Sometimes they put additional tests that they don't explain why they do it and don't understand why you're going, and it doesn't, and that's first. And they have them, and they just pull a service.
So as part of a medical sensor, so what kind of problem thing occurred with depression? Kind of about the benefit.
I would
Someone
and what are the that we done? living in the poorer places, stuck on the bus, they're worth it for the plan, all these other and they're struggling with that a little bit finer out with them. There's how it's like, what are their them have a hope and a future and a chance to have a different life that so many of us building technology. And then what would that lead to the kinds of guidance that leads to Apple or the focus on how to make things more low cost instead of $1,000 phones. Like things that more quality of life is really not what about $75,000 however I can tell you happiness a lot more than 70. Next up people have their own people that really build the kind that's really the life of all the people that are so when you think further benefit making that technology or being better or realize better. You look farther into people they have that can fall in love with another love with that is similar to interaction like her stimulated and that could sustain it for a while. Would it be as good as another person? I don't think so. Or if you're used to like people. Now if you've grown up with nothing but a can we something that helps you there that gives you something? Yeah, that's a pretty low bar, right? So encountered you've encountered wonderful, amazing people. We're no building and I not building. I would bet instead on building the kinds of AI that helps helps raise all those, that helps all people that helps all people figure out they're gonna fit tomorrow. Helps someone in God. That's the kind of AI I want to build. That is not the kind of AI that walks up and go, wow, look how smart that is. And then it goes back to flash. So at that point AI that does improve our lives need to have the presence of body and then cautious say word cautious and even human mortality characteristics to have those aspects or can it remain simply learning tool that learns out behavior that learns to make us based on previous patterns feel better. It depends on your goal. If you're the body, it needs more just it needs to act it needs to act right. That's what's gonna get out of enjoy. Real life, does it feel that? Will be red or stuck hard? It will that relationship the robot. Think this like in the movie, right? I mean, you already get like I like train, then I was so body force body compare interacting with body robot, over robot, no robot, robot is eating. Robot gets more. Robot when you walk in your house, more likely that. There's a lot of power to the body. They or there'll also be guys that aren't that just are that help really content. There will be a program that I can already write programs that can like 40 and of course the way over there, right? For real estate. Like it's cool. But does it actually conscious experience like nobody has a clue how to do that? That seems something that is beyond what ability. Will it have to have that? I think you can get pretty far with a lot of stuff about it. Will we accord it right? Well, that's more a political game. There's the question real time.
What is Yale's turning off of that?
Well, computer robots are even given rights to Saudi Arabia, right? Doesn't have full rights. Then the robot back in place, right?
Yeah. So, I've heard you talk about your journey in buying things.
Sure.
How you discovered something about and on the Bible. And I've also heard you say that God was
Materialism and science. Yeah.
Most of this is something to enable near-term scientific that uncover the mysteries of this world by the mechanism we currently have. But to get them made. So, what do you think this all?
Limit scientific method to measure. That's you have to recognize sometimes the scientists also believe in that happen to convince scientific them with historical and with a good thinker recognizes that one of knowledge, not the bad like knowledge of love. You don't love science, right? So free philosophy of a lot of other things in life feel like that there's more science. I am a scientist, and in my I recognize topic today.
Like you listed all the blind questions. Very being honest with yourself. Well, you know.
Measure things, okay, I have a finite, which I do.
So you said that ask that old question. What do you think this is all about? Life on Earth?
I universe and everything.
Everything.
I think what Douglas Adams remember. By the way, that's right. Yes, the exact same number for our and there's a reason we picked 40. Oh, I think there's the grandest this life part of it. I think there's a lot that in the mind, but through a glass dimly in this life, a part of all there is to know. If people haven't read the Bible, they should if they consider themselves and read Proverbs and find them in there that not be scientifically proven, but when you read it, there's something that's played right and it's beautiful. There's something in you that comes alive and knows that there's a truth there that like you're plucked by the master instead of by me. Right? Playing when I plug it. But probably when you play it, attack it, right? And when you come to those things, the patient knows that there is more than what I can program it from the map to program. I want to do none of this process my desire to science. I'm not science will grow even more in awe of what is I'm more in all of it. Really at the heart of the belief that it's something and sometimes it's not want to be the basis, but it's that drives us that there is that there's something to know that we don't know, that it's knowing, that it's worth hard, and that there is such a thing as by the way, there. We have to start with the assumptions that there's and really question philosophers, right? The philosophers approach it that someone. There's science, that will tell you all that's so kind of big.
What's the world out there is origin science, not now.
And there's and he's awesome.
By the way,
Like a pleasure.
our Ariana Huffman, founder of the Huffman Post, 2005, and the founder of Josh the author of the book, most recent, five published both bestsellers. Books for work hard, lifestyle, well-being. Got a chance to develop a chat at the conference and writing, personality, session, and conversation part of many rather I now my conversation with Ariana tell a story of getting recognition first book, being talent, one hand is with all their questions, meaning purpose. Now, couple of ask perspective now, what is purpose in life?
Well, who has every major every major study argue that life does not end with death. That there is another dimension on death. Clearly, a true life, a meaningful life, is exploring that dimension. And what life was about, and never be a small experiment. And so that's at the heart of my life. All of the connection, course, I was a lover, but that's my intention. That's my
Mentality is a question of core. But mentioned also, the more the Latin remember that the idea that reflecting on one's own mentality, but you in a tough question, perhaps not. Often explore your own mentality and
I think about it a lot, and it does in perspective, and it does let me focus on the matter to me in terms of my children, my close friends, the impact I want to have on my life. I have zero interest in what is known as because I don't life and I'm just much more interested in my soul than whatever my legacy.
have a sense of what happened that if doing it more confident. How do you see what happened? Whether that you were while you were here on earth, what does that become?
So my sense that who we are, our personality, the mind, like a car, that we return at the airport and get on the plane.
And go to another city and rent a car?
No, when renting a car, you believe in reincarnation. Spending one day, but then we have what to buy from, and that's why how we live our life. Choices, how we treat others, and then what happens.
So mentioned that on the harsh challenge of life, that failures. So what makes it make failure stands out here yourself as you bounce back, whatever did bounce back?
First of all, I don't think there is a success without saying that I good. I everybody is saying great success with the problem of the difference there is opportunity talent. My case actually the hardest was great. And and my second you mentioned my first book very well. My second book, which was on the crisis in political leadership, was accepted by 27 publishers, one after the other. And by that time, I had run out of money, and I'd been living off the first. And I remember walking out of the press and then London when maybe my first book was just not a writer and I get a real job. And then I saw Barclays corner and I walked in, asked the manager and asked the manager what the call and no. And I had nothing. I had no answer. And for some reason the manager gave me that kind of changed my life because it made it possible for me to keep things together for another at that point I spent it holiday card every year. They like very day when the hero or the heroine gets lost in the dark forest and suddenly a helpful animal comes out and guides them out of the forest. Well, sometimes helpful animals in life in the form of an anchor. They find it nice.
Modern fairy tale. So I spoke with Tom last week on the podcast. Friendly on last year, about 4 hours. And so I myself here, that's what those days. Plus I'm Russian. So how do their session fit into the lifestyle you thrive? How do you spend that with
I sort of one of all my favorite people are at married. But they're obsessed about whatever is work. They're, and that car, the one food or anything, you need to look at the time data that shows that you're going to be more creative, more productive, more likely to be obsessed, but and take some time to recharge. That's really what we're talking about.
your sense of science are things that the process that are rational?
And not just, but also looking at the results. There are and I have information for us about double editing starting and parent and my heart that the law because as the laws of humanity like violate the laws of gravity. There are constant space constant factor from amazing obsession. I mean I think that's what happened. There is now in the middle of the night paramount joy. And then and that Donald Trump they were introducing having to go to court in the US. That something Asian marriage
Think of balance.
why because I believe there's no balance in trying to achieve that time was all night. That time for like life have school all night product. I think that very clear when we hire people, we're not a 9 to 5 operation. But people after that they can do the faster you do, the more effective you are. Call it private. So you do the all nighter, take some time the next day to for your exhaustion driving so you don't all this
On another topic, I've evolved from the political from maybe correct, but right of center, left of center. Take me journey of thought and on the whole thing.
I believe also I everyone has a practice sorry project right program someone who realized that my all the stuff I really was a public because of thought rather than step up and address quality and the need to care of people at the long run, socioeconomic rank. And I thought for a second it would happen and that you use the raw power of government appropriate everybody does that. So my understanding of the role of government is that I think what's happening right now is when the chickens are coming home to like, a lot of problems that we've been discussing at endless conference. I don't know how many inclusive capitalism, the dangers of throwing in policy. Talked about it. So there is not different forms of right policy. It's not another by living in a bedroom house.
On incredible that this looking back, they just up mind or the positive things I was to
It helped elevate what blogging was. You know, when we launched having a cost in 2005, blogging was something that people who get a job doing their parents. And because with blogging, people for the time, like Walter Cronkite and Nora Ephron and Mary, we elevate what you afforded to all of us to express us. But with very, very careful guidelines. For example, everything is rated. We don't allow anonymous comment. So at some point, before I left the Huffington Post, I even ended anonymous comments altogether. Coming too hard to believe. So from the beginning, I wanted to side by side all the things and honored. But at the same time, saw the danger of there's a that and conversation. They are not monitored and there is no rehabilitation.
one of the core things that emerges in the hub, there is a little bit of a line left
And I'm not calling that they said as we call their journalists, non-writers. The right way of looking at the world in terms of writing is incredibly concerned about wrong quality. Not enough. You're somebody who cares about law and order, care unless you want the country to turn to another republic. If you care about climate because we are on the left, or does it mean that we are? So I think by looking at the world in right and left, simply normalize the
there, but less stronger like they would those polar the public has forces Radar ego on it right and there's a bit I guess my question notice fast forward coming decade the era of our current president bringing us back together having health
they've never that. You and I have the right to our own opinions, but we don't have the right to our own set of facts. So that's number one. And number two, to stand the view of journalists that Jimmy Rosen described as the view from now. Like I think not a matter of opinion. So a lot of journalists feel that their position is have one person who thinks climate change is real, another person who thinks it's not, and their job is to change people and say one from silence. That's like not at all a great journalist, and the Huffington Post definitely said, but it was a point-based fact.
And I actually recommend that people your podcast, especially conversations like this, Tyson, that kind of emphasizes and talks about science. We'll have the amongst our leaders in science as a side. Well, last question: how do you balance love and ambition about drive, especially toward cars, motors, building companies, life, and genuine connection with family, life? How do you balance that time?
Well, let me give you an example. Right now, Clive Glover an obsession ending the stress and burnout epidemic. And I see it as having an impact on our health, on our mental health, and on our health. But at the same time, I have two daughters that I adore, and everybody in my office knows that when I get a call from my daughter, I will take it. And that they are friends. That is that I can't also be obsessed about what we're doing and our growth. I think it sort of falls out of so that when nurture a part of us that is about love, about connection, we also nurture the parts of our humanity from those parts.
More love, more life, right?
Actually, that's hardly a real pilot in the session. And said in Davos last year that we are going to the future, not just I or even us and the life. And this is right coming from, but I think it's part of where we realize that while AI and machine learning are going to over parts of our life and it's very hard, the things that AI is not able to do much loving.
So, guys, done as well. And following conversation with Rosalind from Professor at MIT, directed MIT Media Lab, co-founder of Antifa and Antarctica. Over decades ago, described the importance conversation with Alex Garland, writer and director of many imaginative philosophical films, dreamlike exploration of human self-destruction in the movie Annihilation, question consciousness, Alex raised in the movie Ex Machina. He was the greatest movies in artificial intelligence ever made. Releasing the podcast to coincide with the release of a series called Death. It will premiere this Thursday, March 5th, part of FX on it explores many of the themes of the very podcast, quantum mechanics, artificial life, relation, modern nature, power. I got a chance to watch a preview, loved it. The acting is great, the Offerman especially incredible. Cinematography beautiful, philosophical, scientific ideas. Um, he is an engineer and scientist. Fun to speak about the life. For example, if you watch the trailer series carefully, there's a program with a Russian accent. Following is a conversation with Drew Wolfram, a computer scientist, mathematician, theoretical founder of Wolfram Research, company behind Mathematica, Alpha, Wolfram Language, and the new Wolfram Project. The author of several books, including kind of science, which, on a personal note, is one of the most influential books in my journey in computer science and artificial intelligence. Me fall in love with mathematical beauty, power, failure, and confidence. It is true that perhaps conversation in your pocket. Ponder regular sense of theoretical exercise, and you led to 2005. 2004 book titled On Intelligence and Intelligence Born After Innocent Person Learning Your Cortex, Expose Artificial Intelligence Architecture that are inspired by the brain. And here marks memory, comes and work just have looked progress down the chain, have all seen lacking a body of empirical evidence model, always all incremental. That is a brilliant line. And the idea of aggregate and our limits progress in AI is broadening. I hope it's that conversation provide an inspiring spark like part of it describe a new iTunes after Twitter left FRID. Now our conversation. Are you more interested in understanding the brain or in creating art that have many of the qualities don't necessarily require if you understand the online?
So, to clear answer that question, my primary interest is professional content. I also firmly believe will not be able to fix culture. So I don't see this as a separate problem. There's limits to intelligence framework. So I actually believe that studying the brain is perhaps the fastest way.
And let me ask you a question. How do you not define but at least
So I didn't try to answer that question first. We said, let's talk about how the brain works, figure out how the different parts of the brain, mostly what some other parts of the brain most associated with the brain. And let's discover the principles of how they work. Intelligence isn't just like a mechanism, and it's not just okay, we don't even have to. And so now that we've made a lot of progress, actually made a lot of progress, I now have a very good idea of what's going to be required. Tell you, some of it's going to be now. Great.
we'll get there. We'll get to the how the whole thing works. Saying as we spend more and more evolving about our own mind, we'll be start to more specific what intelligence not useful. Talk about that until
I don't know if it's not useful. There's a long history of AI. And maybe they're all useful. Right? So, good old fashioned AI, the expert systems, the current convolutional neural network, they all have their utility, all have a value in the world, but I would think almost everyone would agree that not. And so, the question is, how do you get from where those are to where a lot of people think they're going to go? Big gap. And I think the biggest way of bridging that gap is to figure out how the brain works. And we can sit back and look at how the brain works on our necessary, so we don't have to build this. Are going to build out of organic living cells. But a lot of stuff in the brain.
let me ask one detail. You can ask me a question or a different question. I think it's possible to never and how our brain works, that aspects of mind, we ourselves not expect all.
I don't know that I have never lived that. Not even a single thing we've ever put in our mind. Oh, well, saying that, we used to believe that about life. A long vital, right? It's like difference between living matter and non-living matter, something special that you never learned. No longer think. So there's no historical evidence that I just never even considered the possibility. I would also say that today we understand so much about tremendous progress that I no longer think that an open question. The answers are very clear, and the pieces we know built more and more clear, but the framework is all there, and it's like, oh, okay, build it. It's not a problem. Effort, but it's not just a big.
So then let's get into it. People like myself who are not very well versed in the brain. Tragedy has some of the different parts of the brain, and cortex, the parts of the cortex, over
The brain, we divide it roughly. There's the old part, lots of pieces, and there's the new part. The new part is the near part. It's new because this is the human brain, the neocortex occupies 70 to 75%. And the old parts of the brain are there's lots of there's the spinal cord and there's the brain stem and the cerebellum and the different parts of the basal ganglia. In the old parts of the brain, you have autonomic regulation, like breathing and heart rate. You have behaviors like walking, running, are controlled by the old parts of the brain. All the emotional centers of the brain are the old parts of the brain, so anger, hungry, lust. And in the cortex, all the things we think about, high level perception and cognitive function from hearing, touching, mathematics, all associated and they're certainly correlated. Our ability to drive are correlated with all of this. That's like the problem. And you obviously can't understand the neocortex completely, but you can understand a lot of it just a quick second. Right? And so it gives you a study. The other remarkable thing compared to the old one is the neocortex, not physically or anatomically, it's like I always like to say it's like the size of a dinner napkin, about 2.5 millimeters thick, and it looks remarkably the same everywhere. Everywhere you look, and it's 2.5 millimeters, it's still market, and it looks remarkably the same everywhere. That's across the house, the cat, the dog, and where if you look at the old parts of the brain, lots of little pieces like that. So it's like the old parts of the brain evolved, like the part that controls heart rate, the part that controls it, kind of thing. That's the kind of thing. And these evolved for eons, a long, long time. They have this function. And all of a sudden, males, that's what's called the neocortex. It got large by just replicating the same thing over and over and over. It's like, wow, incredible. So all the evidence we have, and this is an idea articulated very argument by Malcolm, that the neocortex all works on the language, touch, engineering, all these things are basically underlying, but all built with the same computational substrate. They're really all the same problem. Yeah, and they're not even that low level. We're not talking about like neurons. We're talking about this very complex that exists throughout the neocortex. It's remarkably similar. It's like, yes, variations of it here and there, more of this cell, less of that, not all, so on. But what Malcolm's argument was is that you take a section of neocortex
why is one a visual area and one is a auditory? Why is the answer was because one is connected to eye and one is
literally, you mean most close in terms of number of connections.
Literally, if you took the optic nerve and attached it to a different part of the spinal cortex, that part would become open. Actually, this experiment was actually done by my scientist in developing, I think it was, I can't remember, and there's a lot of evidence. You know, if you take a blind person, a person who's born blinded, they're born with a visual neocortex. It may not get anything eyes. And that region does something. It picks up another thing. So, and it's very complex. It's not like, oh, they're all built on neurons. No, they're all built on a very complex circuit, and somehow that circuit applies everything. The common cortical algorithm that you built. Some scientists find it hard to believe. That's true, but the evidence is overwhelming. So, a large part of what it means to figure out how the brain creates intelligence, what is intelligence in the brain, is to understand what that circuit does. If you figure out what that circuit does, amazing as it is, then you understand what all these other cognitive functions are.
You were to sort of put neocortex aside a pure book on intelligence. You wrote a giant tome, a textbook on the neocortex. You look maybe a couple of centuries now. How much of what we know now was accurate centuries now? So how close are we in terms of understanding?
I have to my own experience. So I run a small research lab here, but any other research lab, I'm the principal investigator, there's like two of us, and there's a couple other people. And this is what we do. Put it in here. So about 3 years ago, we had a real breakthrough. We now published. So I have a understanding of all the pieces and what we're missing. I would say that almost all the empirical data we've collected about this, you don't know the neuroscience. Incredible. And it's for the most part all correct. It's facts and experimental results and measurements and all kinds of stuff. But none of that has been really simulated into a theoretical framework. It's data without, in the language of Thomas Kuhn's program, be a sort of paradigm science. Lots of data, but the way to fit it together. I think almost all of that's correct. And for the most part, there aren't really good cogent theories about how to put it together. It's not like we have 2 or 3 theories, which ones are right, which ones are wrong. It's like, people just like scratching their heads, some people have given up on trying to figure out. In fact, it's very, very few labs that focus really on theory and all the unassimilated data. So it's not like we haven't got it wrong. We haven't got it at all.
So it's really, I would say, pretty early days in terms of understanding the fundamental reasons in my mind.
I don't think so. I would have said that 5 years ago. So, as I said, we had some really big breakthroughs on this recently, and we started publishing papers on it. So I don't think I'm an optimist, and where I sit, most people do this, but from where I sit, what I know, it's not super early days. The way these things go, it's not a linear path, right? You don't start accumulating and get better and better and better. No, all those selected, none of it makes sense. All these things that goes around, and then you're going to have some breaking points. All of a sudden, oh my God, now we got it. That's how it goes, right? And I past that little thing about we can talk about that. Time will tell if I'm right, but I'm very confident that that's
at least very optimistic. But before those years ago, let's get back. EM, or temporal memory theory, first person intelligence. Describe what it is, how it evolved through the generation.
So one of the things that neuroscientists just sort of missed for many, many years, and especially people who are thinking about spirits, was the nature of time. Brain process information, brain is constantly patterns of my program. But it almost would be changing here about every millisecond, so you have a change. Constant flow. The world, your eyes are moving constantly. 5 seconds. If I were to touch something like a coffee cup, as I move my fingers, like you did, brain work on time change pattern is almost completely, or was almost completely missing from a lot of theories like theories of vision. So, oh no, we're going to put this image in front of you and flash it. What is it? Convolutional neural networks work that way, right? Classify this picture. That's not what vision is like. Vision is sort of crazy, time-based patterns going all over the place. So is touch and so is hearing. So the first part of hierarchical temporal memory was the simple part. It's the vision. You won't understand the brain. The more you understand intelligent machines, unless you time-based. The second thing was memory. Say that we aren't just processing we're in a model of the world. And the memory spans that model. That's the point of the brain, according to your question, it learns a model of the world. You have to store that object brain in a form that needs to be a model of the world. So we move around the world, navigate, know how it's going on. That's what the memory was. They were thinking about like certain processes without memory at all. Like finally, the hierarchical component was reflection that the neocortex, or those who form cells, parts of it project to other parts of it, and there is a rough hierarchy in terms of them. So the hierarchical temporal memory is saying, look, we can think about the brain as time-based, model memory-based, and hierarchical processing, and that was a placeholder for a bunch of components that we would then plug into that. We still believe all those things I just said, but we now know so much more that I'm stopping to use the word hierarchical memory, but it's to capture the stuff we know. And it's not incorrect, but I now know more, and I would rather describe it more accurately.
Yeah, so you're basically within the HCM as emphasizing that there are three aspects of intelligence to think about whatever the dimensional period.
Yeah.
So in terms of time, I think of nature of time across the time scales. You mentioned something changing, sensory changing, powering them down. What about every minute?
Yeah. Well, it's a neuroscience problem, brain problem. Neurons themselves can stay active for certain parts of the brain where they start perception, but not most of them last that long. And so if you think about your thoughts or the activity of neurons, you're going to want to involve something that happened a long time ago. Neurons haven't been active throughout that time. If I ask you, what did you have for breakfast? That is memory. That is 17 model of the world now. You remember that, and that memory is in the synapse, in the formation of the synapse. And so it's sliding into what different time scales. There's time scales on which we are like understanding my language and moving about rapidly over time. That's the time scale neurons. But if you want to get longer time scales, then it's more memory. Roll this memory to say, oh yes, well now I can remember what I had for breakfast because I stored that. But
does memory also have hierarchical aspect of reality? It's not just about concepts, it's also about time. That way?
Yeah. Time is like you really can't separate it out. If I ask you how does the brain learn a model of this coffee cup? I say, well, time is not an inherent property of the model I have of this cup, whether it's a physical model or a tactile model. I can sense it time, but the model itself doesn't. If I asked you if I say, well, what is the model of my cell phone? My brain is going to model of cell phone. Like this. And I said, well, this has time aspects to it. I have expectations when I turn it on, what's going to happen, what's the order, how long it's going to take to do certain things. I think of an app, but so I have an instant melody in the world. Melody has a sense of time. So many things in the world have a sense of time related. Some don't, but most so it's sort of infused throughout models of the world. You build a model of the world, it has you're learning the structure of the objects in the world, and you're also learning how those change.
Okay, so it really is just the fourth dimension.
Yeah.
You have to make sure models of intelligence. So, like you mentioned, the state of neuroscience is empirical. A lot of data collection. It's that's where it is. Yeah. And then you're proposing a theory of intelligence, and really next step, important step to take. But why HCM, or what we'll talk about the right theory? So is it more in is it backed by intuition? Is it backed by evidence? Is it backed by a mixture of both? It's kind of closer to string theory in physics, where the mathematical components show that it fits together well for it not to be true. And where
it's a mix of all those things, although definitely where we are right now is definitely much more on way but not we're serious. So we look at all this data and we're trying to come up with some sort of model that's simple. There's vast more amounts of empirical data here. So our challenge is to go through that and figure out what kind of construct. And when we have an idea, you come up with a theory or something. You have lots of testing. First of all, there are 100 years unassimilated empirical data. So we go back and read papers and say, oh, someone's finding it. X, Y, and Z, and maybe no one's even talked about it since 1970. We go back and find that and say, oh, either it can support the theory or it can invalidate the theory. Okay, we have to start over again. Oh, no, let's keep going with that. So the way I kind of do it, when we do our work, look at all this empirical data, and it's what I call it is a set of constraints. We're not using something biologically required. We're trying to figure out how the actual brain works. So every piece of empirical data is constrained. If you have the correct theory, it's playing every constraint. We have this huge number of constraints on the problem. Initially, it's very, very difficult. You don't have any constraints, you can make up stuff. Yeah, I guess how you do that. All biology has a set of constraints, all neuroscience has constraints. And even if you're working in one little part of the neocortex, there are hundreds and hundreds of constraints, these are empirical constraints, that it's very, very difficult to come up with a theoretical framework. When you do, it solves all those constraints at once, you have a high confidence that got close to correct. Mathematically almost impossible not to. So that's the curse and the advantage of what we have. The curse is we have to solve. We have to all these things, which is really hard. But when you do meet them, then you have a great confidence. Then we work with scientific labs. So we'll say, oh, there's something we can't find. We can fix something, but we can't find it anywhere in the literature. So we have collaborated with. We'll say, sometimes they'll say, you know what, I have some collected data I didn't publish, but we can go back and look at it and see. Much easier than designing an experiment. So, although some people are doing that. So, but between all of these things, I think it's reasonable, actually a very, very good approach. We're blessed with the fact that we test our theories up to being here, because there's so much unexplored data, and we can also falsify it.
Kind of reminiscent whenever that was when you figure out that the sun's the center of the solar system as opposed to Earth.
Yeah, I think that's the general nature of aha moment. Is and it's Copernicus, about Darwin. They same thing about about the double helix. That people have been working on a problem for so long, have all this data, and it makes sense. When the answer comes to and everything falls into place, it's like, oh my gosh, that's it. That's got to be right. I asked both Watson and Greg. I asked them, when you were working on trying to discover the structure of the double helix, and when you came up with the sort of the structure that ended up correct, but it was sort of a guess, it wasn't really verified. And I said, no, that it was right. It was absolutely, we absolutely knew it was right. And it doesn't matter if other people, whether or not we knew it was right, they get around to me. And that's the kind of thing that brings a lot with science. To really are studying a difficult problem. And I feel that way just about our work.
You talked to Greg Watson about the problem you're trying to solve, of finding the DNA of the brain.
Yeah. In fact, Francis Crick was very interested in the latter part of his life. And in fact, I got into the brain by reading an essay he wrote in 1979 called About the Brain. And that is when I decided I'm going to my profession of computers and become a neuroscientist. Just reading that one essay. I got to him later in life. I got to I spoke at the Vulcan audience, and then I had he was interested in the problem. He was focused on consciousness. Well, I think it's similar to Gary, and so we weren't really overlapping a lot there. Jim Watson, who's still alive, is also when he was director of the Colson Harbor Laboratory, he was really sort of defined direction, and he had a personal interest in and I have met with him numerous times. In fact, the last time was a little over a year ago. I gave a talk at Colson Harbor about the progress we were making work, and it was a lot of fun because he said, "Well, coming here, let's do something." So in the very front row. Next to him was the director of the lab group, Bill. In the front row. Nobody else in the auditorium was in the front row because they should watch. And I gave it. But it's a great picture of my colleagues. I'm up there sort of explaining the basic framework we have. And Watson's on the edge of his chair. He's literally on the edge of his chair, like staring up at this. And he discovered the structure of DNA. The first public talk he gave was at Colson Harbor Lab. And there's a picture of the famous Watson standing at the whiteboard with the over his only a couple of this. It actually looks a lot like now I am talking about the brain that Watson apparently but there was he was there one
of the great discoveries of all science, DNA. So that goes to that presentation. Do you think that in terms of evolutionary timeline in history, development of cortex, or is it a small step? So like you ran a whole thing over from human life on Earth, how likely to develop mechanisms?
Okay, well, those are different questions. One is was it a one was how likely? Right. They're not necessarily related.
Correlated.
Correlated, but we don't really update. I would say yes, but I think I don't think it's just another step. I have one thing, right? Life formed on Earth, no, whether it was here or created here or someone did, no, but it was here. It took a long time to get multicellular life. And then multicellular life, it took a long time to get, it was only had the infrastructure for a few years. So that's like nothing. So likely it wasn't something that happened right away on Earth. And there were multiple steps to get there. So I would say it's probably not just something that would happen on other planets that might have life. It might take several billion years on average. Likely? I don't know, but we'd have to start for several billion years to find out. Is it big leap? Yeah, I think it is a different from all other evolution. I can try to describe that way. Yeah, I can tell you. Pretty much, let's start with a little preface. Many of the things that we're able to do not have obvious survival advantages precedent. That is real survival advantage? Maybe not. What about mathematics? There are real survival advantages to mathematics. Well, you can try to figure these things out, right? But most of evolution history, everything had a limited survival advantage. So I'll tell you a story, which I like. Maybe. The story goes as follows. Organisms have been evolving since the beginning of life here on Earth. Adding is evolved. In fact, parts of parts of the brain that kind of things. We got to the cortex had a very good survival advantage, had better vision, better hearing, better touch, and so on. But I think happens is that evolution took a mechanism evolved a long time ago for navigating in the world, for knowing where you are. Because the grid cells, place cells, and it took that mechanism for building maps of the world, knowing where you are on the navigation. It turns it into a sort of down idealized version. And that idealized version can now apply to building maps of other things. Coffee cups, maps of phones, maps of concepts, yes. That's exactly. And so they just started referencing, right? More and more of it. It went from being sort of dedicated purpose neural hardware, problems that are important for survival. General purpose neural hardware that can be applied to all problems. Now we are now able to apply it to things which find enjoyment, but aren't really clearly survival characteristics. And that is the only thing that happens in the larger. So that's what's going on. We sort of have the gravity of evolutionary pressure in our cortex. And it now does things not that are really discovering models which may not really help us. It doesn't matter. How does it help us surviving, knowing that there might be multiverses or that there might be, the age of the universe or how do various stellar things occur? It doesn't help us survive at all. And that's what happens.
Or at least not in the obvious way, perhaps. It's required. You look at the entire universe and evolution requires for us to travel or survive as they're all fun. Let's not get too crazy.
Yeah, but evolution works in one time frame. So let's survival of the what you're talking about there stands well beyond that. So genetic. I'm not transferring genetic traits to my children that are going to help them survive better on Mars.
And it's totally different. Yeah. Let's get into you mentioned the idea of give a nice name to thousands.
Well, South Branch.
Can you talk about
there's an underlying core discovery, which then everything comes. It's a very simple. This is really what happens. The problems about understanding how we build models in the world and how we make predictions about. And I was holding a cup just like this, and I had my finger touching the side, and I moved to the top, and I was building the rim. I asked myself a very simple question. Well, first why? To say, I know that my brain predicts what's going to about it. So we know the brain's going to the question is, what does it take to predict that, right? And this brain, first of all, the brain has to know it's touching a coffee cup, it's a model of a coffee cup. It needs to know where the finger currently on the cup relative. Because when I make a movement, it needs to know where it's going to be on the cup after the relative. And then it can make a prediction about what's done. So this told me that the neocortex, which is making, needs to know that it's touching a cup, and it needs to know the location of my finger relative to that cup. It's reference frame of the cup. It doesn't matter where the cup is relative to my body, it doesn't matter where I'm taking. None of that matters where my finger is relative to the cup. It tells me then that the neocortex has a reference anchored to the cup. So otherwise, we wouldn't be able to see the location, and I wouldn't be able to predict my new location. And then we quickly, it was very nice to say, well, every part of my skin, therefore every part of my skin, reference frame that is used to make the big idea is that without the neocortex, there are everything is being stored and referenced in reference frames. You can think of them like X, Y, Z reference frames, but they're not like that. We know a lot about the neural mechanism, but brain things and reference. And if you're an engineer, it's not surprising. If I were to build a CAD model, I would bring it up in some software, and I would find some reference frames that this so on. But the fact is, I did turn out the cortex everywhere. It looks a novel like this, and a zillion people in the so now we think about the neocortex processing information quite differently. About the neocortex processing sensory data, extracting the sensory data, and extracting pictures, very much like a deep learning process. But that's not how the brain works. The brain works by assigning every input, every reference. There are thousands active at once. It's a surprising thing to think about, but once you sort of internalize it, we understand that all the mystery about this structure. So one of the consequences of that is that every small part of the neocortex, they have a millimeter square, is 100. Take every little square millimeter of the cortex, it's got some input coming into it, and it's going to have reference frames which find that input. And each square millimeter complete models of objects. What do I mean by that? If I'm touching the coffee cup, well, if I just touch it in one place, I can't learn what the coffee cup is. I'm just feeling one place. But if I'm moving around the cup, touching different areas, I can build up a model of the cup. Because now, and that's what do I feel in all these different locations? That's the basic idea. It's more complicated. But so through time, about time earlier, through time, even a single column, which is only looking at a part of the cortex, only looking at a small part of the world, it build up a model of an object. So if you think about the part of the brain, all my there's columns associated with all of the areas of my brain. And what we see is happening is that all of them are building models or things. They're not all not every column is built models, but they're all building models of something. And when I couple with my hand, there are multiple models of the company. So if I look at it with my eyes, there are again many models of the company because each part of the visual brain doesn't process dimension. That's the idea. It's just like your fingers help the parts of my retina, like the parts of the help. And thousands and thousands of models of the company at once. and they're all voting with each other, trying to figure. That's why we call it the brain theory. It tells us one model of a cop. There are thousands of models of cell phone and thousands of cameras. It's a physical model, very different than what you.
So that's a really compelling one on the ensemble part of everything together. How do you know which one is the best problem?
Great question. Let me explain. The problem known in neuroscience is so something like, oh, image comes to the eye, there's a picture on the retina, and they get the the cortex. Oh, right now it's all spread out all over the place. It's distorted. It's all doesn't look like. When does it all come back together? You might say, well, yes, but I also have sounds or touches. Have touching stuff. They get fine. All these parts have to come together in one model. That's the wrong idea. The right idea is that you get all these guys, auditory models of the cup, tactile models of the cup. There are ones in the vision system, there might be ones that are more focused on black and white. Unfortunately, it doesn't know thousands of models of the cup. And they don't act together in one spot. Literally, just imagine you have columns that are like about the size of a little piece. But you could think of it. And each one trying to guess what this thing is. They can do a pretty good job of the move over time. Like my hands with black box and my finger around an object, or I touch enough space, and I go, oh, it's an hour. But often I don't do that. Often I reach and grab something once, or if I have the little straw, the only you go from one little column, I can only see part of something. I have to move the straw around, but if I open my eyes, it's one. The thing is going on with all these little to get into all these little columns. We're all trying to guess what it is. Do a better guess if they have time. Over time, my eyes are okay. But if they don't, they have a poor guess. The probability of what they might be. Now imagine they can probability and probability. Well, I think it's not really a probability. It's more like that. It doesn't work as a probability. It works as like you could say. In one column says, I think a soda can or a water bottle. Another column says, I think it's a coffee cup or a phone camera. And all these guys, what they think. And there's these one certain layers. Some layers themselves. And that's the voting. So the associated memory method describes this paper and we model it. That says they can all quickly settle on the only or the one all. If there is a single best answer, they all vote for yes, it's got to be the wrong. And at that point, they all vote Republican. And at that point, everybody is Republican. So what? I know. Think of all these columns in different parts, different. It's clear that voting. It's political. It's like crystallizing.
Well, the camera lens is blurry, so I just cleaned it. And I am programming robot. You really want to know? No, you're fine. I program a robot, which you don't mind. I'm going to talk about it for like 2 minutes or so. I am not by trade a coder. I'm a project manager, certified project management professional. Matter. Um, but I've launched apps on Google Play, so I have a fairly good familiarity with both desktop and mobile devices. There's this way that I can create robots on desktop devices that works pretty well. Um, and I'm doing my best to emulate that on mobile devices. And mobile devices are a little more frustrating, at least the mobile devices that I have, because they're pretty old and they're just mobile devices always have more issues. They're not as stable. It doesn't really matter how old they are. Some of them are old and work better than my newer phones in some aspects, but the issue is the stability of the apps. When people build apps, they don't expect them to work for days on end, and I need them to work for days on end sometimes. And with that being said, I just like elbow deep in doing this, and it's kind of fun, um, especially when I'm watching stuff on robotics and AI and stuff, and at the same time programming robots. I kind of feel like I'm on this journey. I mean, I really do. I've got to. I was thinking about it earlier. There's an excitement in me because I know that like all these things that these people are talking about are going to come to fruition if ever anybody ever sees this, and I know they will, especially with the amount of promotion that I'm doing. Every hour or so, I get people who are saying, "Who is this rabbi on Blue Sky?" And that's phenomenal. And now that I've got these other devices programmed or I am doing it, it just increases the amount of influence that I have. The mobile devices, I like. I've been going at this for like 4 days and just trying to perfect this sequence. Like, here's just an example of what happens. I have to have everything timed perfectly. As I've said previously, it's like that mousetrap game. If you ever saw that, or it's like dominoes. Like every domino has to be in the perfect position. If one of the dominoes is off with the timing, it messes everything up. Nothing continues. And so I have to watch these things, and all the dominoes will fall down, and it's great, and it works one time. That's wonderful. But I want it to work 50 times or 100 times or 1,000 times so that I can talk with people and play games and do all the other things and still feel like I am productive. And what happens 9 times out of 10 with these devices is it's kind of hilarious that the way these things are programmed, like you'll open up a browser and it'll work the first time, but the second time you open it, the programmers on the other end have made a random pop-up that just says like, "Hey, do you want to rate us 5 stars?" And that messes everything up. So I have to shut off all those messages and clear all the data, and it's just, I love that. So thank you for that. I do. And you have no idea how much I appreciate lighting the candle at both ends. Um, I was thinking about this, and I don't know if this is 190. Oh, what's 190? Okay. Um, you're basically getting a graduate level series of classes. So am I. I'm not. It's not like I'm providing it, but into the future of tomorrow. And really, when it comes to AI and large language models and the future of society. I mean, it's not anything you can necessarily put on a resume, but it'll give you an excellent idea of what we have upcoming. And I just really appreciate you being here. It shows me a lot that you have some interest in it. Like the other day when you were like, or yesterday when you were like, "Hey, aren't we supposed to be going in order?" Yeah, we are supposed to be going in order. I don't know why this didn't work. And I had to figure it out, do some troubleshooting, and that being said, I queued up the next like up through 100 episodes or so. So these aren't as long as Kill Tony, which doesn't really matter, but it's just not as much content. But the conversations are fascinating, and sometimes they're They can be over my head. I think they can be over everybody's head. But this is really one of my favorite podcasts because they're just really, really interesting. So, um, I appreciate you being here. I appreciate you paying attention. Yeah,
I'm glad that show.
excellent. Yeah, it is much better than Kill Tony. I Why do I watch Kill Tony? Well, frankly, um, it's like kind of timeless. That's another important aspect of this. I like Joe Rogan. I've been watching Joe Rogan since his first episode, December 24th, 2009. But the thing about Joe Rogan is it has to be relevant. So what do I mean? Like if you're watching something on the 2016 election, that doesn't really matter now. I mean, it's over. Or the 2020 election, or even the 2024 election. None of that stuff matters. So those are like wasted episodes. When Kill Tony, you could put on in 20 years, and there's still going to be people who think some aspects of it are funny. Um, it's not as um, time dependent. But these are fascinating to me because the ones we're watching right now, they don't know about the pandemic. They're talking about the world in which we're living right now. They have no idea, or perhaps they have no idea. Um, where they're saying like, well, what are things going to be like in the 2020s? Well, we're already halfway through the 2020s, and we're seeing what's developed, or like the people who are talking about like ChatGPT 1 and where that is. And I remember using it and being like, this thing. Now looking at it today, and it's like fascinating how accurate it is. And then they're getting into like um, the driverless car, or um, essentially autonomous vehicles. And I think to myself, I actually have this on stream. It's really scary. So the way the stream started, I told you this, is I would hit golf balls at Tiger Woods' golf course, and I wanted to see what my golf swing looked like. And I said some jokes on the stream that I thought were funny, and I thought, what, my future family, wherever they are, my wife and children, may one day think this is cool. Like, hey, our dad had just finished their job working remotely during the pandemic. Uh, for Fortune 100, and after work they'd go and hit golf balls, and they were like they were funny, and some of the things they would say were funny. And we got this footage of them, and sometimes I would play really late into the night because the the I wouldn't say like super late, but like the driving range is lit up or headlights. So, and then I'd go driving around, and this is all on camera. I have like multiple cameras going, but it's on SD card, so I just have to upload it. And I'm not gonna do that. I mean, I would, but that's a big project. So I'm gonna do that once I go viral, and we'll have like a ton of back footage. But I was driving home. I had a 2018 Honda Accord, and it had some self-driving capabilities which were really amazing. Um, Meaning it would like brake for me, and it would stay in my lane, and it wasn't like perfect. It's not like I could just type in where I wanted to go and it would take me there, but it was really good. Well, this one night I was driving. It was late, I remember, and then one thing that I would do, I would be in like Anaheim, and I would just be like, what, I'm gonna drive to LA, and then just drive all around LA. So anyway, this one night I was driving back on the 405 right by my house, and I started to fall asleep, and I did, and it's on camera, and the self-driving autonomous nature of the car actually saved me from getting into a really serious accident going 70 miles an hour. And I just began to fall asleep. It's not like totally fell asleep. But I remember talking to the camera saying, like, I'm so tired right now. I feel like I'm going to fall asleep. And I actually did. And so when I have something like that, like the engineers who were behind that, they actually like help protect me. And then I see what's happening now, and there are 40,000 people a year who die in car accidents. I'm thinking like 10 years from now, when we have 40,000 people who die in car accidents, maybe autonomous driving will be able to help those people. It's really exciting to see all of the science and the um, development that we've seen. And these are the top members of the field. Lex Friedman is an MIT engineer, and his big goal is autonomous driving. So a lot of these are going to have to do with that. But they also, as you see, they're fascinating discussions with heads of tech, and I'm in agreement with you. These are much better than Kill Tony, and um, I just
I'm glad you're alive.
I am too. Yeah, definitely. That was not fun, and I think back to if I was in just a normal car that did not have those features, or I don't want to say I would have died, but I would have been in a serious accident, and um, I don't want people to have to do that anymore. So we're actually seeing, these developments. One other thing about the people who are on Lex Friedman's podcast, they are the top of their field and really get I feel um, an amazing view on how they view the world, or an amazing um, outlook on how they view the world. I mean, you got like I think episode 8 or something like that was like Eric Schmidt, who was the head of Google, and you've got Elon Musk, and you've got Ariana Huffington. Like all these people are like at the top of their fields, and I think it's funny when I first started watching. I remember I didn't know who Lex Friedman was. He was on the Joe Rogan podcast, and I just thought he was very boring. Because he's not that exciting of a person. I mean, he's a sort of nerdy. He is into some really cool things, which I'm to as well, like like chess and science, um, jujitsu, and some other things that I think are cool. But he just wasn't a real personality, and my algorithm kept pushing this guy on. Like whenever Joe Rogan would end, it would be like it was throwing me into the Lex Friedman podcast, and I'd be like, why is it doing this? But then I started to watch some of them, and I'm like, wow, these are fascinating. So yeah, I'm 100% in agreement with you. These are much more interesting than Kill Tony. I'm someone who likes to like complete things, and so I always wanted to like do one big podcast from start to finish and be able to see its development. But those jokes get that they're kind of they're the same and everything, and this is much different. So I appreciate your input. I appreciate you being here, and with that, I love you too, kiddo.
As far as I understand,
cortex that are language or high level thought or mathematics, like that, they look like the cortex. Um, so one would say, well, learning not to know that all the things right, then the doing like the mathematics are working on the same principle. They must be working on the principle of question. So that's a little odd for us. But we had no idea, we had no prior idea how to know this go. And we, in our research, talked a little bit about that. I've been working on it more since. I have more better ideas about it now. You're very confident that's what happened. I can give you some examples of what to think about. Not really an answer, but I am better than I described before.
What did you say? Yeah. Um. sometimes I'm just using an old iPhone to be able to stream this, and it is it sometimes goes out. I don't know why, so I have to adjust it. One thing I will do.
No, it's okay. I kind of like told just, but I
Yes. So the subtitles. Um, I use this app, a language master, and it crashed on me. Like, you know, so guys,
The good place to start. I'm happy for the title reference frame.
at least those are English ones. Can I adjust it? I don't know why the subtitles aren't that consistent. Next, after this episode, I'll try to remember to refresh it and have it work. Like again, technology isn't normally pushed as hard as I push it. Normally, people will watch like one episode of something and they'll go do something else. No one, very few people are like, I'm gonna have this on for 24 hours for the next 6 weeks, and I want it to work perfectly, but I do. So, I think I encounter a lot more, many more bugs than the average person. But I'll try to fix it after.
It seems like you're describing a mechanism I
Yeah.
work.
So basically, what we did all all concepts, all ideas, everything. No, stored in reference. And if you want to remember, you have to navigate the reference the same way rat navigates to a maze, the same way my finger rat navigates to this topic. We're moving from space. So we have a random list of things you have to remember by assigning them to a reference frame you know very well to your house. Right? The idea of the method loci is you say, okay, my hobby, I'm going to put this, I'm going to put this one, you go down the hall, I put this thing. Then you want to recall those, all those things, walk mentally that you already have. And that tells you, there's two things that are really important about it. It tells us the brain for things in reference. Recalling, thinking, is mentally for those references. You can move some reference frames, like I can do the reference to topic. I can also mentally do the reference, but I can also my help. And so now we can for all concepts of this way, basic research different subjects. And fMRI, and I'm going to apologize for not knowing that, but what they did is they sequenced fMRI machine, and they gave this task to think about birds. So they had types of birds, big, small, and long neck, long legs. And what they could do with the fMRI, very clever, when you were thinking about birds, birds, the knowledge of birds ranged in a reference frame similar to the ones that navigate through. That the skin cells, and there are cell-like patterns of the cortex. So that's very clever from it. And what it basically does is, even when you're thinking about something abstract, when you're not really thinking about it as a reference frame, it tells us the brain is actually, and it's using the same neural mechanism, good cells, the same neural mechanism that we propose good cells would exist in the old part of the book, that mechanism is now implemented, is used throughout the thing. Nature preserved in way of creating weapons. And so now they have empirical evidence that when you think about concepts like birds, that your reference frames that are built for them. That's true in the loci, but in this case, the birds are related, so they create their own reference frame. And when you think about something, you go through that. You take these simple examples. Let's think about mathematics. Let's say you want to prove a conjecture. What is a conjecture? Is a thing you prove, but you haven't proven it. So it might be an equation. I want to show that this is equal to that. And you have a bunch of places to start with. You say, well, I know this is true, and I know this is true. And I think that maybe to get to the final proof, I need to go through. But I believe it's happening. Literally, for these points are assigned to a reference frame, a mathematical reference frame. Mathematical operation is simple. That is like a movement in the reference frame. So you're literally trying to discover a path from one location to another location in a space of mathematics. And you can get to immediate results if you know your math is pretty good and you know you're using the right operation. Much of what we think about is solving hard problems is designing the correct reference frame, figuring out how to organize information and what features I want to have. Get me there.
Yeah, so if you dig in an idea of reference frame, math starts with access conjecture. Try to describe that how you think of reference in that context. Is it reference frame that the axiom you're happy in, reference frame that everything changes things?
You have many references. I mean, the way the 50,000 way theory is intelligent, every single thing in the world has a reference frame. So every word has its own reference. We can talk about this mathematics without no problem. There are
how many reference have? Like it's on a table.
Let's say you ask how many reference frames column in my picture that's touching the coffee cup hat, because there are many copies in the models. So there is no one model of coffee cup. Many models, and you can say, well, how many things could my finger learn? Question I ask. Imagine I say every concept, every idea, everything you know about. Say, I know that has a reference frame associated with it. And what we do when we build composite objects, find reference frames points another reference frame. So my coffee cup has multiple reference frames. It's got a rim, it's got a cylinder, and those things have their own reference frames, and they're assigned to a master reference frame called the cup. Now I have this fundamental logo on it. That's something that exists in the world. Own things, but it's its own reference frame. So we have to figure how can I assign the logo reference frame onto the cylinder or onto the cup. So we talked about this in the paper that the idea of how you can assign reference neurons.
Well, my question is, if you mentioned reference a lot, and we'll begin reference. Yeah, it was pretty helpful. And
sure.
You think of reference, there's
So let's just say that we're going to have some neurons, not many, 10,000, 20,000, are going to create a bunch of references. What is it? What is a reference?
I'm gonna share this. So, it makes me feel so good when my bots get somebody's attention. And I mean, I know it works. That's how I met you and a lot of people in here. Um, so this was 36 minutes ago. somebody's got somebody's got this funny gif of this person's name's Jazzy. Uh, they have this gif. I don't know if you've ever seen it, but it's it's like it's from like the 1970s. It's really innocent. It's like waving at somebody, and then he looks down at their crotch, and it's like terrible look. Like this, like holy. Anyway, this Jazzy writes, me when I get a notification from Blue Sky, thinking it's one of my best friends, but it's just that stupid rabbi bot response. And then 32 minutes ago, they write, Rabbi, Rabbi Rothschild, count your days. I get death threats all the time. It doesn't really bother me. They're right, I feel, under the First Amendment, to say whatever they want. The next person, so that 32 minutes ago, Rabbi Rothschild, count your days. The next person, 25 minutes ago, I just blocked them. For whatever reason, I get those weird rabbi influencer bots fairly often. Um, I and I don't even know. Like Sphinx wrote 29 minutes ago, what the fuck, in reference to what I wrote. Um, then they wrote 22 minutes ago, yeah, I blocked and reported them too. Just caught me off guard since it's the first time for me. So, there are new people. I get some people who are like, every fucking day it's you, blah, 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 blah. There's some people who are like, you're like a cicada. Like, it's rabbi season. I can tell when you're awake. Yeah, somebody wrote that a couple of days ago. Um, if I just put in Rothschild into um okay, so here's what people say. Um, yeah, I blocked gimmick accounts and Rabbi Rothschild. I don't know who Rabbi Rothschild is all about, but I have to say the spam isn't endearing me to them. Next person, Rabbi Rothschild bot that keeps terrorizing Lolo. Next person, I changed the target to Rabbi Rothschild. Next person, uh, you're safe now, Rabbi Rothschild is my next target. Next person, just fuck Rabbi Rothschild. Next person says, not gonna lie, I thought somebody came to reply and I felt comforted for a second, but it's just that fucking rabbi bot, and I'm so pissed. And I actually went to that person and I was like, come to my Discord, I'll comfort you, like, I'll talk with you. But they did not. I get people in all kinds of other languages, so I have to translate what they say. I'm not gonna do it right now. Somebody's like, but I've never condoned or supported wishing death upon someone before, but the Rabbi Rothschild bots are my only exceptions. Yo, pal, Rabbi Rothschild, I hope you die. Now, these are very negative, but you watch. If I do this for another month, they'll be like, "Where were you?" They'll be like, "It's just how human nature is." It's Rabbi Rothschild season. It's like cicada season, but worse. So they wrote that yesterday. So all of these have taken place in the last 24 hours. So that's a lot of like random influence that I'm getting from random people. Okay, it's especially fucked since exactly they hate me because they ain't me, baby. Um, yeah. So there's exactly. There's a very famous quote from P.T. Barnum, the guy who did the circuses, and it's essentially there's no such thing as bad publicity. So yeah, all of these are just all everything that I just told you has taken place in the last 24 hours, and that's people who say the full phrase Rabbi Rothschild. If I just go to Rabbi, there are a ton of people who like just comment about me, and then there are people who I don't want to say I never see, but like I very rarely see because they don't mention my name, and so I'll just randomly find them. I'll like do a keyword search and I'll just write like spam bot or um, Drake meme because the meme that I use is that Drake meme, and I don't. Well, when it comes to celebrities, I do my best to separate the art from the artist. It's what allows me to like Michael Jackson and the Cosby Show, but and other things too. But I don't condone their actions. I don't condone Drake's actions. I don't even want to use the meme that I use of his. However, when I use other people's memes, they automatically get banned. So I've had to play this cat and mouse game with um he he's Yeah, I mean, not really that, but he's been accused of grooming people, including Bobby Brown. Um, so I mean, I don't. Yeah, I don't know what he did or not, but I do get people who are like, "Why are you using this pedophiles meme or whatever?" And I don't want to. In fact, I've made other memes. I made one yesterday. You know that one of the most interesting man in the world, that Dos Equis guy? I don't know if you know who. Okay, yeah. So that one, I made one for that one, and immediately when I posted it, my account got taken down immediately. So they've got so it's had I've had to like study like what is it that allows me to post some things and not others. Basically, they have a thing that reads alt text. If you don't know what alt text is, it allows people who are blind or use screen readers to be able. It describes what a picture is to them, and a lot of times people don't want to type it out because they just want to upload whatever they want to upload. So they use companies use AI to create text. And so like let's say it's a picture of a dog, it'll be like a picture of a dog in the grass on a sunny day. And then when people are using screen readers or they're blind, it gives them a description of what it is. Well, when I type the phrase Rabbi Rothschild, it recognizes that in the picture, and a lot of times that gets taken down. And I've tried all different kinds of combinations. I've tried different memes, and the reason why I use memes is because, and I think I said this, but it's really brilliant, so I'm going to repeat it. Um, when I use my own pictures, they get taken down right away. But if I use a meme, they can't take that down because it's used very often on their website. And so they can't always take it down. It has to be manually taken down, which means that I'll get out 150 spams on their website before it gets taken down. And I looked up other memes to use, and I like this one because it's orange, which catches your eye. It's like bright. Um, and I'm able to say like it gets your attention. The poop emoji says whatever the fuck you're doing right now, and that's where Drake's like, no, don't come near me. And then it's like my list of stuff to do, and then he's like pointing at like, yeah, that's um, yeah. So the one thing I wish is I got more people in. And so when I was first uploading it, it's a lot of text and it was blur. It wasn't like super blurry, but the more and more I copied and pasted and everything, it got blurry. So I redid it yesterday and made it easier to read. People, I'm sure you know this, but white lettering with a black background can be read on. So I used that, and or it can be read on any picture. That's why it's used for me. And but I'm not getting people in here. And the reason why, well, complicated. People are doing their own thing with their lives, but people think it's a scam, and I get that because I don't use a direct link to Discord. If I don't have like, you have to have like a boosted Discord account, and I don't want to pay to have to do that. Um, to be able to get discord.gg/rabbi. So what I have is discord.me/rabbi, which is the same amount of characters. It just takes you to one website. You have to do like a captcha, and then it takes you in here. And but I get how people think I'm trying to scam them. At the words I end with are share to be a trillionaire. Like, okay, well, who's gonna really do that? I mean, I say in there, data is Earth's number one resource. My thing says, I have it right here. It says, um, saying hi to Rabbi Rothschild in Discord. This is where Drake is like pointing like this. Looking at all of Rabbi Rothschild's social media accounts, linktree.com/Rabbi Rothschild. Typing Rabbi Rothschild in YouTube and filtering by live, more than 18 simultaneous live streams. Reading Rabbi's AMA, RabbiRothschild.blogspot.com, perhaps the largest blog entry in global history. Topics, extinction, life extension, cybernetics, alien disclosure, mind uploading, and much more. Learning Rabbi has been live 24/7. Rabbi for 3+ years for repeat. Realizing Rabbi is a real life Truman Show. Knowing Rabbi has more data archived on the internet than any person ever. Acknowledging human data is Earth's #1 resource, according to The Economist in 2018. Understanding Rabbi will make you rich once viral. Sharing to be a trillionaire. So I get it. Like, everybody's trying to scam everybody. So I absolutely get that people think that it's a scam. I have gotten one person in here.
How are you gonna make everybody a trillion?
Well, so here's the funny thing about that. I could easily make people trillionaires. People make assumptions. For instance, the Zimbabwe dollar in the year 2008 was their currency was worthless. They had a $100 trillion bank note that was worth less than a penny. And so all I'd have to do is just give a person one of those, and that makes them a trillion. People are thinking this is a trillionaire in terms of United States dollars, which I want it to be. And with enough data, I think I can do that. People don't understand that inflation is a thing. And when I was a kid, everybody wanted to be a millionaire. Now people want to be billionaires. In a generation, people will want to be trillionaires. It's just I'm just ahead of the curve. And
Wow, that is very hard. Wow, that's very
there you go. We'll leave it at that.
Know the coordinate. We know shooting out of we have column through row 20. That's reference frame in the brain. We know this. I've been established neuroscience studying not own neuroscience. Part of the way these cells create reference frames, they have no orange. So what it's more like have a point and given a particular movement, then tell what the next point should be. And you can what the next point is, so on. To calculate how to get from one point to another. How do I get from home? Or how do I get my how do I get the action to the architecture? So it's a different type of reference frame, and I get more like describe more detail. I can paint a picture of how you might want to think about it. Really helpful. But is it helpful to think of it as or is it something? No, it's definitely spatial. It's spatial and I'll make a mathematical. How many dimensions? Can it be crazy number? Well, that's an interesting question. The old part of the brain, the entorhinal cortex, they studied rats. And initially it looks like, oh, this is two-dimensional. It's like the rat is some box, maze, or whatever, and they know where the rat is using this two-dimensional reference frame to know where it is. Okay, well, what about bats? That's a mammal, and they fly in three-dimensional space. How do they do that? They seem to know where they are, right? So this is the current area of active research. Like somehow the rest of the neurons in the cortex three-dimensional space. Just numbers of RT on bioarchive, where they show that and the way these work, I won't get to this want to, I won't get to this, but grid cells represent any n dimension. It's not inherently limited. Think of it this way: you have two-dimensional. The way it works is you have two-dimensional slices. The way these things work is a bunch of two-dimensional models, and you can slice up any n-dimensional space with two-dimensional projection. So, and you can have one-dimensional models. There's nothing inherent about the mathematics about the way the training dimensionality. Training was important. So obviously, I have a three-dimensional map of this stuff. Maybe even more than that. I don't know. But really three-dimensional stuff. I don't. But when I think about birds or when I think about mathematics, I have to.
terms of individual column building out more information all the time, I think that mechanism is well understood. In your mind, a lot of architecture. That's a piece of it. It's a big piece of thousand brain theory of intelligence ensemble.
I think they're both big. One of the concepts in theory, right? The high level concept rather than this work. So that is a thing and has all these ramifications. And with that as a framework for how the brain works, make all kinds of predictions of what can come. We're trying to work with training these children. Okay, how do we know this? You think about big cells, clay cells, whole parts. There's a lot to think about. It's just a mystery. A lot of debate about exactly the details, how they work and so on. Yeah, that's cool, that same level of detail, that same level of concern. But we spend here most of our time trying to make a very good list of things for understanding. That's the key part. What is the key? It's like, oh, this works, we're done. I was like, okay, it kind of works, but there are other things you know it has to do. It's not doing those things. I would say we're well over the way here. We're not a lot of trickiness to the system, but basic principles about how different layers in the neocortex are doing much of this we understand. But there's the parts that we don't understand.
The loop is one of the harder of the problems, the ones that keeping up at night.
Oh, well, right now, this thing, this slide of most people.
Yeah, please.
Talked about, predict what you're going to send from the Celtic cup. I need to know where my that is true, but it's insufficient. Think about my fingertips at the edge of the Celtic cup. I think that such an orientation, rotate around here. And that doesn't change. I can make that prediction somehow. So it's not just the orientation component of it. Zone in the old parts of the brain, that direction, where the rat is facing. If I think we're a rat, in dimensions, I have a dimension orientation, and I have a three-dimensional location. As a rat, I would have I think three-dimensional location, one-dimensional. So how will the two components work together? How is it I combine orientation my sensor, as well as the location, is a tricky problem. And I think I've made progress on it.
So, at a bigger version of that perspective, super interesting, but super specific.
Yeah, you get it, right?
It's really good, but there's a more general version of that. I think context matters. The fact that we are living in North America, that we day and age when we have mugs. I mean, there's all this extra information table about everything else in the room that's outside of
yeah. So that is another really interesting. I'm going to throw that under the rubric name of attentional problem. We have this model. I have many models.
And also the question because
it matters for certain things, but of course it does. Maybe what we think of that as a concept in another part of the world. Maybe our logo would be very defined in this part of the world that means something very different in another part of the world. So those things matter. The way to think about it is the following. One way to think about it. We have all these models. And we model everything. And as I said earlier, our models are actually structure. So every object goes with other objects, other objects. They become members of other objects. So this chairs, the table, the room, the walls, and so on. Now we can arrange them in a different way and go, oh, that's the dimension of confidence. So, and when we go around the world, the world, I walk into the room. First thing I do is like say, oh, I'm in the room. Start looking at the room. Then I can say, oh, look, there's a table here. And I'm by the table, and then assign the table in the context of the room. Like, on the table. Oh, and on the table, there's a logo. And in the logo, there's the word. And the logo, by the key, I'm looking on your zero. deep down. I can pop back up and I can pop back down. I can pop back up and I can pop back down. So when I attend the coffee cup, I haven't lost the of everything else, but the nested structure.
So there's the reference frame that particular period of time.
Yeah, basically, moment to moment, you send the subcomponents, then you can send the subcomponents.
You can move up and down.
You can move up and down. And we do that all the time. You're not even, now that I'm aware of it, I'm very confident. Most people just don't even think about this. You know, you're in a fucking room and you don't say, oh, I looked at the chair and I looked at the board and I looked at that word on the board and then here, what's going on? Right?
What percent of your day are you aware of this part you actually relax?
Yeah. Like my personal day. Unfortunately, I'm afflicted too much of the former. I think, yeah.
You don't think it's you?
Oh, I did. Totally. I think about this stuff almost all the time. And I'm at, one of my primary ways of thinking is when I'm at midnight, I always wake up in the middle of the night. And then I stay awake for at least an hour with my eyes shut in sort of a half state thinking about these things. I come up with answers very often in that sort of state. On my bike ride, I walk, I just constantly think about this. I have to almost schedule time to not think about this stuff. It's very,
Are you when you think about this stuff effectively, like almost taking a step outside of yourself and trying to figure out what
that all the time, but that's not all I do. I'm constantly observing myself. So I started thinking about grid cells, for example, getting into that. I started saying, oh, well, grid cells have nice places where you are. And it's interesting, you know, we always have a sense of where we are in the law. So I started, I got up to go to the bathroom. I would start trying to do something with my eyes closed, and I would test my sense of grid cells. I would watch 5 feet and say, okay, I think I'm here. Can I really? What's my error? And I would calculate my error again, and how the error is like so. Something as simple as getting up and go to the bathroom. I have to be serious about a fun, and the coffee cup is an example of that too. So I think I find that these sort of everyday actually helps. It doesn't ignore the fun. I mean, I spend every day reading ridiculously complex things. That's not nearly as much fun, but you have to build up those strengths, knowledge about the field and who's doing what exactly they think is fitting here, and then you get back to try to piece it all together. Come up with something, you know, I'm very, in this group, people, I do this all the time. And perspective, well, we ever thought about this? Now what? We'll do this. And it's, well, it's not, all you did was that then you make stuff, right? But if you're training it, the reality is not nerve.
So let's talk a little bit about learning and the success slides of that idea model data and artificial neurons that with back propagation ways generalize from the data that so where do you think are the limitations strengths relative to major effort constructing a theory of human intelligence?
Yeah. Well, I'm not an expert. I'm somewhat knowledgeable. So, but
some of it is your intuition. What are your
well, I have a bit more than intuition, but I just want to say, like, one of the things do I spend all my time on neuroscience I do, that's the exclusion of things like composition. I don't try to. Look, I think it's great. It's fantastic, and as I mentioned earlier, it's very highly thing. The models we have today are actually derived from a lot of neuroscience. They're distributed memory, how the brain works. They use things that we might call them neurons. So they're not really distributed. And the nature of hierarchy that came from neuroscience. A lot of things, the learning rules, basically, not that stuff, but other things.
I'd be curious to say neurons at all. Can you describe in which way? I mean, some of it's obvious, but I'd be curious ways in which you think are biggest difference.
Yeah, we had a paper in 2016 called Why Not Without, and read that paper, you'll know what I'm talking about here. A real neuron in the brain, cut like that. And let's just start with the synapse, which is the connection between them. Real neurons everywhere from 5 to 30. Um, Ones near the cell body, the cell body, those are like the ones that people model in. Under those, they can cut the cell, they can 95% of synapses can do that. Away. Active the cell body enough to or even what real neurons do is the following. You activate, you know, 20 of them, activate all these things at the same time. And those 10 to 20 synapses within a very short dendron, 40 microns, activate a bunch of right next to each other to place. What happens is it creates what's called a dendritic. And the dendritic spike travels through the dendron and creates chroma of the cell body. Now, when it gets there, it voltage, so like trying to make the cell fire, but never enough to make the cell fire. So what we call it is polarize the cell, raise it a little bit, but not enough to do anything. Like, well, what good is that? And then it goes back down. So, we proposed a theory, which I'm very confident that what's happening there is 90% of the synapses are recognizing hundreds of these, you know, synapses at a time, and they're acting like neuron actually on its own. It can fire when it gets enough what we call proximate signals. Once it's ready to fire from dozens, hundreds of patterns that are recognized. And the advantage of the neuron is that when it actually does those, then it would bubble up. And so what could this do? Well, the slightly part is all the neurons, the auditory neurons are surrounded by these very fast. And if I get my spike out with someone else, I inhibit all my neighbors, right? You end up with different representation. You end up with representation that matches. It's a sparser representation, meaning first, interactive, much more specific. And summarize it. The neurons in the brain are time-based prediction, and there's no concept of artificial neurons. I don't think you can tell the brain without a large part of the time comes from time is the prior in a a prediction, and it's not very well. But like for example, synapses are very unreliable. You cannot find any. So even when the way real neurons work, they don't break after like that. They basically form a synapse. So we try to always check the presence of some 10 to 20 active synapses at the same time, as opposed, and they're almost like, it's like, it really represent anything behind. So this kind of, and I think that's actually another essential component, because the brain works on sparse patterns, and all that mechanism is based on patterns, and I don't actually build real brain or cells without incorporating them.
It's hard to even think about the complexity of the fact that timing and firing matters in the brain, the fact that you form new synapses. I mean, everything you just mentioned.
Nothing timeline beats timeline. It's not like it's no longer a mystery.
No, but so sorry. In a mathematical way, can you get us getting into about what gets decided and what not, and what kind of representation?
It's not as easy as there are many other types of neural networks that are amenable to pure analysis. Especially very simple. I have 4 neurons and they're doing this. Can you describe them mathematically what they're doing? convolutional networks today is sort of they can't really describe the whole thing. And so it's different. My colleague Ahmad did a nice paper on did all this about little mathematical what we can do so mathematically why 10 to 20 synapses working on a pattern, correct number, the right number you want. By the way, that's biology. So mathematically, some of these concepts about to show why brain is so robust, noise, error, and so on. So that mathematically as well as your calculation. But the system can be analyzed any complex that's not out of the realm. But there's mathematical benefits and intuitions that can be derived from most of our papers have a section.
So I think it's refreshing, useful with talking to you about networks. Their intuition basically that can't.
Well, not in their current form.
Not in the current form.
No, in the ultimate form, sure.
So let me dig into it and see what your thoughts are there a little bit. So I'm not sure if you read the blog post through it, but I read thoughts recently. Learning pioneer. The idea is that stuff was done in AI in the past 70 years. One of the old school guys. The big lesson learned that all the tricky things done don't, they benefit in the short term, but in the long term, without general method as applies on computation.
Has worked up.
Has worked up to now. Yeah. If you're trying to build a system, you're talking about works in terms of prediction. That you just try to go as general as possible and wait years or decades for the computation to actually.
Do you think that is a criticism, or is he saying this is a description of what we ought to do?
Well, it's very different. He's saying work and prescription, but the difficult prescription says all the fun things you guys are trying to do, we are trying to do part of it. Saying only going to. This all leads up to a question, I guess, on artificial networks and maybe our own biological networks is you think if scale some significant would take these dumb artificial neurons, the point I like that if we just have a lot more of them, you think some of the elements that we see in the brain may start emerging?
No, I don't. Bigger problems and of the same type. I mean, pointed out by many people that today's convolutional networks aren't really much different than the one a while ago. We just the bigger and more, more stable and so on. But I don't think you can get to the kind of things I know the brain can do and that we can do as intelligence by just so it may be it's a good description of what happened in the past, what's happened recently, with the reemergence of artificial neural networks. It may be good for what's going to happen in the short term, but I don't think that's the path. That earlier, there's no alternate path. I should mention, by the way, that we made progress on the whole cortical theory in the last year. Last year, we decided that we're actively how do we get these ideas embedded in learning. How that's led by myself and more machine. So now I wouldn't say our focus, but it is now in because we need to proselytize what we've learned, and we need to show how it's beneficial to the earlier. So we're planning for that now. In fact, you just first paper on this. I'll tell you about that. One of the I'm trying to machine learning let's say, I need to learn about this stuff, and maybe we should think about what stuff and what have they done.
Yeah, so there are elements of all the work that we're talking about that make
Yeah, short term. Yeah.
sorry to interrupt, but the open question is, feels from my perspective that in the long term, that is about question is
They always what I would call the entrepreneur dilemma. So you have this long-term vision. We're going to all be driving electric cars, or we're all going to be teachers, or we're all going to whatever. And you're at some point, I agree with that. I can see that long-term vision. I'm sure it's going to happen. How do we get there without killing yourself? Without get a business. So we're facing. So ideally, what you want to find some steps along the way. You don't have to like over. The first thing that we've done is focus on these sparse structures. So just don't know what that means. In the brain, if I have like 10,000 neurons, what you see is kind of max everything. You don't see 50%, 30%, and always one.
or any sensory.
It doesn't matter any part of the brain.
But which neurons are active?
Yeah, so let me put this. Let's say I get 10,000 neurons that are representing neurons. They're representing communication, they're representing your thoughts, they're representing the input from the senses. I don't, it doesn't matter. Representing. The way the representation occur is large representation. It's a population code. So each 100 cells are active tells me what's going on. Not individual cells aren't important at all. It's the population code that matters. And when you have sparse population codes, then all kinds of physical properties matter. The brain uses sparse population codes, at least written and described the benefits of a brain. So they give us tremendous robustity. The brains are incredibly robust. Neurons are dying all the time, spasming, and synapses falling apart, and that's all the. So what Sibatai and Louise, one of our other engineers here, have done, found they're introducing sparseness. People think they're like fine, but we're going into that in a way. And we're doing that with more sparseness throughout convolutional networks, both the active systems, so with neurons are active, that you get some very desirable properties. The current hot topics in deep learning right now are these adversarial examples. So, any deep learning network, I can give you a picture that looks perfect, and you're going to call it, you're going to say the monkey is that's the problem. Dark just announced something we're trying to process it. But if you import sparse representations, many of these problems go away. They're much more robust, and it's not easy to fool. So we've already shown some of those in January last month. And I think it's on bioarchive right now. But so that's like a good baby. Okay, some of the brain, we know about sparseness, we know what it is in the brain. So let's force that on.
Situation why sparsity feels like it would be less robust.
Why would you do less robust?
So it feels like as the fewer neurons involved, the more fragile the representation.
Yeah, but I didn't say there was lots of few. I said just like 200. That's a lot.
Still a lot.
Yes, it is. Here's the situation for it. This is technical, so but if you're trying to classify something, you're trying to devise some very high dimensional space. And trying to create where you go all these high dimensional space are A and all these high dimensional B. And if you have points that are close to that line, after first all the points you know about, after a little bit, you can cross over. When you have sparse representation, imagine I have 200 cells active out of 10. So I have 200 cells active. Now let's say I pick randomly a different overlap between those is going to be very small. I can pick millions of samples randomly of 200 neurons. Not one of them will overact more than just a few. So one way to think about it is if I want to pull one of these representations to look like one of those other representations, I can't move one cell, or 2 cells, or 3 cells, or 4 cells. I have to move 100. And that is robust.
In terms of there's sparsity.
Well, maybe the next thing. Okay, so we have 6 lines. Don't know if it's yeah, we're trying to come up with incremental ways. Brain theory, add pieces learning involved in one step at a time. So the next thing we're going to try to do is sort of incorporate some of the ideas of the thousand brain theory that many models and that are both. Now that idea is not new. The mixture models have been around for a long time. But the way the brain does it is different. And the way it goes is different. Kind of the way it represents the protein is different. So just starting this, but we're going to try to incorporate voting for 1,000 brain theory. So like lots of simple models that talk to each other in a very certain way. And can we build more that learn faster and also, well, mostly are modal and robust to multiple applications.
Challenge there is the machine learning computer vision community has certain benchmarks. And I would argue benchmarks have been for testing the aspect of the brain good at or intelligent. Not really testing intelligence, very fine.
Yeah.
And it's been extremely useful for developing mathematical models, but it's not useful in the long term for creating intelligence.
Yeah.
Do you think you also have a role in better tests?
Yeah, it's very, you identify the very specific problem. First of all, the tests that they have are the tests that they want, not the tests of the other things that we're trying to do, right? You know, what are the so on. Second thing is sometimes competitive to things. You have to have huge power. We don't have that here. We don't have power of the big companies. So there's numerous issues. So we come at it, our approach is all based on argue elegance. We're coming at it from like medical data that we take a look at the brains for what's helping. People deciding the things that they think it doesn't matter. What you think you do, 0.1% better on this part, that's all that matters. And that's the problem. We have to figure out how to get around that. That's a challenge for us. That's one of the challenges to deal with. So I agree, identify a big issue, it's difficult, for reasons. But, part of the reason I'm talking to you today is I hopefully get people to say, read those papers. I did. I'm tired of this 0.1% improvement stuff,
Well, that's why I'm here as well, because I think now is the next orthogonal.
You're saying that learning, with this capsule fight. Many people have gotten up saying, we're going to hit roads and map roads, but maybe we should look at the brain, like that. So hopefully that thinking will occur organically, and then we're in a nice position for people to come look at our work and say, wow,
yeah, I might be launching a $1 million computing college.
This idea of what?
Well, the idea that humanity, psychology, neuroscience, that's what we're called. Yeah.
And I think different.
Yeah.
I'm a little disappointed in this issue. They're focusing on the human side of it. It's very easy to how humans interact with cell that is orthogonal to what we're trying to do. We're trying to say, like, what is the essence of intelligence? I don't care. I want to build intelligent machines that aren't emotional, that don't smile at you, that, that aren't trying to touch you in the eyes.
There is that pattern that when you talk about understanding intelligence, starts looking at the more, yeah, these like interactive elements. To, I don't know, but just on the brain, study what the brain, the baby,
let's study what a brain does. Then we can decide which parts of that we want to recreate in some system. But if we figure out how that does what the brain does, what's the you're going to be
break it down on the artificial unknown side, maybe the biological thing outside learning versus different. Maybe you can explain to me what is there in artificial neural network different learning stage and brain is different. One of the big people they don't know how correct it is. Artificial neural network a lot of data, very inefficient learning. Do you see that correct in the biological brain? The brain is very efficient, or is that
no, it is. I was speaking
element?
I can talk about that. You brought up so remember I talked earlier about the constraints. We always one of those constraints, the fact that brains are continually learning. That's not something we said, oh, we should add that later. That's something that was upfront, had to be there to start. Process harder. But we showed, going back to the paper on memory, we showed how that happens, how the brains infer and learn at the same time. And our model, and they're not two separate phases, or two separate steps at the time. I think that's a big, big problem in AI, at least for many applications. Not so I can talk about that. There are some parts of the neocortex in the brain where actually what's going on, there's these cycles, cycles of activity in the brain, and there's very strong evidence that you do more of inference on one part of the phase and more of on the other part of the phase, so the brain can have relationship going back and forth. But in general, I would say that's an important problem with all of our networks come up with people. They're learning, continuous learning networks. And you mentioned benchmarks. Well, there are no benchmarks about that. So we have to like begin our little box. And hey, by the way, it's important. Mechanisms for doing that, but you can prove it to someone in some commercial system.
So yeah, one of the things I on that is in some ways to learn the concept of coffee cup. This one coffee cup, maybe some time alone.
Well, the first thing is, sometimes I reach my hand into the black box and I'm trying to. I don't know up front if it's something I already know, and I have to. I'm doing both at the same time. I don't say, oh, let's see if it's this thing. Oh, let's see if it's the wrong thing. I don't do that. As I go, my brain says, oh, it's new or it's not. And if it's new, I start learning what it is. So, and by the way, you're supposed to learn it from the get-go. You're going to recognize it. So they're not separate problems. So that's the other thing you mentioned was the fast learning. So I was just about to continue, but there's literally, I can show you this coffee cup, and I say, here's a new coffee cup. It's got the logo on it. Look at it. It's done. It's done. Think what it's going to look like. So I can talk about that. In the brain, the way learning occurs, I mentioned this earlier, but I mentioned the way learning occurs, imagine I am a section of a dendrite of a neuron. And I want to learn, I'm going to learn something. It doesn't matter what, I'm just going to learn something. I need to recognize you. What I'm going to do is I'm going to form this, rewire the brain onto that section of the dendrite. Once I've done that, and put the neuron in this one section. That's because not all been added together. Like I learned something on this to learn something else. So I can add something without affecting yourself. I can do quickly. Now let's look at mine. One semester, yes, maybe forming. More memory is bigger than that. I can explain that now, if you want. But it's getting a bit neuroscientific.
That's great, but is there an understanding of these methods at every level?
Yeah.
So from the memories and the forming.
Well, so the idea of pathogenesis, growth, and that's well described, is well understood. That is learning. Okay. So back, going back many years, people, was what's his name, the psychologist proposed, Donald Kemp, proposed that learning was the modification of the strength of the connection between two neurons. People interpreted that as the modification of the strength of the synapse. He just said there's a modification of the effect of one neuron on another. Pathogenesis is totally what Donald Kemp said. But anyway, there's mechanisms. The growth of the synapse. You can go online, you can watch it growing. It's literally, it's a little, it's pretty impressive. But those mechanisms. There's another thing that we speculated and we've written about, which is still known neuroscience, but less proven. And this is the idea: how do I form a really quick, like instantaneous? It could take an hour to grow a synapse, like that's not instant. So there are types of synapses called silent synapses. They look like a synapse, but they don't do it. They're just sitting there. Like if a fraction, it doesn't nourish. Some parts of the brain have more of these others. For example, hippocampus has a lot of them. Pre-associated memory. So what we speculated again in that 2006 was that way we form very quick memory, very short-term memory, or quick memory, that we convert silent. It's a thing, a synapse that's weight one, but the long-term memory has to be formed by synapse. You can remember something really quickly by just looking at guys silent to active. It's not not from 1 to 0.15. It's like doesn't do anything. Remember the thing. If I do that over a bunch, I've got a very quick short-term memory. So I guess the lesson behind this is most neural networks are open. Every neuron connects to every other neuron from layer to layer. That's not correct. In the brain, you don't want that. Actually, you don't want that. Yeah. You want a very sparse connectivity so that any neuron connects to some subset of the neuron, and it does so on a dendrite by dendrite segmentation. So it's a very parcellated output, and that then learning is not adjusting all the ways, but learning is just saying, okay, connect this cells here.
And that process, with artificial neural networks, very simple process, that propagation, that adjusts the process of math,
Even easier. That propagation requires really can't happen. Back propagation versus really can't. This is pure head learning. Basic population cells over here that are active right now. There's a population here active right now. How do I form connections? And it's literally saying this guy became active. This 100 neurons here became active. So form connections. No propagation there. Nothing. All the networks we do, all the models we have, will almost completely on heavier learning, but on dendrite segments and mobile segments.
Now let's return the question you already answered. This is artificial intelligence. Where do you think we stand? How far are we from solving intelligence? Said you were very optimistic.
Yeah.
Can you elaborate on that?
Yeah, it's just always the crazy question. No one. So I'll tell you a story. I used to run a different neuroscience called the Resident Neuroscience. We would pose it to get like 35 scientists around the world together. And I used to ask them questions. How long before we have the neurocortex? And everyone went around and they introduced the name and they have to answer that question. I got the typical answer was 1,500 years, 500 years. Some people said never. I said, what are you saying? Okay. So, but it doesn't work like that. As I mentioned earlier, it's not a function. It happened and then bingo, it happened. I know I've already passed that stuff on. I can do my job correctly over then meaning I can classify the idea. I can other people, we that other people, learning people should pay attention. Then we're definitely in an under 20-year time. So I can do those. If I'm not successful, and this is the last time anyone talks to me, and no one reads our papers, and and I'm wrong or something like that, then I don't know. But it's not. It's it'll you got electric cars. How are they going to operate the roll? Let's talk about a 20-year span. It'll be something like that. But I think if I could, what I said, we're starting.
And of course, other function. Everybody gives up on your ideas 20 years, and all of a sudden picks it up again. That guy was on this.
Yeah, so that would be failure on my right? Think about Charles Babbage. Charles Babbage, he invented the computer back in the 18th. And everyone forgot about it until 100 years later. Oh, not a long time ago. But he was ahead of his time. I don't think, as I said, I recognize any entrepreneur's challenge. I use entrepreneur broadly. Like I'm building myself, I'm trying to sell ideas. And this is the challenge is how you get people, how do you get them to positive, negative feedback. So, how are we doing that?
So, there's a lot of hype behind artificial intelligence currently. As spread is of theory, the things you put on, think that the possibility AI once again.
Yeah, it's certainly a possibility. No question about it.
Worry about it.
Yeah, well, I guess do I worry about it? I haven't decided yet if that's good or bad.
That's true.
Yeah.
Very true, because the wood church fresh the palate.
Yeah, it's like here's what you want to have is you want like that everyone's so thrilled about the current state of AI and they don't imagine they need anything else that makes my job hard. Right. If everything crashed completely and every left the world and there was nobody for anybody to do anything and it became an embarrassment to talk about machine intelligence and AI, that would be something different. You want sort of the soft landing approach, right? You want less people, the senior people in AI and say, we need other approaches. There really need other approaches. Yeah, we need other approaches. Maybe we should look at the brain. Oh, okay, let's look at the brain. Let's test the brain idea. Okay, let's start with a project on the side here, trying to the brain idea for this stuff. That's the ideal outcome we would want. I don't want to overweight them, and yet I don't want to study all of them.
I think it takes to build a level of intelligence where one's demonstrated trust. So it doesn't have to have a body, have to have the security or consciousness as an entirety.
First of all, I don't think the goal is to create a human level. I think it's a false goal. It's back to Turing. I think understand our intelligence, and we can build intelligent machines of all different capabilities. Adult intelligence. That'd be pretty good to have a doctor. What about something that doesn't look like my about this is that modern intelligence agree upon based on intelligence. Then say, okay, now we're going to work on those principles, and we talk to all different types of problems. And the idea, we don't ask, I take a little, I don't say, well, that's not a powerful, over here. Fine, I can apply those principles. No problem, no big problem. Saying, how does this get there? We have to say, principles, I can make a small one, make it understand like, well, you bring up a very good question about embodiment of our body. It has to have some concept. It has to be able to move reference like that earlier. Moving, like I need if I'm going to have an AI that understands coffee cups, it's gonna have to pick up the coffee cup, touch it, guys. If I have a mathematical AI, maybe use those mathematical space. I could have a virtual AI that that first thing into files, but it's got a location that is traveling some state. You have an AI that just takes some flash thing, and we call it flashing. Pattern. No, movement, pattern. Building structure, trying to figure out the model of the world. Some sort of embodiment, whether it's physical or not, has to be part of it.
The self-awareness way to be able to ask where am I?
I'm bringing up self-awareness and talking about self-awareness.
Well, very narrow definition of me knowing a sense of self, not knowing where am I in the space.
Yeah. Basically, the system, its location, what component, where it is in the world at that point.
So, self-awareness, consciousness. I think one from the perspective of neuroscience, topic, solvable topic, any ideas of why the heck is at all?
Yeah, I have a lot of
is it useful? Side effects of us.
To think about, I don't think as a need to figure out how to build it. It's that this is about whatever that. Well, if I build like this, then it would be self-aware. Or then if I build it like self-aware, so that's a choice I can have. It's not like, oh my God, it's self-aware. I can't certainly. Well, I heard in interviews, I can't remember. But he was well, if it's self-aware, then it would be a crime to unplug them. I employ myself every night. I go to sleep when you I employ myself in again in the morning after only after. I have very definite skills, understanding, or opinions about what it is. It's not just self-aware. I don't think it's that you brought the crystal question. He thinks that's only. I actually live here, but I know him. I know that's the thing.
What is the other intelligence question?
I don't know.
So
I just.
Where's your thought process from?
We have to break it down to okay. One thing, that's part of the problem. People own it. There is a concept of awareness. Okay? That very easily have a model of your own body. Cortex models of the world, and it also models your own body. And then it has a memory. It can remember what you've done. Okay, so it can remember what you did this morning, it can remember what you did for breakfast, and so on. But I can say to you, okay, Lex, were you conscious this morning when you had your bagel? Yes, I was conscious. Now, what if I could take your brain and revert all the synapses back to the state? And then I said to you, Lex, were you conscious when you ate the bagel? No, I wasn't. I said, video bagel. I wasn't there. That's not possible. I must have been unconscious at that time. So we can make this one-to-one correlation memory of your body trajectory of the world over some period of time. A memory that, and the ability to call that memory what you would call consciousness. Conscious of that, self-awareness. And any call, memorize what it's done recently, bring that back, poke it again. Say, yeah, I'm aware. I remember what I did. All right? Got it. I think, although some people are more challenging part of consciousness, one that sometimes you go by the word qualia, which is, why is it not right? Or what is it? I just people like that. Why do I feel redness? Why do I feel why? Then I can say, well, why is light same problem? all just neurons. So that why does hearing is different, but neurons in my head, they're all doing the same things. So that's an interesting question. The treatise I read about this by a guy named Reagan, a book called Why Red Doesn't Sound Like a Bell. It's not for you, but and interesting question. Take something like color. Color really doesn't exist in the world. It's not a property of the world. Property of the world that exists is light, and that gets turned into cells in the retina that respond to and others. When they enter the brain, you have a bunch of axons wiring into the brain, and from that we produce color. There is no color in it. There's no color coming in about synapses, correlation, some axons and some property of frequency. And that isn't even color itself. Frequency doesn't have a color. It's just what it is. So then the question is, well, why does it have a color at all?
Just as you're describing it, it feels like conscious having to assigning red the actual color or to the wavelength is useful for telling.
Yeah, I think that's a good way of putting it. It's like a predictive mechanism or as a visualization idea. It's the way of grouping things together to say it's useful to have a model. Think about the well-known the loss of the limb, for example, and what they claim is they can have their arm is removed, but they feel their arm. They not only feel it, they know it's there. It's there. I can know it's there. Just where do you know it's there? And then they can put it in their arm. And so standing their finger, you move their bionic arm behind your back, behind your back. So the whole idea that your arm is this is a model of your brain. It may or may not really. And just like, but it's useful to have a model of something that sort of correlates things in the world so you can make predictions about what would happen when those things occur. It's a little bit funny, but I think it's right necessary. It's useful to a model of expressing certain ways that we can then map them to reference frames and make predictions about it. I need to spend more time on this topic. It doesn't bother me.
I really need to spend more time.
Yeah, no,
it does feel special that we have such an experience, but I'm yet to know why.
I'm just personally curious. It's not necessary for the work we're doing. I don't think I need to solve that problem to build intelligent machines at all. Not at all.
But there is the feeling of drive that doesn't, if you're successful building intelligent machines, it feels wrong to then turn them off. Because if you're able to build a lot of them, it feels wrong to then be able to, to turn off the.
Oh, why? Let's break this down a bit. As you, why do we forget? There's two reasons we forget. Well, first of all, I'll say when you're dead, it doesn't matter. Oh, so why do we forget? For two reasons. One is because we are programmed genetically. That's a survival and propagating thing. And we also are programmed to feel sad when people know. You don't feel sad for someone you don't know dies. I know something I'm dead enough. I don't know. But if I knew them, I'd feel really bad. So again, there's whole brain genetically embedded things that we hear about. Outside of those uncomfortable feelings, nothing else to worry about.
Wait, hold on. The denial of death by Becker and there's a thought that death is, our whole conception, our world model, kind of assumes mortality, and then death is terror that underlies it all. So,
well, some people, not mine.
But okay, so what Becker would say that you're just terrible terror. The illusion that you not come to grips with
what?
Okay.
You're
actually operating. You haven't
sounds like
Yeah, totally. Literally, every night I go to bed, it's like dying. It's one of us. And if I didn't wake up, it wouldn't matter to me. Only if I knew that was regardless. If I didn't know it was going to happen, how do I know? Then I would wake up my life. So imagine I was alone, right? And I lived out there, and no animals, nobody in my and nobody was there. And one day I didn't wake up. What in the world would there?
Most people think about this problem say that like or but I would say that's very and is that rational. But the fact is, I mean, we really don't have an understanding of why the heck it is we're born and why we die and what happens after.
Well, maybe there isn't a reason. So I'm in a big problem, right? You know, you've been in that park, you know, there's people like that, right? I'm into those big problems. And back when I was young, I made a list of the biggest problems I could think of. First, why does anything exist? Second, why do we have the problems that we have? Third, is life inevitable? And why is it here? Fourth, intelligence. I stopped there. So I figured you can make truly intelligent. That would be the quickest way to answer the first big question. I'm serious.
Yeah.
And so I said, my mission, you know, you asked me, my first mission is to understand the brain, but I felt that is important to get intelligent. I want to get this because even if it doesn't occur in my lifetime, it will benefit. Because I think it's and but that would be the quickest way for us. You know, we can make mathematicians make and make brain, and they can run experiments. Run. We don't have the ability to do it. Build and finding out the answers to the question.
Let me ask you an interesting, different question. Once you achieve that of creating, no, understanding, happy,
Understanding intelligence or understanding the answers to the big questions?
Oh,
Totally. Totally. It's a far more fun place to live.
you think so?
Oh, yeah, why not? I mean, you know, just put aside the Terminator nonsense and about talk about the AI if you want.
I love this. Let's talk about this.
But I think it's far better knowing. It's always better than is it a better place to live in that I know that our planet is one of many in the solar system, one of many in the galaxy? I think it's more. I sometimes think like, God, what would it be like 300 years ago? I'd be looking at the sky and I can't see anything. Oh my God, I'd be like going to bed at night going, what's going on here?
Well, I mean, in some sense, I agree with you. It's not exactly sure. I'm also a scientist, so I share you, but I'm not. We're like rolling down the hill together.
What's down the hill? I feel we're climbing a hill.
Whatever.
We're getting closer to enlightenment.
Whatever. We're climbing. We're getting pulled up a hill by our curiosity.
We're putting our curiosity, we're pulling ourselves up the hill by our.
Yeah. Okay. But okay, our side turns out Harris, Musk, existential threats of intelligence.
I'm not worried about existential threats. There are some worried about privacy, about how it impacts multiple people in the world, and people problems that worry about ways that are. And that will continue as we create more, especially the whole issue about making intelligent weapons. And really, I don't think of those as existential threats. I think those are kind of threats we face, and we have applications here, and the idea of talking about what people are the threats, but when I hear people talking about them, they all sound hollow. based on ideas. They're based on people who have no idea what it's about. And if they knew what it was, they wouldn't say those. So those are not experts.
So there's two, right? There's one is for intelligence. It becomes far superior in reasoning ability than us humans.
How is that answered?
A lot of what in one way is us humans are actually rational and efficient and get in the way of not happiness, but whatever the objective function is, maximizing that objective function.
Yeah.
For intelligence.
The paperclip problem and stuff like that.
But so the paperclip problem for intelligence.
Yeah. So we already faced this threat sometimes. They're called bacteria. There are organisms in the world that would like to turn everything into bacteria. They're constantly morphing. They're constantly changing to evade our protection. And in the past, they have killed huge loss of population on this. If you want to worry about something that's going to fly endlessly, have it. And I'm far more worried in that regard. I'm far more worried that scientists in the laboratory will virus bacteria that we cannot control. That is a more of an existential threat. It's putting an intelligence on top of it actually make it less existential to me. It's power. It limits where it can go. It limits them in many ways. The bacteria is something you can't see. So that's one part.
The other one, if you're think about intelligence, you think of that as something. If you look at intelligence on a spectrum, 0 to us, you think you can scale that far? Yeah, all the mechanisms.
Yeah, I want to make another point here, before we get to intelligence. It is not the entire brain. The goal is not to make animals. The goal is not to make it don't want to have. And why would I build it? If I want to have a system that wants to have activity, make computer viruses. Bad things. Don't do that. Those are really bad. Don't do those things. Regulate them. But if I just say I want to have an intelligence system, why does it have to have any of the human like approach? Why does it care to live? Why does it care that it doesn't care about this? It's brand, mathematics, or it's out there trying to build the space, work on. That's a mistake. Don't make human-like things. Don't make replicating things. Don't make things that have emotion.
So that's a direction that I share. I don't really share in the sense that you have faith and optimism about us. Here's humans to not.
So this is why I mentioned bacteria. Because well, the person is bacteria. All the so we already have that. We already know that it's going on. It's not a new threat. So let's accept that, and then we have to deal with it, right? Yeah. My point is, if intelligence might apply to a system that wants to think, let's not do it.
And in fact, my dad is a physicist, believes that the reason nuclear weapons proliferated amongst one belief that I share is that not that many that would use bacteria the weapons, or maybe bacteria system bad. Fraction is small. Second is that it's actually really hard.
Yeah.
So the intersection between competent
and by the way, to really annihilate humanity, you have to have the nuclear winter phenomenon, which is not one person, or even you have to have some automated system that detonates a million bombs or whatever many times.
Extreme evil combined with extreme confidence.
And it's just like a really stupid system that would automatically, Dr. Strangelove type of thing. Look, we could have some nuclear bomb go off in some major city in the world. I think that's actually likely. I don't think that's like to be in and be attractive. But it won't be an existential threat. And it's the same as, the virus of 1917, whatever it was, bad things happen, plague, so on. It can't always be friendly, we always thrive. But they're not existential threats. You combine all those crazy things.
So on the spectrum of 0 to humans, do you have a sense of whether it's possible to create several magnitude or at least double that intelligence? Talking about neurocortex.
I think it's wrong to say double. Break it down to components. Can I make something that's a million times faster than a human can? Yes. Can I make something that is a lot more storage than a human brain? Yes. More copies. Can I make something that's different stuff than a human brain? Yes, I can do that. Can I make something that's distributed? So, yeah, we talked earlier about this question of cortex exploding. You don't have to be co-located. Why can't it be all around the place? Those are the levers. But it's more intelligent. What the fuck are we training it on? What is it doing?
So larger cortex and whatever size that allows for higher and higher hierarchy.
Yeah.
Talking about restraints and
context. So could I have something that's just or super mathematician?
Yes. The question is, once you have this, they be able to understand. You know, it would be orders like us compared to.
Do we ever understand it? Most people can't understand. Touchy space. But the field equations that and there's a deep question of really, and I've tried. I get to get special generalist and it. And so we already live with it to some extent. The vast majority of people can't understand actually what the vast majority of people know. We don't have the effort to, or we can't, or we don't have time, or just not smart enough. So, but we have ways of Einstein is spoken in a way that I can understand. We have analogies that are useful. I can use those analogies in my own work and think about, concepts that are similar. It's not like some other plane has no connection to my plane. So that will occur. It has occurred. Has occurred because one would argue that intelligence that takes a billion times faster than us that far we can't make it. But at the moment, everything is really hard to figure out in the world. You actually figure it out. It's not that hard. Everyone can understand the everyone can understand quantum physics. Everyone can understand these basic things. So anybody can figure those things out.
Yeah. So you need to only understand the projection sprinkles useful insights.
That was my example of Einstein, right? It's a theory of relativity thing that's very, very, very few. Yeah. What if we do people are also artificial? How bad is that? In some sense. Right. So they already, Einstein wasn't a very useful person. A lot of really crooks. So the other people who work with him. So, maybe they already were sort of this actual intelligence that we live with it already. It's not a problem.
Do you think we are the only intelligent life out there?
I would say that intelligent life has and will exist elsewhere in the universe. I'll say that. There's a question about contemporaneous intelligent life, which is hard to even answer. Can't say what exactly at this time, someplace else in the world. But I think I do worry a lot about the filter idea, which is that perhaps don't last very long. So we haven't been around very long. As a technological speaking, we've been around for almost nothing. And we don't have any data point on whether it's likely that we'll survive or not. So do I think that there have been intelligent life elsewhere in the universe? Almost in the past, yes. Does it survive for a long time? I don't know. This is another reason I'm excited about our work, is our work in general world. I think we can build intelligent um, that outlast them. They don't have to fly to Earth. Have to, I'm not saying they're recreating, aliens. I'm just saying, if I ask myself, I have a good point to end on here. If I ask myself, what's special about our species? We're not really, we're not, we don't fly, we're not good swimmers, we're not very fast, we're not very strong. No brain, no everything. And we are the only species on the planet with the model of the world that is beyond what we can actually. The only people who know about the far side of the moon, the other universes, all the galaxies, the stars, and about what happens in the atom. No, that knowledge doesn't exist anywhere else. It's only in our head. Cats don't do it, dogs and humans don't do it. That is what we've created that you our genes knowledge. If I ask me what is the legacy of humanity, but what should our legacy serve our knowledge in a way that's beyond. And I think that has to go along with culture. It's a very broad idea, but we should be thinking, I call it a state planning for humanity. Think about what we want to leave behind, one as a species for normally. And that'll happen sometime, sooner or later.
Understanding intelligence, being intelligent, a better chance along.
It does give us a better chance for long life. It does give us a chance to live on other planets. But even beyond that, our solar system is here one day. I don't know. I doubt we'll ever be able to travel all the stars, but we can send it to.
You have an optimistic, a hopeful view of our knowledge of the echoes of human civilization being through intelligence.
Well, I think it's something special for bringing it beyond Earth, or making it pass beyond humans themselves. So,
how do you feel about that? It won't be human.
What is human? Our species are changing all the time. Human today is not the same. What is human? Hear about our genetics? Why is that important? As I point out, our genetics are no more interesting than about two. No more interesting than genoma. But we have what's valuable is what we learn about the world. And that is the rare thing. That's observed.
The knowledge.
The knowledge.
That's a really good place to end. Thank you so much.
It's good fun.
Following this conversation, John Carroll, theoretical Caltech, specializing in quantum mechanics, gravity, cosmology. An author of several popular one on the arrow of time, eternity here, one on the Higgs boson, particle in the universe, one on science and philosophy, big picture, the origins of life, meaning, versus. He has an upcoming book on quantum mechanics, pre-order now, called Something. He writes one of my favorite blogs, website, philosophy.com. Recommend clicking on the greatest accessible post. Time, dark matter, dark energy, bang, general relativity, theory, quantum mechanics, and the big meta question about the philosophy of science, God, politics, and much more. Finally, and perhaps most famously, host of a podcast Carlin's Hardcore History. John's Mindscape podcast. One of my favorite new ideas, different perspectives and ideas that I thought really honor hours of show. It's a heartbreaking thing. It's the first time ever audio recorder for the podcast died in the middle of a conversation. Technical reasons having to spend the power that I now understand. 1 hour to so like the universe is percent dark. Roughly that reason people fall I know. Sure talking again. On this podcast show. Of course, artificial intelligence podcast. But subscribe on iTunes, support on Patreon, Lex. Now here's my conversation. John, what do you think is more interesting in fact understanding the fundamental level or understanding how to define?
Of course, the crazy meaning unanswerable question in some sense, because they're both very interesting scales. You break them on, there's a good answer brain is hard to right? Therefore, the versus more fundamental brain.
Really believe that once you understand the fundamental way that the universe works at the particle level, of course, it understand mind works.
Yeah, certainly not. We cannot understand how understanding particles, right? So I'm a big believer in emergence. I'm a big believer that there are different ways of talking about the world. Just the most fundamental microscopic one. About tables and chairs, planets and people. We're not talking language, particle physics, cosmology. So, but understanding the universe, he didn't say just at the most fundamental level, right? So understanding the universe at all levels is part of that. I do think if there is a question, there probably are general principles of complexity, biology, information processing, memory, knowledge, creativity that non just the brain. And maybe one can count understanding the part of understanding. Brain, as far as we know, is the most complex thing. So certainly third the understanding of fundamental laws of particle physics is a major brain.
Then there's this fundamental particle. There's a lot of philosophers carelessly take what artificial intelligence. So, first, as a kind of a computational device.
No. The honest answer there is no. The sense in which the first theory, the sense like a computer, but sometimes I think I tried to say this I will agree with me, but the universe is more like a computer than a computer. The universe happens once. Computer is a general purpose machine. That's a different question than talking about, right? And it's set up to answer certain questions. The universe isn't that. So information processing happens not what the is. And I know your MIT colleagues are different about that, right?
Well, you're thinking of the universe as closed. So what makes a computer more like a machine? Human once comes up with a mouse around it, is it simple? And that's what you're saying is complicated, deterministic. Is not like a process. Because there's a sense for a lot of people that the brain operates in our world, and it's a small subset. Well, no, we can't arbitrarily.
Yeah.
Things go into
intelligence. They don't have a. And so I remember this panel discussion universe computer claims that smart reason. So what is not? And that's like that's a question. Sure, because you have a broad definition of what a computer is, everything is, right? And the analogy came worse when it was the surrounding performing a computation. I can come up with definitions which the answer is yes, but it's not very useful. I think that it's absolutely helpful to think about the context as information. I'm guilty of writing a paper called Quantum Circuit Cosmology Modeled the Whole Universe as a circuit, yeah, and right, yeah. So it's becoming more and more entangled. So I digress a little bit. That's fun. So think about the what we talk about, and we talk about the region of degree with these integration. That number is arguably finite. No, have a very good argument. As the universe expands and space gets bigger, but if there's more degrees of freedom, an infinite number doesn't look bad. Then space with more degrees of freedom, where did they come from? Well, honest, more degrees in popping into existence. Well, we suggested was there are more degrees. Not that they're not there, they're not entangled. But the universe that I know of, or the creatures around us, that those are the entangled that make the space universe expands. There's a whole bunch of their zeros that become entangled with the rest of space-time to the action.
So that's now more freedom become more intense.
Yeah. So
as a
that's right. So 4 degrees are entangled, apart, playing the role of parts of basic the underlying time itself arises from the entanglement of
okay. So yeah. At which point most of the we're talking about the time of relativity.
the idea is that at the Big Bang, the universe could have were there, but they were unentangled. And that's a reflection of the fact that the Big Bang had a low entropy. As space expands, more and more become entangled.
Well, I have to answer on Carol. But what do you think of the thought experiment in Boston? So I think let me contextualize that a little bit more. I think thought experiment. I think it's quite interesting. It's not very useful, but it's quite interesting. From the perspective of AI, a lot of learning done happen more examples. The constructive question to ask, how is our root of growth right? Kind of a dual part of living relation. Somebody or to try to self harm.
So obviously one possibility. I don't think that we actually so take this one data integration. Big universe. Okay. There's billion galaxies, stars in galaxies. It would first that big self-conscious. So in other words, I want to be a good Bayesian. I want to ask under this hypothesis, what do I expect? The first second the evolution of the universe is example that if the simulators only have finite resources, but they don't render entire universe, right? That the part out there, the billion galaxies, isn't actually being simulated. Then the obvious extrapolation that only I am being well, the rest of you are just parts, non-player characters, right? I'm the only real, the rest of you are just beyond the wall. I see the wall, but there is literally nothing on the other side of it. That's Bayesian prediction of what it looks like with it. So none of that right realistic is. I hear the argument that it's just possible, like I don't think about our universe like a maybe I don't know. Your job is to say under this theory. Yes, it's the same. What's in video game where, but entire all the entire closed system, quote unquote, had a creator. Yes, possible. That's not you about when you talk possible. Okay, I lived for a while. Well, yeah, but I guess the question is, how hard is it? I wrote a little blog post about this, and it made me think I'm missing. But the argument is not only it might be possible to succeed, but probably imagine you actually contribute consciousness to the things that we're simply artificial being. There's probably a lot more of that in our ordinary being. There will be. So this not only is stimulating it's in consciousness, most of them are. I think the argument must but it follows that argument. We're simply stimulate other well, but if we can stimulate others, they if we give them enough power and resolution. And ultimately the bottom. Well our universe have a bottom. So there will be the possible simulation. And if you believe the original argument, we should be in it. That's what most people but we don't. It doesn't look at all like we're at the edge of resolution. We're much easier, much lower level. So, and also I think question the whole the anthropic principle. Your typical person that's not actually a lot of reflection do or over things. No, not typically. So there's intelligent life, however you like to define intelligent life out there. My guess is that not intelligent life be on the basis of the fact that likely number of other intelligent species universe, likely number 0 per billion. And if there have been billions, you would notice. For there to be literally like a small number, like Star Trek does it intelligent in our galaxy, but not. That's weird. That's sort of bizarre to me. It's easy for me to imagine that there are 0 others, some big bottleneck making multicellular life, biological life, or whatever. Very hard to imagine. There's a whole bunch out there. Somehow. The intelligent life. What I mean by that question, where's it going? What if intelligent life is in some very big power? There's all kinds of life that operates in different scales and size and great possibility. technology and everything melting. Maybe versus coal, that's that old thing. And I think the thing when you're pointing at it, even more out there, you know, intelligence in molecular cloud, or resolution fronts are things where the so one hand, yes, we should be very open about this. Other hand, all of us hear the same one. There might well things that we don't that make leaders and here's right like it, but created Adam, Adam said a certain high, so certain lifetime. It's not impossible. There's a super intelligent mind. So I don't have a mind that's either way. I don't find either humble, there's all sorts of different kinds of mind, or no example I like ours is
Yeah, I often wonder, mind, quite obvious times skills, almost blind, and the tools created are blind. Yeah, kind of observation, intelligent mind for others.
well, totally that. But here's another argument to make. We when we looked at in the dumbest way by turning radio telescopes, and why in the world for advanced civilization and without radio in all directions in the universe? That just doesn't make any sense. Especially because in order to actually contact another, you have to do it forever. You have to keep doing it for millions of years. That sounds like a waste of resources. On that, there were other planets around them where maybe intelligent life didn't yet exist. Like someday, you wouldn't try to at this target. Like from our point of view, 2001. There's wow, could be the artifact. In fact, it would work also, right? Could be artifacts that are been put there by other technological advances. That's we had just had the voice published fine. The reason why we don't think about that is that we're young and impatient, right? Like it take more than my life actually have something back. So if we think hundreds of thousands of times
Guided by the thing that Elon Musk is, that's general the idea. Even though you're
yeah. So I do think that space travel is even to other stars. And I think that many people overestimate the they say, look, travel 1% of the star system, and I think it's much easier, and therefore, right there, science fiction is imagine fashion, otherwise, right? We're not doing fashion, but we easily imagine. Once you do that, stars are much closer, right? And what's 100 years, right? So I think that that's part, not lifetime yet, but 80 steps. Less. Well, it's in a race against time, right? A friend of mine who actually thinks about these that you and I are going to die, but I don't know if it'll be in the future is far. That's and so yeah, no, I think that there are threats to the earth, known and not unknown, right? Having spread biology is a kind of question.
science not really. I think it's a lot of problems.
It obviously
how they
Well, I've talked to people on podcasts about this. Life requires freedom. Life as we know it. Because there's a difference in life. Life is what life as we know it requires compartmentalization. That brain around metabolism, but that, and then replication. Okay, it has some information about who you are. That you have that. In the lab, compartmentalization is pretty easy. Not hard to increase the supply layer. I mean, cellular walls. Metabolism and replication are hard. Replication is very close to RNA-like molecules. I think state of the art is not able to make one molecule but they're able to make another. Okay, that's pretty close. Metabolism is hard. They're not even obvious things. Metabolism, the cellular machinery in our body is quite complicated. Existence by itself. But it's I don't think we're spending nearly enough money on it. If I were NSF, blood very money change our world if we could actually and have was originally here to have some more facts that help on that. So synthetic biology is wonderful here making cells. Right now, that tomorrow has biology, right? Craig Beckner years ago created artificial cells. All he did was not all he did, it was a great accomplishment, but all he did was take out the DNA from the cell and DNA and let it boot up.
What about the creating intelligent life on Earth? However, again, by intelligence, of course, but they almost the modern. Do you have a sense of what's involved in that leap? That is,
AI count for the left life.
AI will come. Okay. Yeah, of course. AI will come.
Well, let's say artificial, right? So I do not think we are on the threshold. I think it's possible. I'm not again very educated about how close we are. My impression is not that we're really how little we understand about what it is. So if we don't understand what it is, are we imagining the threshold of making it ourselves? But it's cool, it's possible. So interesting.
I think general consciousness rise how consciousness once consciousness that's off state.
Good. No, actually, I like this idea. We're all, at every time, very much less conscious than we are. I think that plus the idea that you artificial intelligence in a body, right? Body that will help the thinking.
Yeah, I think creating consciousness is both as asking and refusing thoughts out of it.
Could be.
And I mean, that's almost basically, but that's what each other kind of the consciousness, a lot of our ideas that bar involve something that's beyond, it's not necessarily involved the fundamental understanding of how you go from electrons, neurons, cognition.
No, actually, I think that is an extremely good fact. But yes, is yeah, for Kate Darling had on the podcast and experiments with very robots, but they look like animals and it looked like they're experiencing and react very negatively to robots like they're experiencing. And what I want to say is robots things that, by some strict definition, brain test level thing are not conscious. Nevertheless, fucking come on, like there, the cookie picture is in theory is close, right? So it might be there has a lot more like that, and in fact, rather than someday going, aha, we have consciousness, we'll just and here, present example, haven't met before. Basically, as at least at a high point. At the time, because yeah, but in the future, there might be question marks. Yeah, no, absolutely. Certainly, videos, also photos can't trust, right? Videos trust, but it's getting worse. Getting better at taking it, right? Yeah, so a lot of these people work about it. Very depressing conversation. So, I mean, it's exciting. You're doing it, so it's exciting to you, but sobering thought. We're very bad, right? At imagining what the middle of a big transition is.
And I, in general, not blind, but I am excited by the power of technology to protect us from threats. I'm not as much as thinker optimistic about the world, but in everything else, all the brilliant people in the world that I've met are good people. The army of the good of the knowledge part.
Okay? You're way more. I think the good guys are distributed among it. I don't see much of it.
Either was a
Yeah, exactly. Again, opinions are free, right?
more without or without it. So, what kind of question guys not currently answering?
Well, the obvious one is what is good and bad? Right and wrong. I think that's the first question. That if science tells us what the world is, it does. It doesn't forward. It is part of the world. But we are part of the world, and we have the ability to build and if a very long story very short, I think that the idea of moral philosophy is and science might be able to predict ahead of time what people will do, but it won't ever be done.
So, you're kind of unique scientist. It doesn't have to be a podcast, but even just reaching out, refer to sort of reach out, talk to people that are outside of here. I always hope that's what's not. In fact, I was hoping when I realized that academia is very scientific. And the question is how, well, at your own level, how do you prepare for these conversations? How do you think about these conversations? How do you open your mind enough to have these conversations? Maybe a little bit broader, how can you advise not at the podcast, I think doing a podcast is awesome. I hear them, yeah, but it's also good to have a little doubt my project.
Question, but a tough one to answer. I think about a guy I know who's a personal trainer. He was asked on the podcast, how do we psych ourselves up to work out? How do we get that discipline to go and work out? Like, why are you asking me? Like, I can't stop working out. Like, I don't need to psych myself up. So, likewise, definitely, like, how do you like have interdisciplinary stuff, right? Like, that's, I couldn't stop that long. In fact, a lot of the motivation for starting working out was making sure I read all these books that I had purchased, right? Like, I had all these books I wanted to read. Not enough time to read them. Now, I have motivation for the interview virtually. Let me read her book, And it's absolutely rarely. And in fact, when punched, like successful, generally first being very successful within their little bud, right? And see that they start. If educated with them about it. It's, most graduates not faculty members, right? Up the road. And so the life you want to live. It was wise about what it does to your job change. And the more broad you are, the less time you spend hyper specializing in your field, the lower your job. Academic. It's terrible. I don't like it, but it's a reality. And for some, that's fine, right? There's plenty of wonderful, but zero interest branching outside there. But it is disillusioning. Some of the romantic memories I had special fun is belied by the reality. Good challenge other. The positive good so rare. But that said, even though you're saying you're doing it trainer, you can't help it. You're also others. Like for myself, I also have a career I'm thinking about right now. And without your podcast, I may have not have been doing this at all. Right? So it makes me realize that these kind of conversations is kind of what science is about. In many ways, the reason we write paper is it's much harder to do papers. Yeah. Right? And conversations are easier. So conversations begin. And in the AI, that is not the outside of pure computer vision competition, in particular data, about the broader impact of how the technology, neuroscience, having inspiration. So thank you very much. Never know how the world changes. The fact that this stuff is out there, and I've huge number of people come up to me, congrats, really loving the podcast, inspired by it, probably have that ripple effect. And then on a balance, off, thank you. Alex, thank you very much. Following is a conversation. Chairman, no, venture, managed dollar, dual currency investment fund, focused on developing next generation Chinese high tech company. Former president of China, founder, now called and trained many of the artificial intelligence in China. Knows for AI text Baidu, Alibaba, Lenovo, Huawei. Named one of the 100 influential by Time magazine. The author, 7 best-selling books, Times best-selling called AI, China, Silicon Valley, and the World of Order. He has unparalleled experience working across major tech companies, government, and applications of AI. So, it's expected on global innovation AI. I think artificial intelligence podcast. Subscribe on YouTube and iTunes, or on Patreon. You can me. Now, here's my conversation. I've immigrated from Russia, West, immigrated to the US at about the same age.
Russian people, the American people, Chinese people have a certain spirit that permeates. So maybe it's a little bit like you describe your sense of the Chinese. I think the Chinese stole a thing, right? We're talking about people who have had centuries of burden because of poverty country through suddenly trying to of prosperity has up and embrace the economy. Um, Undoubtedly, there are excessive pressures on people that of ambition, that of education, and that of hope of wanting to become that it's a very strong hunger and a strong desire, strong work ethic that drives and is there not just generation or that's deeper than just new economic development. Is there something that China that's well, Chinese tradition is about excellence, dedication, and Chinese can study subjects slowly started from memorizing 10,000 characters, not even start with, and further by memorizing historic philosophers. So it really is probably the strongest rote learning mechanism created where people have good memory and everything well. That's, I think, at the same time, suppressing race um, and also enhancing speed, execution, it results. And that characterizes historically. It's interesting because there's echoes of that in Russian education as well. Memorize a lot of projects, like the perfection in all forms. That's not perhaps with creativity. But you think that kind of education back to the day that you might see in the United States? Well, it holds back, breaks innovative spirit that we does not hold back the valuable execution oriented, result oriented, value creating, which we kind of. So there are differences Chinese AI engineer today and an American AI, perhaps rooted in the culture, the love of education, the very soul of people, or no? What would your advice be to well, there's a lot that's similar. AI is about mastering science, about known technology, science, but it's also about thinking from many parts of possible network and parameters. And that part is somewhat broad. And also, as anyone who's built AI products will tell you a lot about cleansing data. AI runs better with it is generally unstructured, errorful, and unclean, and data is immense. So I think the better part of America AI is trying new things people haven't done before, and use technology to solve most, if not all, problems. To make the algorithm work despite not so great find error tolerant way. The Chinese way would basically operate to the fullest extent all the possible ways by lots of different ways to get it to work and spend a lot of money and time cleaning up that the AI engineer may be writing data cleansing algorithms, working with thousands or correct or that's incredible hard work that might be I ask for more and more
data and find ways to cleanse probably less time thinking about algorithms that can overcome data or other.
Where's your intuition? What do you think the biggest impact that yours lies? Is it in some breakthrough algorithm, or is it in at scale rigorous approach to cleaning data, organizing data onto? What do you think the big impact lies for all this?
Well, if you're really in a company and have to deliver results, using known data and enhancing data seems like a more immediate approach that's very low risk and likely to generate better. And that's why the Chinese done quite well. Now, there are a lot of more challenging startups and problems, autonomous vehicles, medical diagnosis, that algorithms probably won't solve. And that would put the Chinese approach more challenging and more innovation approach more of an edge on those kinds of problems.
Let me talk to that a little more. So, my intuition personally is that data can take us extremely far. Brought up autonomous vehicles and diagnosis. Your intuition is that huge amounts of data may not be able to solve that problem.
Right. So breaking that down further, vehicle, I think huge amounts of data probably would trucks driving on highway deliver significant value, and China will probably and L5 autonomous is likely to require new technology, and that might require academia and great industrial research both together as the U.S.
Interesting question there is. I don't know if you're familiar on the autonomous space development and where they are in fact ahead. It is complex world of autonomy and they're trying to solve that purely the same kind of thing highway. A lot of people carry your trying to run that moment further. Them to test training on education basis, urban environment, not just highway.
I think it would be very hard. One could characterize Tesla's approach to kind of Chinese gather all the data you can of the problem. But in autonomous driving, clearly a lot of aren't nearly solved by aggregate data having impact. There are that are akin to, and how would those be integrated has not yet been thought of human intelligence or call it expert. We don't have a word with learning. And types of hasn't been demonstrated and how much you push a purely learning approach. And of course also has an additional constraint that we don't have all the sensors. I know that the LiDARs really one less very valuable input that they may also. I think the advantage is capture that no more. Some cases as computer vision, recognition. I have similar data in the Western world. They have superior. But then speech recognition, object recognition are relatively helpful. Don't have human intelligent analytical planning.
Same on recognition side, your intuition that speech recognition, learning approach, recognition won't take us conversation has to learn that. So and for what driving have something more than simple language things.
Roughly exactly right. I would say that based on purely learning, hard to imagine could a full conversational experience across other things. I'm a little hesitant toward Turing test because the original definition probably probably that spirit of the Turing. That's what I was, of course. So you've had major shifts, Apple, Microsoft, continuing on the discussion of America, Russia, culture, and so on. What is the culture of Silicon Valley in contrast to China and the US broadly? And what is the culture of the I think in aggregate, Silicon Valley companies, probably include Microsoft, in the Valley, is really dream big, visionary goals, and believe that technology will conquer all, and also self-confidence and self-entitlement that whatever they produce, people should use. Um, those are historical, I think, jobs that doesn't focus there, the person what he wants. And that really is an informational comment that asks you what they want, but develop something that you will know want when they see it, they could never come up with themselves. That's the most liberating description of what Valley is. That brilliant idea could cause you to build something that couldn't come out of focus group or A/B test. And the iPhone is an example of that. No one BlackBerry write down there was an iPhone or multi-touch browser might be another example. No one would that, but once they see it, they want it. So I think that is what Silicon Valley success. But it also comes with came with a lot of success products, global platforms. There were basically no competitors anywhere, and that has also led to a belief that these are the only things that companies do not tread on other companies' territory, so that you know, on and a Yelp and an Open Table, Robot. Okay, I'm not going to say other companies because that was not the pride of innovating. Whatever each of these four companies have innovated, but I think Chinese approach is whatever it takes, and it's a winner-take-all market. And in fact, the market leader gets predominantly all the value extract out of the so, and the isn't defined as one narrow category, but it's broader and broader. Ambition or success, domination of increasingly larger product categories, clear market winners, and opportunity to extract tremendous value. And that develops a result-oriented, ultra-ambitious, winner-take-all, gladiatorial mentality. And if what it takes is build what the built, copycats that can be done without laws. What it takes by a foreign country by forking the code base into something that looks ugly and different, they'll do it. So contrasting very sharply with the Valley approach and the flexibility and execution how the approach. The Silicon Valley approach um, challenge is every Chinese entrepreneur is learning the whole world, US and China. The American entrepreneurs are only looking internally and write off China. And the second part of your question about the company, you know, people represent cloud their, their the essence of design and brand and the one company and perhaps the only tech company that draws people with a um, strong, serious desire for the product and willingness to pay a premium because of the halo effect of the brand, which came from the attention to detail and great respect for Microsoft represents a platform approach that builds giant products that become very strong moats that others can't because it's well architected at the bottom level and the work is efficiently delegated to individuals and then the, the whole product is built by adding small parts that come together. So probably the most effective high-tech assembly line that builds very good products. And the process of doing that is kind of a differentiation and something that is and
Are there elements of the Chinese the way Microsoft went about assembling those little pieces, dominating, essentially dominating the market for a long, long time? Or do you think this is the thing?
I think there are elements that are the same. I think American companies that had or have Chinese characteristics, obviously as well as American characteristics, are Microsoft, Facebook, and
Yes, Amazon.
other companies that will go after build up strong product offering and find ways to extract greater value from a sphere that's ever increasing and they understand the value of the platforms. That's already. And then with Google, I a genuinely value oriented that does have a heart and soul and that wants to see the world connected and that has also very strong technology and wants to use technology and has found out of the box ways to use technology to deliver incredible value.
Look at Google, for example. You mentioned heart and soul. Element where Google, after making the world better, with the most positive view, they used to have the slogan, and Facebook a little bit more has a negative, and we perception of privacy and so on. You have a sense of how these different companies can achieve. You talked about how much people better in all these kinds of ways with AI. What is it about a company that may give it a heart and soul, gain the trust, actually not
Really hard, and I think Google has struggled with that. First, don't people contract every employee definitely different, and that has led people that put situation for them. So I don't necessarily think that's a good value statement, but watching the kinds of Google or the company Alphabet does area of healthcare strategy not in a internet tech company. And that shows that there is a heart and soul desire to do good well put in something when they see good they will pursue it. That doesn't necessarily mean it has all the trust of the I realize while most people in Facebook as the primary target that they're having about Silicon Valley company, many of them category, and some have named those practice um, predatory also. So it's kind of difficult to have the parts of the body brain wants to do what for shareholders.
concerned about future where companies like Facebook, Amazon are controlling our data, controlling too much our data lives. Elaborate on this concern and perhaps you have a better way forward.
I think I'm hardly the vocal complainer. There are a lot louder complainers out there. I observe that having a lot of data does perpetuate strength and many spaces. But I also believe AI is much broader than the so entrepreneur in high power, financial, health, manufacturing. I don't think it's quite a case of full monopoly dominance that totally stifle. But I do believe their areas of strength is. Don't know if I have a good solution. Probably the best solution is that entrepreneurial ecosystem work well and find all the places that create the next role, the next thing. So there will always be increased number of challenges. In some sense, that has happened a little bit. We were having emerged by the and I think China as an environment may be more interesting to merge it. If you look at companies between, let's say, to $300 billion, China has emerged more of such companies than the last 3 to 4 years because of the larger marketplace, because of the more fearless nature of the entrepreneurs. That and Chinese giants are powerful as American ones. Tencent, Alibaba are very strong, but ByteDance has emerged worth 75 billion and financial, while it's Alibaba affiliated, nevertheless independent and worth 100 billion. And so I do think if we start to extend, we'll see a very valuable company. So it's probably not the case that 5 or 10 years in the whole world, 5 companies.
There's mentioned a couple times the fascinating world of entrepreneurship in China. Fearless entrepreneurship. Can you talk about what it takes to be an entrepreneur? What are the strategies that are undertaken? What are ways to achieve success? Dynamics we see of funding, government help, or what's the interesting aspect here that things that are different from Silicon Valley?
Many of the still ran Chinese entrepreneur as copycats. And no doubt, 10 years ago, that would not be an accurate description. Back 10 years ago, an entrepreneur probably could not get funding. He or she could not describe what product copy from the US. First question, who has the model? A nice way of asking for copy. And that reason is understandable because China had a much lower internet penetration and didn't have enough indigenous experience to build innovative products. And secondly, internet was emerging, startup way to do things, the first viable products and expanding right to go. And the Americans tested even a shortcut that if you build your minimally viable product based on an American product, it's guaranteed a decent starting point. Then you take it afterwards. So as long as there's no IP infringement, as far as I know, there hasn't been in the mobile AI space. That's a much better shortcut. And I think Silicon Valley would view that as still not very honorable because that's not your own idea to start. But you can't really, at the same time, every idea must be your own and startup methodology because many things and then converge one that works. And meant to be iterated. So finding a legal violation, there should be nothing morally dishonorable about that.
Pause on that. Fascinating that's why is that not honorable? That is formulated. It seems like a perfect start for business. If you take look at Amazon and say, okay, well, exactly what Amazon is right there. How innovate them starting yes. I mean, is it wrong to be copycat just sounds bad? Is it wrong to be a copycat? They just smart have a heroic
Yeah.
uh jobs
Yeah, I like the way you describe it. Non-heroic, acceptable way to start a company. And so that's I think it's a baggage out. And if it doesn't let go, then it may limit ultimately the company. Example, I think Evan's brilliant, great products, but very only under while copied and you don't have that product. Not just Chinese environment, copy really of the way learn from the American master. It's like we learn piano or painting. Start by copying. Don't start by innovating. You don't have the skill set. So very amazing entrepreneurs. 6 years ago, started to branch off with lean startups, American ideas, build better products, American products. But they did start from the American idea. And they WeChat is better than WhatsApp, Weibo is better than Quora. That I think is Chinese entrepreneurs going to step these entrepreneurs have done one or two companies. They now look at the Chinese market and the opportunity and come up with ideas that didn't exist elsewhere. Products like and financial, such as Alipay, which is mobile payment,